or reconnaissance or discovery. It all means the same thing to us. It's, to me, the crucial stage of pen testing. So allow me to identify this phase like this. It's a phase in which we will extract information regarding the target that we're attempting to hack. And then this information can be anything directly or indirectly about the target application or the customer. Remember the video about attack surfaces? When doing a web pen test, we need to explore all the possibilities of breaking into the web application. That's why we need to know about the application, database, server, as well as the users. So the more information we gather about the target, the more options we will have while we're testing. Now, to be more specific, this phase includes identifying the IP addresses, subdomains, and related information, accumulating information about the target website from publicly available resources, such as Google, Bing, Yahoo, Archive.org, and Shodan, identifying people related to the target with the help of social networking sites, such as Facebook or Twitter, spidering the web application, and creating sitemaps to understand the flow of the application. You really should consider any information gathered at this stage important, because even a small bit of information that looks like it could be nothing may help you exploit in the later stages of the test. The success of the penetration test depends on the quality of the information gathered in this stage. Cool? Domain host related info. So the conducted web penetration tests are generally close to black box testing, as we mentioned before. So we don't have, well, hardly any information about the target, if any. Maybe just a URL, IP address, or a domain name is given to us. So to start testing and gathering information, we'll need to dig around an URL, IP, or domain name. No problem. So in this section, we're going to first extract domain registration information by using the Whois service. Then we're going to use the extracted information to get subdomains of the target, and even the other hosts in the network. And then, if it's possible, we're going to discover the applications that are served on the same server or same service. All right, so let's start with the Whois service. When registering a domain, the domain owner needs to provide his personal information to the domain registrar, such as name, phone number, other contact information. And all this is public information due to the nature of the Whois service. So that means that you can view the name, address, phone number, and email address of the person or entity who registered the domain. If you query the registrar Whois service, you can get this information. But sometimes the registrars can hide this if they have a service to change the owner information with theirs. Whois records and holds the registration details provided by the domain owner to the domain registrar. Yes, I say Whois. Whois is a protocol that works on port TCP 43, and there are multiple Whois servers on the internet around the world. These servers are operated by regional internet registrars, so they are used to extract information about the domains and the associated contacts information. Okay, so open your terminal in Kali, and thanks to our developers, Kali has a Whois client, and it's very easy to use. Okay, so type Whois to see the help file, and we're going to use that. So let's think of google.com as your target domain. And you got to wonder about Google's registration info, right? So type Whois google.com and hit enter. Okay, so this is the output for this domain. It's long. So scroll up. And as you're seeing this with me, the registrar for this domain is Mark Monitor. The dates of validity period are also displayed. The output of a Whois query also points out the DNS servers for google.com. And those will help us to find additional hosts in the domain. So now I will run another Whois query. But first let me get the google.com IP address, hostgoogle.com. And the host command performs a reverse IP check. So when you give the domain, it returns the corresponding IP address. So type whois-h-whois.erin.net. Now I will copy this IP address. With the H parameter, you can point to a specific whois server to query. So hit enter. And again, you get a long output. But it's got a lot of information, such as network range, phone number, and address. So whois queries are very handy to originate a domain name. There are also online whois services, and you've probably had a look at them. You may want to look at them again. Now, once we get the authoritative DNS server address by using whois, we can identify any additional hosts in the domain, such as FTP server, mail server, and so on. If there are any other services in this domain, we can also extract information from them. Now, another way to discover subdomains and the host is to query search engines, and then you can compare the results. Okay, so here you might be confused about host and subdomain, so let me give you a quick explanation. If you think of the address x.example.com, now x is the subdomain of example.com. And x.example.com be a host if it is connected to an IP address and resolves to a computer when one goes to x.example.com. Cool? So anyway, there are multiple ways to extract additional host and subdomain information. So that means there's lots of tools out there for us to use on this purpose. And I'm going to use two tools that are already present in Kali, Fierce and the Harvester. Now, Fierce is a really cool tool. Besides that, it uses brute force methods to get subdomains. Also, after it finds a valid host, then it performs a reverse lookup to uncover additional hosts. And here are the options for Fierce. Okay, so first we're going to run a basic scan. So type fierce-dns google.com/threads10-file/root/desktop/googleinfo.txt and hit enter. So the DNS parameter specifies the domain that you want to scan. So in our example, it is google.com. By default, Fierce runs in single thread mode. So because of this, I can add the threads parameter to increase the speed. So that makes the scan run faster. And then the file parameter helps us to save the results to a file. And now while scanning the hosts or subdomains, what happens in the background? So Fierce first tries to find the DNS servers for the target domain. And next, as I'm showing you on the screen, it attempts to do a zone transfer. Now, at this point, if a zone transfer is successful, Fierce will stop running. And then you can take that information that you got from the zone transfer. Now, if zone transfer fails, as it has in our scan, it checks if wildcard DNS is enabled. And then it performs a brute force against the domain using its built-in word list. Okay, so now the scan is complete. And as you can see, once the scan is finished, the found subdomains and discovered subnets are listed. We can also view and save the file, but the content is not that different. In fact, it's not different at all from the output on our screen. It just makes it convenient. And by default, Fierce uses its own built-in word list. But it also provides the ability to use a custom word list that you can build. And sometimes different word lists can uncover new subdomains. So the second tool is the Harvester. It is another subdomain scanner, and it gathers public information such as employee names, emails, subdomains, banners, and other similar information. But for now, we're just going to deal with subdomains and host. And type the Harvester, and you'll see options. Now, it's quite easy to use this tool, so let's just run it quickly. Type the Harvester-D and the domain that you want to search. So in my case, of course, it's google.com. It might be strange because I will be using Bing to search for google.com. But by using the B parameter, you can provide a data source. L parameter limits the search output. So the harvester will analyze the first 500 search results of Bing about google.com. And finally, the F parameter helps us to save the result to a file. Okay, so hit Enter to run. And first, the search is conducted. Then it will analyze the result. Okay, so here's what we expected to see. So now, go to the saved file directory. I'm going to go to the desktop, and here's a file. So let's have a look. So it's not very different from the output that's on the screen, but at least we can have smaller graphics. Great, so you can run these tools, or some other ones if you wish, for your target. You can go ahead and practice that. Now let's have a look at applications on the same service. So this is not just all about the target domain. Because in general, while we're conducting a penetration test, we say the URL to the address of the web application. And especially in an intranet network, it's quite often to see unusual URL addresses. In the port and service detection part, I'm going to show you a couple of things. But sometimes you will see just an HTTP service on a port with different applications. And URLs may be in the form of http://domain.com/app1, app2, etc. So in a situation like that, you'll need to detect these applications to get extra information about your target. There's really no tool to use in a situation like that, so you will have to manually discover these kinds of applications. Ports and services on the web server. Web applications are generally served on ports 80 and 443, but it's not limited to use just these port numbers. Port numbers are configurable, so it's not uncommon to see a web application served on a non-standard port such as 8080. Okay, so basically a URL or an IP address will be provided to you if you start a penetration test, but sometimes, due to your contract, you may need to run a black box testing approach with nothing. You wouldn't even have an IP or a URL to get to test. In both of these scenarios, you would need to identify and then map the target network in some level. So the first thing to do is to identify the target network with whois. So we've already done that. The second thing to do is to map the network. And that's what we're going to do now. And we will use Kali Linux. It's got a great tool in there to help us out. Nmap. So Nmap is short for Network Mapper. It's a powerful open source network scanning tool, perfect for conducting reconnaissance and enumeration. So here we are going to benefit from Nmap. So now open up your terminal in Kali and type Nmap. You can see there are a few options. Nmap can perform many tasks. It can identify live hosts, scan TCP and UDP open ports, detect firewalls, get service version running in remote hosts, and even with the use of scripts, find and exploit vulnerabilities. So, why don't we just start with a basic scan? So at this point, let's assume I was given, or I have found the target IP or URL. So I'm going to use bbox IP address in the examples. Simply type nmap 192.168.204.130 and hit enter. And here's a basic scan. So Nmap will scan the target IP with its default options, and the result shows the open ports and corresponding service names running on these ports. So now let's touch on some of these other parameters to perform a detailed scan. Now, Nmap has several approaches for scanning open ports. It sends raw network packets to several TCP or UDP ports of the target and checks to see if there's a response. And if there is, depending on the type of response, it will define the port as to whether it's open or not. And remembering that HTTP uses TCP for transmitting packets, Nmap will play with these packets, and then different scan types come up. So, a regular TCP connection between two IPs is called a three-way handshake. So first, a sign flag reaches the destination, and then it sends the sign ACK flags back to the source. Then the source sends back the ACK flag to start the data transmission. So this is the basic and fully qualified TCP connection, right? So type Nmap 192.168.204.130-SS, and the SS parameter will do the sign scan on the target. So that means that Nmap will not complete the three-way handshake. It's not going to replace the last sign packet with a reset packet. But the result is not going to be different than the first one, because the sign scan is the default option for Nmap. Now, type Nmap 192.168.204.130 and this is a TCP scan if the ST parameter is used. So that means Nmap completes the three-way handshake, and that way Nmap can actually connect to the target port. And then the connection is logged by the server. And the result is the same as the previous one, but it provides a more accurate state of the port. Okay, so you can see that Nmap's a really clever tool. It first identifies the live host on the target network, and then scans the host for open ports. So now let's type Nmap 192.168.204.130 SN, and with the flag SN, you can force Nmap to check to see if the host is alive or not. And then, of course, the opposite is also possible. Change SN to PN, and then this time Nmap will not check to see if the host is live or not. It will only perform a port scan. Okay, so now let's be a little bit more specific about these ports. So you can use the P flag to define a port number, port list, or a port range for Nmap to scan. So here I'm going to give it port 80 and 443. And of course, you can provide service names like HTTP or HTTPS. This time it will find ports running these services. So if you want to scan all the ports, just put a dash after the P. It's going to take a lot longer. But if you're not looking for a specific port, you can limit the number of ports by using top ports as a parameter. It will look for Nmap's top 100 ports. Now, if you only want the open ports, just add the open parameter. The closed port is gone. Also, you can add a reason parameter to display the reason a port is in its particular state. So until now, we've got open ports and the names of the services, right? So thankfully, Nmap can show the software versions running on the open ports. And just add the parameter SV to detect versions. And it might take a little while to run this kind of scan. And here are the results with their version banners. So now you can look for these version numbers to see if they have vulnerabilities or not. And then the last thing that we'll do here is determining the operating system running on the target host. So just add the parameter O to the previous command. And this could also take a little more time. Nmap will analyze the information collected from the open ports and versions and guess the probable OS. You can also use Nmap scripts. And also you can compose your own script by using the Nmap scripting engine. So here are some script names that you can use to help you when you're doing penetration tests. I won't show you how to use them, but simply because I'm going to be using some other tools and techniques for the same purpose. Using scripts is certainly not complicated, and I do advise you to use them. Review technology and architecture information. Now, as we talked about previously, the technology stack behind an application can vary widely. So what that means is in the real world, it's very common to see complex applications everywhere you turn. Different technologies, different vendors, different versions, and so on and so forth. So naturally, these technologies can have vulnerabilities or configuration, shall we say, shortcomings. So, in order to discover these vulnerabilities, extracting the technology information is A1 priority. It's absolutely critical for your career as a pen tester. So that's why we need to detect the type and the version of the server software and the application framework or application platform. This information will help you to shape the payloads that you're going to use and deploy. And it will also bring you the awareness that you need to have about known vulnerabilities, if the framework has any as well, because that's part of your research. So I think that you detect a jQuery library or an old server version which has some insecure functions or vulnerabilities. Yes? What a coincidence, because it just happens to be perfect in order to compromise the application we're about to do. So first, open up your terminal in Kali, and we are going to use whatweb to get some information. So see the options for the tool. And then before using the tool, I want to just tell you a few more things. So it's not hard to detect the server and the framework information, right? You can get this information from the HTTP headers, or cookies, error messages, whatever. So the first place to look is the HTTP response headers. So type whatweb-a3 http://192.168.204.130/bwap/. So parameter A determines the aggression level of the tool. And then the target URL comes up, and whatweb will analyze some HTTP headers for you. It has a very colorful output, and the tool also follows the redirections. So that's a very good feature. And here you can see the server header for the server software information, and the application framework and platform information from the X-powered by header. Now, there may be some other HTTP headers specific to some particular technology, so you always need to look out for the headers. Okay, so now I'm going to just minimize the terminal. Now you can also view headers manually in burp. So open up your browser and burp, and enable Foxy Proxy to send traffic to burp. Now request the login page of bwap. Now we're going to forward the request. And here are the headers. Server and X-powered by headers. So you see it's very easy. However, these headers are configurable. So that means the administrator can easily change these entries from the configuration of the server and application. Or even some security products can do this. That's why you need to dig into the application and the environment to gain more clues about the server, framework, and the platform. So let's say, for example, different web server software can have different HTTP header orders. And then these servers can behave in a different way if you send some malformed requests. Also, you can look at HTTP headers, cookies, HTML sources, file types, and extensions. And the error messages are a great way to detect things as well. Extracting directory structure, crawling. So mapping the application layout and its structure is another very important task. Although there are some single-page applications, the applications you will test can generally consist of multiple web pages. And by multiple, I mean a lot. And these pages can be independent, or they can be linked to one another. There's actually no magic to get the structure. unless you're the actual developer of the application. And that, it's just hours and hours of work. So, the best way to extract the structure of the application is to visit every page and click every link and fill every form. Then, observe all the URLs. So you can manually walk through the application and identify web pages from authenticated and unauthenticated users' perspective. So this whole process is called crawling or spidering the application. Now you might think, and you would be right, that it's not really possible to do everything manually. This really is a time-consuming process. So gosh darn it, wouldn't you just love it if somebody created a tool for crawling, and how about some scripts for good measure? Well, I'm glad you asked. Because now let's go over to Kali and open up your browser and burp. I know if you were raised like me, it's rude, but I'm going to ask you to do it again. Open your browser and burp. Okay, so, sorry. Go to Dashboard and make sure that capturing is active. Then disable master interception from this button. Okay, so see it's off. But in your browser, redirect the traffic to burp by enabling Foxy Proxy. So now, burp will passively intercept all traffic coming from Firefox. Then what we're going to do here is visit pages and click links. See, so that way, burp will create a structure of the application from the clicked URLs by intercepting passively. Right? So I'm going to click on some links here on the page and then log in. Open up a few other pages and okay, that's enough to show you. So, okay, look at the history in burp. So all the requests are here. And, okay, so the aim here is to see a sort of a broad overview of the application layout. So there are a few more things in the step to perform, but I want you to just have a look here. I'm sure that you've heard about robots.txt. I know almost every website uses this file to allow or disallow directories to be crawled by bots. So robots.txt is a file that uses a specification protocol called robots exclusion protocol. Now, it's not really something that you need to consider, but you might want to have a look at it later. But yeah, displaying this file is very handy if you want to see the sensitive pages and directories easily. So, what am I saying? Yeah, go to the robots.txt file of BWAP. And here are some directories that are not allowed. So I'm going to visit each of them. Admin directory, documents, and images. And then, wait, what's this? Passwords directory. Now go to burp. Click Target tab. Click Sitemap. On the left pane, you can see the site structure. And also, there are filter options above. You know, this is great. I hope you get excited as I do. So by clicking Show All, resources like CSS and images, they're all going to show up on the map as well. Now, I think the commercial version of burp will do this task automatically, but I really do want you to, get your hands dirty, as I was saying before. I know it's not the most efficient way, but this is how you learn. So we need something a bit more intrusive now, I should think. So Kali Linux has a number of tools for this job. Dirbuster is one of them. So open up the terminal and simply type Dirbuster, and the GUI will come up. Dirbuster is the directory brute forcer for web applications. So now let's provide the target URL, which is http://192.168.204.130/bwap/. And here's a starting point for Dirbuster. And it will automate the tedious tasks of cataloging the pages within the application. That sounds good, huh? So it works by requesting a web page, parsing through it for links, and then sending requests to these new links until all the web pages are mapped. So then let's increase the number of threads here to 20, and then choose a list, browse. Now there are several lists in Dirbuster directory under word lists. And I'm going to choose the medium directory list. Okay, and click Start. Oh, and another good thing is to identify administrative and test pages. These pages can contain sensitive information and provide entry points to perform attacks, such as a brute force attack. It is also possible to see old and backup files in the directory structure. Don't laugh, I've seen it many times in real-world situations. So, if the old version of the application functions and has any vulnerabilities, bingo, you can own the entire system. Besides that, the folders and files belong to the application, so there may be metafiles and folders of the server software as well as the application framework. And I mean known files and folders such as PHP, MyAdmin, and so forth. So Dirbuster also looks for this kind of stuff. And here, as you can see, it detects Drupal, PHP, MyAdmin, and SQLite. Okay, so at this point, I'm going to stop the scan, and you can take a report. Full text report. Browse where the location is saved, and give it the name. I'm just going to type BWAP and generate report. So now you can go to that folder, and here's the report we saved. So now you can analyze it. Minimum information principle. So let me tell you, there's an interesting belief out there in the development community that they explain everything about the application in detail. Now, it's not necessarily bad, but sometimes this really good behavior goes beyond its good intention. And that means that it provides some important information for a pen tester. So this kind of information sometimes can help us in, well, particularly vital situations. There may be different ways to get this kind of information, but I want to give you a few tips. So the first thing is to read just about all the HTML source files, or at least write your own script to investigate the sources for certain special tags and words. You can find an HTML comment that contains any information about the back end of the application, such as passwords, usernames. That's golden. Also look through the help pages. Use the demo users if the application has one. Now, once I test an application, I can see an unauthenticated help document, which contains an administrative demo user. So it's these types of errors that are, well, decreasing constantly because companies are moving faster and faster to better deployment and better development environments. But that doesn't mean they're not out there. Also, there may be some error and warning directives that are helpful to the general users, such as your password is wrong. See, but for a pen tester, this means brute force a password because you've already got some usernames, right? And sometimes errors are caused in the back end, and those can be directly reflected to the user. And again, for a general user, it doesn't have any meaning. But the hacker or pen tester is not the same as a general user. And now one last thing that I want to mention to you. Sometimes we can observe all the information about all the employees on the website of the company. Seriously, all board members, employees, their phone numbers, names, emails, even way more info than that. And I'm not telling you that that's a vulnerability or you've got to hide this information, but I really think that it shouldn't be that easy to find. Anyway, it really does help for the social engineering purposes. So in the previous video, we talked about crawlers, but don't forget, search engines are the best crawlers. They work almost exactly as we want them to. And they have a huge amount of data about the publicly exposed web applications. See, when a search engine bot crawls a web application, it indexes the pages according to some rules that are associated to the page and its content. They can index almost anything within a website, including sensitive information. So they have a complex working style, and they always update the way they crawl. But at the end of the day, they provide us with so much good information from everything, from error messages to vulnerable files and servers. Okay, so now go to Kali and open up your browser. And for the majority of our generation, Google is one of the first search engines that comes to mind. But it is by no means alone. There are several other search engines, such as Bing and Yandex and Yahoo, and of course, anybody could go on. But we're going to conduct the Google queries to get more. So for the average person, Google is just a search engine used to find text, images, videos. It's even a spell checker for some. However, for pen testers, Google is a very useful hacking tool. So go ahead, type google.com, and you can run Google search queries from this interface. But besides this simple interface, Google has an advanced search functionality. So go to Settings and click on Advanced Search, and you can use this page for more detailed queries. Also, Google Search Engine has its own built-in query language, and I'll give you a list of these search operators. So you can also use these search operators to get detailed results. So in order to benefit from Google more, using these operators can come in quite handily. So let's run some searches with some of these advanced operators, okay? So let's find New York Times subdomains. Type site://www.nytimes.com. So the site command will bring the results that contain only nytimes.com. And the dash before the second site will exclude the results that contain www.nytimes.com. Okay? So look at the number of results. Now, if you add and in URL:/login, it will bring us the results that contain login pages. But be careful. Google doesn't necessarily want us using the advanced search for our purposes. Google will start blocking your connection if you connect from a single static IP. Okay, so it will ask for CAPTCHA challenges to prevent automated queries. So I'm going to fill in this CAPTCHA box. It's always a favorite thing to do. Now look at the number of results. It decreases a lot. Now add or in URL:/signup to bring sign-up pages. So this time the number of results are increased. So you can also look for a vulnerable version of any of the web technologies. So type in URL:/phpMyAdmin/index.php and in title:/phpMyAdmin 2.11. And look at the results. It's going to bring up all of the pages that are version 2.11 of phpMyAdmin. So also we can perform the same search for SQLite Manager. Just type in title:/SQLite Manager in URL:/SQLite/index:/welcome to. And look at that. Here are the SQLite Manager pages. Now, there are a few pages listed, but Google does not only index the HTTP-based servers, it also indexes OpenFTP servers. So if you type in title:/index of in URL:/FTP, OpenFTP servers will be listed. Now, I know you might say, this is not enough. Well, you can go with the prepared queries that are performed by the hacking community. Why didn't I say that before? Because these queries are stored in the Google Hacking Database. Bet you didn't know it existed. Now you do. So open this page. GHDB is also served by Offensive Security. So here, every query is called Google Dork. So you can apply any dork to your target application and server. Just click on any dork. And from here, just click to see the Google search results. And now you can analyze the results. So imagine that a Drupal vulnerability is announced. You can create a Google query to identify the servers or applications that have this vulnerability, or you can check Google Hacking Database to find it and use it. So now the world is up to your imagination and you.
Shodan is a search engine for Internet-connected devices. Shodan gathers information about all devices directly connected to the Internet. If a device is directly hooked up to the Internet, then Shodan queries it for various publicly available information. The types of devices that are indexed can vary tremendously, ranging from small desktops up to nuclear power plants and everything in between. How is it different from Google? The most fundamental difference is that Shodan crawls the Internet, whereas Google crawls the World Wide Web. However, the devices powering the World Wide Web only make up a tiny fraction of what's actually connected to the Internet. Shodan's goal is to provide a complete picture of the Internet. You can use the search parameters displayed in the slide. Country. Use the country code you want to look for. For example, use GB for Great Britain, US for United States, etc. City. Filters the results according to the specified city. Geo searches in a given location. Hostname filters the results according to the host or domain name given. Net searches in given IP or subnet range. OS filters the results according to the operating system. Port searches for specific ports. Before, after filters the results according to the date. Show the results which are before or after the date given. As a plus, you can see the current Shodan scans on ics-radar.shodan.io. Let's try to find out the accessible Cisco device interface in Great Britain. In the search box, search for Cisco and last modified words. Use country. Search the parameters with the GB code. Now you can use the country code in double quotes, otherwise don't let any space occur between the country, parameter, and GB code. When you start the search, you'll see the results in a few seconds. Surf on the results. You will probably face the login pages of Cisco interfaces. You've already found something. You can perform, for example, a brute force attack on the login page. If you're luckier, you can find a Cisco Device Manager interface like the one seen on the slide. It's a good approach to look at the archives or backups of the systems. You'll probably find some valuable data in those archives. The Internet Archive is a San Francisco-based nonprofit digital library with the stated mission of universal access to all knowledge. It provides free public access to collections of digitized materials, including websites, software applications and games, music, movie, videos, moving images, and nearly 3 million public domain books. Web.archive.org is the archive of the websites served by Internet Archive Library. Simply, write down the URL of the target website. You'll see a timetable. If you select a year from the timetable, you'll see the archive dates of the target website in details. On the side, you see the date in which the target website is captured, there in green circles. Suppose that a sensitive data was published on the target website accidentally. A few days later, admins realized the mistake and removed the data from the website. But what if someone has already archived that website with the sensitive data? Select a year, click a date which is in the green circle. You'll see an old version of your target website. That's what the NHS.UK website looked like on the 1st of May 2010. Footprinting, also known as reconnaissance, is the technique used for gathering information about computer systems and the entities they belong to. To get this information, a hacker might use various tools and technologies. FOCA Fingerprinting organizations with collected archives is a tool used mainly to find metadata and hidden information in the documents it scans. These documents may be on web pages and can be downloaded and analyzed with FOCA. It's capable of analyzing a wide variety of documents, with the most common being Microsoft Office, OpenOffice, or PDF files. These documents are searched for 3 possible search engines: Google, Bing, and DuckDuckGo. Here's how you can download and install FOCA. You can download FOCA from the 11 Paths website that is seen on this slide. FOCA is open source. You can download all the sources as well as the executable binary from github.com/11paths/FOCA. However, this version requires SQL Server Express installed on the host machine. So I prefer to download and use the previous version of FOCA, which requires .NET Framework version 3.5 only. It's a portable version, so you don't need to install it. Download the zip file, extract it, go to the bin folder and run foca.exec file. That's it. To work with FOCA, start a new project using Project button on the upper left corner. Give the project a name, enter the website, and choose the folder to save the results to. When you finish filling the fields, click the Create button to create a new project. After creating a new FOCA project, we can start a network scan. From the tree at the left side, select Network Node. Now select the search types. The search types listed on the panel are Web Search, you can choose whether Google or Bing, DN Search, Dictionary Search to perform DNS search using a dictionary, IP Bing to serve the domain names hosted on the same IP address, Shodan and RobText queries, and click the Start button to start the scan. Now we can collect some documents published by the target domain to collect their metadata. From the tree at the left side, select Metadata Node. You're supposed to see a panel similar to the one which is seen on the slide. Select the document types you want to collect, and click the Search All button to start the document search. You can see the documents found under Metadata Node of the tree. You should download the documents to be able to extract the metadata. Right-click the documents you want to download from the menu. Select Download. Now you can extract the metadata of the downloaded documents. You can understand if a document is downloaded from the Download column of the table. Select the documents that you want to collect the metadata. Right-click and select Extract Metadata from the menu. You'll see the results under the Metadata node of the tree. Let's see FOCA in action. Find the 11 Paths FOCA website. On the website, you see a download button which brings you to the GitHub page of 11 Paths. You can find the latest release version of FOCA under FOCA Releases folder. It requires SQL Server Express installed on the host machine. Go back to the 11 Paths website. You can find a link to the previous version of FOCA. Read and accept the EULA and download the FOCAPro.zip file. Extract the zip file. Go to bin folder and run foca.exec file. On the project menu, select New Project to create a new project. Fill the boxes in carefully. And then click Create. Save the project file for further usages. Now we can start a new scan. Select the network node from the tree. Select the search types. On the dictionary search panel, you have to choose a valid dictionary. The default path is probably not valid. You can find a valid dictionary inside the DNS dictionary folder, which is under the bin folder where you found the foca.exec file. Click the Start button to start the scan and let the scan continue for a couple of minutes. Let's collect the documents from the target website and extract their metadata. Select the metadata node from the tree. Select the document types you're interested in. And click Search All button to find the documents. Let the search continue for a couple of minutes. Select the documents that you want to collect the metadata. Right-click and select Download. Select the downloaded documents, right-click, and select Extract Metadata at this time. Look at the nodes under the metadata node of the tree, and you will see the metadata extracted from other downloaded documents. You can examine the metadata of each document one by one, or you can find valuable data summarized under the metadata summary node. Usernames of the owners of the documents, operating system where the document is created, email addresses collected from the metadata of the documents, and more. Maltego is an interactive data mining tool that renders directed graphs for link analysis. The tool is used in online investigations for finding relationships between pieces of information from various sources located on the Internet. The focus of Maltego is analyzing real-world relationships between information that is publicly accessible on the Internet. This includes footprinting Internet infrastructure as well as gathering information about the people and organizations who own it. Maltego can be used to determine the relationships between the following entities: people, names, email addresses, and aliases; groups of people, social networks; companies; organizations; websites; Internet infrastructure such as domains, DN names, net blocks, and IP addresses; affiliations; documents and files. Connections between these pieces of information are found using open source intelligence, OSINT techniques, by querying sources such as DNS records, WHOIS records, search engines, social networks, various online APIs, and extracting metadata. Maltego provides the results in a wide range of graphical layouts that allow for clustering of information, which makes seeing relationships instant and accurate. This makes it possible to see hidden connections, even if they're 3 or 4 degrees of separation apart. You can download the Maltego CE, that's the Community Edition, from www.paterva.com, and it's embedded in Kali Linux. Let's see Maltego in action. Go to Kali Linux and open a terminal screen and type Maltegos, that's Maltegoce, to run Maltego Community Edition embedded. First, we choose a machine to run. There are different machine options specified for different purposes. For example, there's a Twitter Digger machine to work on a Twitter account and analyze the tweets. Let's choose Footprint L1 machine this time, which is a fast and basic footprint for the target domain. The second step is to specify the target domain. When we click the Finish button, it's going to start to collect data. Now, in the Community Edition of Maltego, the results are limited to 12 entries. It shows the results in graph mode. We can zoom out to see the entire picture or zoom in to focus on specific results. Now, if you select a node and right-click on it, you can see all the transforms you're able to run for that node. Transforms are grouped according to their purposes. You can expand a group and select a single transform to run, or you can run a group of transforms at once. You can configure a transform before the run or save a transform in your favorites list. Let's run the mirror:\email addresses found transform at this time. The results start to come in about a minute. Let's see some more about Maltego while we're waiting. There are different graph types you can choose to see the results. If you zoom out the graph under 30%, the entities are shown as the dots instead of meaningful symbols. All the colors of the dot point to a specific type: email addresses, websites, domain names, and more. You can see the color legend in the lower right corner. The results of the transform we ran a minute ago are here now. You can use the toggle full screen button or simply press Alt plus Enter buttons to toggle the graph to full screen. You can select the email addresses node and see the collected email addresses listed in the detail view window.
Vulnerability scan is one of the most important parts of a penetration test, or ethical hacking. Vulnerability scanning is an inspection of the potential points of compromising on a computer or network to identify security holes. A vulnerability scan detects and classifies system weaknesses in computers, networks, and network devices, and predicts the effectiveness of countermeasures. So let's think about the term vulnerability first. I want to show you two vulnerability definitions from two important documents. The first document, ISO 27005, is the name of the prime 27000 series standard covering information security risk management. The standard provides guidelines for information security risk management, ISRM, in an organization, specifically supporting the requirements of an information security management system defined by ISO 27001. So according to ISO 27005, vulnerability is a weakness of an asset or group of assets that can be exploited by one or more threats. The second document is published by NIST. That's the National Institute of Standards and Technology. NIST is a measurement standards laboratory and a non-regulatory agency of the United States Department of Commerce. Its mission is to promote innovation and industrial competitiveness. NIST has very good guides about cybersecurity, so if you're cybersecurity personnel, you should definitely keep your eyes on NIST. So according to NIST, vulnerability is a flaw or weakness in a system, security procedures, design, implementation, or internal controls that could be exercised, accidentally triggered, or intentionally exploited, and result in a security breach or a violation of the system's security policy. Let's see the basic vulnerability detection methods. By looking at an application's banner information, or by obtaining version information of the application, it is possible to know about potential weaknesses in that application. The weaknesses found in certain versions of the applications are detected over time, and this information is collected in vulnerability databases. By looking at these databases, you may have information about whether there is a weakness in that application. Now, protocols used by the application in communication with a client may have vulnerabilities. In this case, the application can be exploited. A weak encryption algorithm in communication is an example. The vulnerability scanners send different types of packets over the network. It examines the behavior of the service against these packets and examines whether these behaviors are similar to the behaviors of the vulnerable services. Wrong configurations may cause vulnerabilities and weaknesses. For example, if you configure your web application's authentication mechanism to allow 3-character passwords, it can very easily be cracked by attackers. A vulnerability scanner is a software program designed to assess computers, computer systems, networks, or applications for known weaknesses. In plain words, these scanners are used to discover the weak points or poorly constructed parts. It's utilized for the identification and detection of vulnerabilities relating to misconfigured assets or flawed software that resides on a network-based asset such as firewall, a router, web server, application server, etc. There are a lot of vulnerability scanners. Some of them are listed in this slide. We have seen Nmap in previous lectures as a network scanner, and we also learned that with the help of Nmap scripting engine, NSE, it's possible to use Nmap as a simple vulnerability scanner. Nessus is one of the most popular and capable vulnerability scanners. We'll see it in detail in the next lecture. Microsoft Baseline Security Analyzer provides a streamlined method to identify missing security updates and common security misconfigurations. It's only for Microsoft systems, and we have to say that it's not an overall vulnerability scanner at all. But no matter what, if you have Windows systems in your network, it would be better if you use Microsoft's Baseline Security Analyzer. Nexpose is a commercial tool developed by Rapid7, which are the producers of Metasploit framework. It is a vulnerability scanner which aims to support the entire vulnerability management lifecycle, including discovery, detection, verification, risk classification, impact analysis, reporting, and mitigation. It integrates with Metasploit for vulnerability exploitation. OpenVAS is an open-source vulnerability scanner that was forked from the last free version of Nessus after that tool went proprietary in 2005. Saint is a commercial vulnerability assessment tool. Like Nessus, it used to be free and open source, but is now a commercial product. Unlike Nexpose and Guard, Saint runs on Linux and Mac OS X. In fact, Saint is one of the few scanner vendors that don't support or run on Windows at all. GFI LandGuard is a network security and vulnerability scanner designed to help with patch management, network and software audits, and vulnerability assessments. The price is based on the number of IP addresses you wish to scan. A free trial version up to 5 IP addresses is available. Qualys Guard is a popular code-based SAS, Software as a Service, vulnerability management offering. Its web-based UI offers network discovery and mapping, asset prioritization, vulnerability assessment reporting, and remediation tracking according to business risk. CompTIA PSI, Personal Software Inspector, is a free security tool designed to detect vulnerable and outdated programs and plugins that expose your PC to attacks. Attacks exploiting vulnerable programs and plugins are rarely blocked by traditional antivirus programs. CompTIA PSI checks only the machine it is running on, while its commercial sibling, CompTIA CSI, Corporate Software Inspector, I know what you TV fans are thinking. Anyway, that scans on multiple machines on a network. So, a vulnerability database is a platform aimed at collecting, maintaining, and disseminating information about discovered vulnerabilities targeting real computer systems. The database will customarily describe the identified vulnerability, assess the potential infliction on computer systems, and the workaround required to desist a hacker. Now, here are the most known vulnerability databases. Open-sourced vulnerability database, OSVBD, was an independent and open-source database. The goal of the project was to provide accurate, detailed, current, and unbiased technical information on security vulnerabilities. The project promoted greater and more open collaboration between companies and individuals. The project was started in August 2002 at the Black Hat and DEF CON conferences by several industry notables. On the 5th of April 2016, the database was shut down, although the blog will continue. The National Vulnerability Database is the U.S. government repository of standards-based vulnerability management data represented using the Security Content Automation Protocol, SCAP. This data enables automation of vulnerability management, as well as security measurement and compliance. NVD includes databases of security checklists, security-related software flaws, misconfigurations, product names, and impact metrics. CVEdetails.com is a free CVE security vulnerability database information source. You can view CVE vulnerability details, exploits, references, Metasploit modules, a full list of vulnerable products, and CVSS score reports, and vulnerability trends over time. CVE, Common Vulnerabilities and Exposures, is the system that provides a reference method for publicly known information security vulnerabilities and exposures. So let's have a look at Nessus. Developed by Tenable Network Security, is one of the most popular and capable vulnerability scanners. Nessus Professional is a commercial product. In addition, a free Nessus Home version is also available, though it's limited and only licensed for home network use. Nessus allows scans for the following types of vulnerabilities. Vulnerabilities that allow a remote hacker to control or access sensitive data on a system. Misconfiguration. For example, open mail relay, missing patches, etc. Default passwords, a few common passwords, and blank or absent passwords on some system accounts. Nessus can also call Hydra, an external tool, to launch a dictionary attack. Denials of service against the TCP IP stack by using malformed packets. And preparation for PCI DSS audits. Now, in a typical operation, Nessus begins by doing a port scan to determine which ports are open on the target, and then tries various exploits on the open ports. The vulnerability tests, available as subscriptions, are written in NASL, Nessus Attack Scripting Language, a scripting language optimized for custom network interaction. Nessus is constantly updated, with more than 70,000 plugins. Key features include remote and local authenticated security checks, a client-server architecture with a web-based interface, and an embedded scripting language for writing your own plugins or understanding the existing ones. Optionally, the results of the scan can be reported in various formats, such as plain text, XML, HTML, and LaTeX. Now, Nessus is not embedded into Kali, so let's download it to install and use in our Kali. Open the browser and search for Nessus Home Download in Google. I think you already know that Nessus Home is the name of the free version of Nessus. So discard the ads. The first link is Tenable's Nessus homepage. We need an activation code to use Nessus Home, and we have to register for an activation code. So you would better register with your exact names and email addresses. Since I have previous registrations, I'd like to register with a public name and mail address. Ethical Hacker is the name and surname. ethichack@yopmail.com. Click register when you're okay. Now the next page is where you can find the download link for Nessus Home. The page says that an email containing my activation code has been sent to my email address. So let's open a new tab and look to see if we've got the activation code. I go to yopmail.com/ethichack, which is the URL address of ethichack@yopmail.com email address. And here's the email with the activation code. Now go back to the homepage of Nessus and click Download. Here's a list of the binaries of Nessus Home. Our Kali is a 64-bit Debian, so I'm going to click and download this one. And save the file. Now let's install the packet that we downloaded. I go back to the browser to see the location to where the file has been downloaded. It's downloaded in the Downloads folder. Now open a terminal screen and go to the folder using cd command. To install the packet, use dpkg, Linux command with iparameter. And last, type the file name. Remember, you can use a tab key to complete the file name and hit enter. The installation is completed within a few seconds. Now let's look at the messages. It says we should start the Nessus D daemon to start Nessus Home. And then we can connect to the web interface of Nessus, which will be served at port 8834. This is the default port of Nessus Home's interface. So use the service command to start the Nessus D daemon. First, I want to look at its status. It's inactive at the moment. Type service Nessus D start to start Nessus D daemon. Now, let's look at the ports of our Kali, which happen to be in listen mode. Use the netstat command with TNLP parameters. And here it is. Port 8834 is being listened to by Nessus D. Now we can access Nessus Home's web interface. So go to the browser and type 127.0.0.1:8843 and hit enter. As you know, 127.0.0.1 stands for the local host. You can use the IP address of your Kali instead. It doesn't matter. Whoops! Nessus service is an HTTPS service. So we have to use HTTPS at the beginning of our URL. So our browser says that the connection is not secure because the local certificate of Nessus is not registered by a CA, a certificate authority. No worries, click Advanced and then Add Exception and click Confirm Security Exception. And here's the first interaction with Nessus Home's web interface. So the next step is to set up Nessus Home. First step is to create an account. Select a username for yourself and add a password. Click Continue. The next screen asks the scanner type and the activation code, which has been sent to our email address while we were downloading the Nessus Homes installation packet. Here are the scanner types. We'll use Nessus Home, so leave the first option selected. Now I go to the email sent by Nessus and copy the activation code and paste it into the related field. Then click Continue. As soon as setup is complete, Nessus downloads and initiates the latest plugins, which will be used in the scans by Nessus. First, it downloads the plugins according to your connection speed. Now, it may take a few minutes, so be patient. Now it's compiling the plugin. This step may take longer than the download step, so you might want to go and grab yourself a cup of coffee. And there it is. The initialization phase is complete. Welcome to the Nessus interface. So hang on, before rushing in to start our first Nessus scan, I'd like to show you how to create our own policies. Policies allow you to create custom templates defining what actions are performed during a scan. In the Nessus web interface, click Policies at the left side. You see that? Good. Click the Create a New Policy link inside the Policies page. Now here we have a lot of scanners. So in Advanced Scan, all the options are chosen by us without any guidance or recommendations. Basic Network Scan is generally suitable for any host. Internal PCI Network Scan is designed for internal scans, and it's based on PCI DSS standards. PCI DSS, Payment Card Institute, and Data Security Standards, simply one of the most important information security standards. So it looks like the days when this video was captured that Spectre and Meltdown are really new vulnerabilities. So here there is a scan specialized for Spectre and Meltdown vulnerabilities. This clearly shows how up-to-date Nessus is. Here there's another scanner specific for web applications. So let's configure our own scan. Click Advanced Scan. First, give a name for your policy. Now go to Discovery section. So we're in the Host Discovery page. Here we have a Ping the Remote Host option and the settings of the ping. If we're going to use the data we collected with Nmap, we can close this ping scan because we already have the lists of the hosts. Click Port Scanning to configure port scanning options. The default value of the port scan range is, well, default. That means Nessus will scan the ports, which is in its Nessus services file. Now I go to the terminal screen to analyze a Nessus services file. Let's find the file first. Use the find command to find the file. / means that the search will begin from the root directory. -name shows the name of the search file, and hit enter. And here it is. You can stop the search using Control-C keys. I use the less command to see the content of the file. Here are the ports, protocols, and the default services which use these ports. Now I want to see the number of the lines of Nessus services file to understand how many ports are scanned by default. Cat command with a file name, pipe, WC to see the word count. The first number is the number of lines, the second one is the number of the words, and the last one is the number of the characters. So we can say that 9,000 ports are scanned by default, which is the total of both TCP and UDP ports. But what if you want to see the number of TCP ports scanned by default? You can use grep before WC. Type cat, file name, pipe, grep, TCP, pipe, WC. You will see the number of TCP ports scanned by default. There are about 4,600 TCP ports. Now, if you want to scan for all ports, you should type 1 through 65535 in port scan range field. So, here are the options to use SSH service for local port enumerators. So, let's have a short break here. If you have some credentials to scan some services in depth, you can define those credentials before the scan. So here, select the Credentials tab, and you see some services. When you click the SSH, for example, you will see the credential options. But let's remove this for now. Now turn back to Settings by clicking its tab. We were in Discovery Port Scanning page. And here are the port scanning options. SynScan is selected by default. If you like, you can select TCP and or UDP scans as well. Now go to the Advanced section. Safe checks are enabled by default. So we can select scan IP addresses in a random order to make the scan a little more stealthy. Let's look at the performance options. We can reduce the number of max simultaneous hosts per scan to avoid delays in network traffic. Max number of concurrent TCP sessions per host is not defined by default. We can define an upper bound to keep the hosts safe. And again, we may define a maximum number of concurrent TCP sessions per scan to keep the network traffic safe. Now look at the tabs on the top of the new policy page and you'll see the plugins tab. Right, so here we have tons of plugins used in Nessus scans. If you click one of the plugin families, you'll see all the plugins of that family. You see the total number of plugins in a plugin family, and here are the plugins. You can click on Enabled next to a plugin to disable it. Or if you want to disable an entire plugin family entirely, for example, denial of service, click on Enable label next to the name of the plugin family. Click Save, and now we have our own scan policy. At last, we are ready to start a Nessus vulnerability scan. This is the main page of the Nessus web interface. We are in My Scan section of Scans tab. At the upper left corner, click New Scan. First, Nessus asks for the scanner. We have seen them before, so here we can choose the most suitable one for our scan. But in the home version of Nessus, unfortunately some scans are disabled. If you click Internal PCI Network Scan, for example, the application redirects you to the Nessus website to buy Nessus Professional. There are also available scanners like Basic Network Scan, or alternatively, go to User Defined tab and select your own policy. This is the policy we defined in the previous lecture, so I chose this. Now, give a name to your scan. As you can see in the right side of the name field, the required fields are identified by Nessus. So write a description if you want. Select the folder for the outputs, and define the targets. You can list the hosts in Targets field one by one. I want to scan my two systems now. 99.139 is OWASP BWA, and 99.206 is my Metasploitable system. So if you want multiple IP addresses, just put a comma in between them. You can also define an IP block or a range, just as you remember in the Nmap lectures. Or alternatively, if you have a file that contains a list of the hosts that we also covered earlier, you can add that file using the Add File link in the Upload Targets field. So now we're ready to launch this scan. At the bottom of the page, select Save, or click the down arrow button and select Launch to start the scan immediately. I choose Launch. It first saved the scan and then launched immediately. So while it's scanning, let's see some of the parts of Nessus interface. At the left, you see the folders. Next to My Scans folder, it says that I have one active scan. And in My Scans page, you see the scan that we just started. If you click on it, you see the scan details. There are three tabs here: Hosts, Vulnerabilities, and History. When you click on the Vulnerabilities tab, you see the vulnerabilities found during the scan. Here we already have some results. Now click the Hosts tab to turn back. These are the systems that we defined as targets: OWASP BWA and Metasploitable. At the right, you see the severity levels of the vulnerabilities. Nessus classifies vulnerabilities into 5 levels. Informational level quickly identifies non-vulnerability information, which is, well, nice to know, and separates them from the vulnerability detail, which is need to know, right? Low level identifies the flaws that might help an attacker to better refine his attack, but by itself that flaw won't be sufficient for a compromise. Medium level identifies that some information is leaking from the remote host. An attacker might be able to read a file he should not have access to. High level identifies that the attacker can read arbitrary files on the remote host and or can execute commands on it. And critical level vulnerabilities are the most important vulnerabilities for us. These vulnerabilities can be exploited by a tool, and in most cases, the attacker does not need to make an extra effort to exploit them. So let's fast forward the scan. Now, on the right side of each host row, you can see the status of the scan of that host. 100% means the scan of that host is complete. Did you know you can ping the hosts sometimes to understand that they're still alive? And finally, our scan is completed in 4 minutes, which is a very fast scan for a vulnerability scan. Now let's click the Metasploitable to go to the vulnerabilities of that host. Here are the vulnerabilities of the Metasploitable machine found by this scan. Please note that there might be other vulnerabilities that cannot be found by Nessus with the policy that we used. The vulnerabilities are ordered by severity levels by default, and I think that's a good idea. The vulnerabilities in the critical severity level are the most important ones for us again. So click on a vulnerability to see the details of it. So here we have the name of the vulnerability, a brief description, a solution method, and the links to learn more about it, and last, the host and the port where the vulnerability lives. At the right side of the screen, you see some additional and important information about the vulnerability. So for this particular vulnerability, Nessus says that we can exploit it using Core Impact, which is a commercial and very powerful exploitation tool. And here are the scores of this vulnerability. 10.0 is perfect for us. So click Back to Vulnerabilities to go back to the list of the vulnerabilities. Here there is another vulnerability which says the VNC server is running on the host and its password is password. If that's true, and if there's no additional measure to protect the host, we can access that host very easily. I'll show you. Let's test it. Go to the terminal screen and run the VNC viewer by typing xVNC viewer and hit enter. If you don't have VNC viewer installed on your Kali, type apt-get install xVNC viewer and hit enter. Type the IP address of Metasploitable as the VNC server and hit enter. And now type password as the password and hit enter again. And voila, we are in the system. I use the WOMI Linux command to learn the user that I've caught, and uname-a to learn the operating system and the kernel details, ifconfig to see the information about the network interfaces, etc. Now type rm-rf/. No, just kidding, don't do that, don't. Let's perform another vulnerability scan. I want to perform an aggressive scan to find as many vulnerabilities as possible. Go to Kali and start the Nessus daemon if it's not already started. Use service Nessus D status to learn if it's running. Okay, so it's inactive. So I use service Nessus D start to start Nessus service. Now, go to your browser and connect to the Nessus interface. It is a HTTPS service. It's running on the same machine, so I'll use 127.0.0.1 loopback IP address referred to as localhost, and the port of the Nessus service is 8834. Sign in using your credential. Click the New Scan button. Now let's choose Advanced Scan for this scan. Will be more aggressive than a basic network scan. So enter the basic info, give the scan a name, and enter a description if you want. And the targets. Here I have a Windows XP with an IP address of 207 and Metasploitable 2 Linux system with an IP address of 206. Here I have a third system, an up-to-date Windows 8, and its IP address is 223. Right, so back to Kali and enter the IP addresses of the target systems. 206 for Metasploitable, 207 for Windows XP, and 223 for Windows 8. Now click Discovery in the list at the left. So we're simply going to accept the defaults on this page. So let's click on Assessment over to the left. And on this page, we want to check Perform Thorough Tests, so check the box. Then move to the Report section in the options on the left. You can override the normal verbosity to make it report as much info as possible. So next, click the Advanced option in the list to the left. The only thing we're going to do here is uncheck Enable Safe Checks. Now, on a normal production network, you would leave this box checked. You don't want to take down production systems when scanning. But for our purposes here, we want to gather as much information as possible, so we're going to uncheck it. Now click on the Credentials tab. Select the SSH option, in the list on the left. Now, since we know the username and password for the Metasploitable 2 machine, we're going to put those credentials in here. Remember, the username and password are both MSF admin. Change the authentication method to password and put in the username and password below. Now, in the Plugins tab, we only need to activate the plugins that have to do with what might be running on a Linux system, so we can disable a few things here. Okay, I paused the demo here. I've got to make an apology. It's a late update. While capturing the demo, I forgot that I have Windows targets and disabled the Windows plugins. It's a mistake, and I just wanted to show you that what we do here is, if there's a problem, there's always a solution. So if you have Windows targets, please do not disable the Windows plugins. All right, let's move on. We can finally click Save at the bottom. So here's a scan, and we're ready to run it. Simply click the great triangle at the far right of our scan, which stands for launching the scan. And yes, the scan is started. Now you can pause or stop the scan anytime you want. So click the scan and we see the results in real time. Okay, boy, that's going to take a while to run, so it's probably a good time to check your email, grab a cup of coffee maybe, but just make sure you come back to review the results. So the scan is completed in 17 minutes. Now another pause here. Because I disabled the Windows plugins, it seems as if the Windows systems don't have critical vulnerabilities. It's not right, especially my Windows XP has several critical vulnerabilities. If you didn't disable Windows plugins, you're supposed to see some more vulnerabilities for Windows systems. Now, to see the results of the Metasploitable scan in detail, let's click the Metasploitable Results 206. The Nessus home found 10 critical vulnerabilities with our scan configuration. But please note that the configuration affects the results, so the target systems may have more vulnerabilities than reported. If there is a vulnerability and it's not found in a scan, we call it a false negative. Now, I'm sure you know that the critical vulnerabilities are the most dangerous ones, but that's where it gets good. They are the most exploitable ones in general. So let's click on one of these critical vulnerabilities, for example, bind shell backdoor detection. Well, look at the description. It says a shell is listening on the port without any authentication being required. This is obviously a backdoor. Here's a port number, 1524. Now, let's check if the finding is a true positive. Go to terminal screen. I use Netcat tool to connect. Simply type NC and the target IP and the target port 1524. And we're in. We have the shell for Metasploitable. Type who am I to learn the credential we have. We are the root user. Now, it was too simple. It's just not fun. And, I don't like it. I like a good challenge, right? I mean, we are the root user and we can access anything we want. For example, shadow file, which contains the hashes of the user's passwords. Okay, back to the browser and click on the Back to Vulnerabilities link to turn back to the vulnerabilities of Metasploitable. Now I'd like to show you some more. Scroll on down the vulnerabilities. It shows 50 vulnerabilities per page by default, but let's make it 200 to see all the findings in a single page. Now the findings are ordered by severity levels, so information is at the bottom. Findings with a severity level of information identify non-vulnerability information, which is, nice to know, and it keeps it separate from the vulnerability detail. So here there's an info RMI registry detection. Let's click it. It says that the remote host is running an RMI registry, retrieving remote objects in the Java runtime method invocation system. So let's look for the exploits of the Metasploit framework, if there is any exploit for Java RMI. Open a terminal screen and run MSF console. So here we have MSF console. Let's search the exploits of RMI. Too many results. To keep it more specific, I want to search Java RMI. So we have 2 auxiliaries and 2 exploits at this time. So look at the exploit in the last line. This module takes advantage of the default configuration of the RMI registry and RMI activation services, which allow loading classes from any remote URL. Let's try to use it on our RMI port. Please don't worry, I am going to explain what these all mean. I just want to show you an example at the beginning, so bear with me. Type use at the module name with a full path. You can simply select the module name and click the middle button of the mouse to copy and paste it. Type show payloads to see the payloads can be used with this module. So I want to use this payload to have a meterpreter session. Again, I'll explain what the meterpreter is soon, but just copy and paste the payload name. Type show options to see the parameters of the exploit and the payload as well. Set the remote host as Metasploitable 206. Default remote port is the same with our port 1099. Serve host is the local host to listen on. Set this to be our Kali 222. Let the default serve port remain. So the other options are not required. I'll just leave them blank. Now are the payload options. Set the listen host to be our Kali 222. Default listen port is good 4444. And finally type exploit to run the exploit. So there, it looks like we have a meterpreter session. Type sessions-L to list the active sessions. Be patient, we'll see them in detail. Type session-I, session ID, to interact with the session. And here we are, we're in. Now I'm going to show you what we can do with the meterpreter session in the following chapter, but here's a couple of meterpreter commands. sysinfo to see the system information. Hashdump to gather password hashes. Now, no such command for this system. Thankfully, we have an alternative for this. Type runpost/linux/gather/hashdump and hit enter. And collect the fruits of your labor. So, as you see here, we found another way to exploit the system, even though the finding was just information. So, I hope you understand not to underestimate any finding. Okay, everybody, I admitted I made a mistake in a previous scan, and I disabled the Windows plugins, although 2 of my 3 targets are Windows. It's just a really big mistake that affects the results, so that clearly shows that we should be very careful while configuring the tools such as the vulnerability scanner. Now, I scanned the target machines once again, and I didn't disable the Windows plugins this time. So these are the results. 207 is Windows XP, and 223 is Windows 8. I click on the Windows XP to see the vulnerabilities. And as you see, there are a lot of critical vulnerabilities. I'll click on one of them just to see its details. So here is the name and the description about the vulnerability. And scrolling down, yes, it says the vulnerability is exploitable with Metasploit. So let's go back to vulnerabilities. I want to show you another vulnerability for our XP system. This is the vulnerability MS08-067, which has a very stable exploit. Rolling down a bit, and Nessus says we can exploit this vulnerability using Metasploit. So let's do it. I think it's an invitation. Open a terminal screen and start MSF console. Search for the vulnerability MS08-067. Here is the exploit. Let's use it. Look for the available payloads using Show Payloads. I want to use shell payload with bind TCP stager for this time. Show options. Set the remote host that was, well, let me look at the Nessus page again. Yes, 2007. And the port is 445. The default value is correct. Show the options again, and we're ready to run the exploit. Here is the shell of the target system. Exploitation is successful once again. And finally, let's see the reporting abilities of Nessus. Open a browser and go to Nessus service, HTTPS, localhost, and port 8834. Log in with your credential. And here are the scans we performed before. I've only one for now, but click on it and see the details. In the upper right-hand corner, there's an export combo box. When you click on it, you see the report types of Nessus Home. So let's generate a PDF report first. We have two options in the Home Edition, and you'll have other options if you buy the Professional Edition. So I choose Custom here, and as you see, we have only two options in Home Edition. You can group the vulnerabilities by host or plugin. I choose the host. And click Export to generate the report in PDF format. Save it or open it now. I'll choose Open, and that way you can see it. So the file is downloaded into the temp folder. And here's a scan report in PDF format. Vulnerabilities are grouped by hosts. I'll click the Metasploitable header. Now there's a few lines of brief summary, then the explanation of the vulnerabilities start. As you see, the vulnerabilities are not sorted by the severity level, which is not good. Of course, you can sort them in the Professional Edition. That's where they get you. So now let's see the vulnerability assessment report in HTML format. Same home page with the PDF option. This time I'll choose the executive summary option and click Export. Open it with Firefox. And here's the report in HTML format. A single frame for each host. Click the Show Details button to see the vulnerabilities list of the host. If you want to have detailed information about a vulnerability, click on it. The HTML file redirects you to the online web pages of Tenable Security. You can scan the network to find out the computer systems in a network and discover the network topology. First, let's see the scan types. There are two types of scanning. First type is passive scan. In this type of scanning, you don't want to be recognized by the target. In this regard, you don't directly contact target systems. Just by watching a network's traffic flow, passive scanners can deduce a large amount of information about the communicating systems. You can use tools such as TCP dump or Wireshark to monitor network traffic. Looking at the ARP table in a computer which is connected to the network is another example of passive scanning. So the second type is active scan. In this type of scanning, you scan on the target systems. Active scanning requires more preparation for the attacker or pen tester because it leaves traces, which are likely to alert the target or produce evidence against him. Active scanning on your network can also return great headaches, however. It can have a high political cost and far-reaching effects on system uptime and reliability. If not done carefully, it can be an ineffective, inefficient way to gather information. We'll see Nmap in details. Hping is an excellent command line-oriented TCP/IP packet analyzer. It looks like ping command, but Hping isn't only able to send ICMP echo requests. It supports TCP, UDP, ICMP, and raw IP protocols, has a traceroute mode, the ability to send files between a covered channel, and many other features. SCAPI is a powerful interactive packet manipulation program. It is able to forge or decode packets of a wide number of protocols, send them on the wire, capture them, match requests and replies, and much more. Traceroute is a utility that records the route, the specific gateway computers at each hop through the network between your computer and a specified destination computer. so you can find out the network devices between you and the target and identify the network topology. There's a really good comparison of active and passive scanning on networkworld.com website, which says, just as you can determine the type of cheese by tasting it, an active scan, you can also use passive techniques such as reading the label or smelling the aroma as it passes by. Before talking about using ARP tables for passive scanning, let's talk a little bit about ARP protocol and mechanism first. So, Address Resolution Protocol, ARP, is a network layer protocol used for mapping a network address such as an IPv4 address to a physical address such as a MAC address. To simulate how the ARP mechanism works, we have a small network in the slide, a switch on top, and 3 computers connected to it. Computer A wants to talk to computer C. It puts an ARP request onto the wire, which happens to be broadcast. Essentially what it's saying is, who has computer C's MAC address? Of course, because it's a broadcast, every system on the network hears it. Does everybody respond? Well, what happens is that B hears that A is looking for the MAC address of computer C. B knows that it's not computer C and therefore does not respond to the broadcast. The broadcast, the ARP request, goes out to every system, but the only system that will reply is computer C with an ARP reply. In other words, computer A says, who has the MAC address of computer C? And although all the workstations hear the question, only C replies and says, I've got the MAC address of computer C, and this is what it is. So the ARP reply sends back the MAC address to computer A, and each of these machines start building an ARP table. So what is the ARP table? Since computers cannot send broadcast messages every time they need to connect with another network device, they store the IP addresses and the corresponding MAC addresses of systems they frequently communicate with in a table called ARP table. All the systems in the LAN maintain this table. The entries in the ARP cache table are generally short-lived and are updated every 15 to 20 minutes. Now let's get back to our topic. Can we say that one of the passive scan methods is just looking into the ARP table of a system, which is a network that we are scanning? Well, sure we can. Inside an ARP table, we see the IP addresses of some of the systems of the network and their corresponding MAC addresses. Let's see the ARP tables in 3 different platforms: Mac OS, Windows, and Debian Linux. We are in a Mac OS operating system first. Open the terminal first. Type terminal in the search box of the applications window, which brings you the terminal application. Typing ARP and hitting enter shows a small help for ARP command. If you want to see detailed help about the ARP command, you can use MAN command. Type MAN, ARP, and hit enter. You'll get detailed help. A parameter is used to display all current ARP table entries. But hold on, it says A is used to delete all entries as well. How can that be? Well, to delete an ARP table entry, you use D parameter. If you use this parameter with A parameter, you are able to delete all entries of ARP tables. I parameter is used to see the entries of a single interface. By default, ARP command tries to show the display addresses symbolically. To see the IP addresses instead of display names of the systems, you have to use N parameter, which means do not resolve names. Okay, press Q to quit the man page of the ARP command. Now type ARP-AN to see all the entries of the ARP table. Since Mac OS is a BSD-based operating system, the results of the ARP command is displayed in BSD style. The second machine is a Microsoft Windows 8. Let's open a command prompt first. I have a shortcut on my status bar, so I click it to start a command prompt. Alternatively, press Windows plus R buttons, open the dialog box, run Command, and hit Enter. If you type ARP in a Windows system, the help page of ARP command is displayed. Type ARP-A to see the entries of the ARP table. In my opinion, this display is more, human readable than BSD style. Now, although we're not interested in these at the moment, I would like to talk a little about the IP addresses that start with 224 to calm your curiosity. 224.0.0.22 is the multicast address for Internet Group Management Protocol. 224.0.0.252 is used by recent versions of Windows for Link Local Multicast Name Resolution, LLMNR, searching for local network computers. The third machine is our Kali, which is a Debian-based Linux operating system. Open the terminal window. If you type ARP and hit Enter, the ARP table entries are displayed in a human-readable format. As you see, systems are listed with a known domain name such as www.owaspbwa.com by default. ARP-H brings you a small help page. If you want a detailed help page, type man space ARP. In a Debian-based Linux system, -A parameter of ARP command is used to see the entries in BSD format, which we saw in Mac OS. -I is, again, to see the entries of a single interface. Okay, press Q to quit the man page. ARP-A displays ARP table entries in BSD format, and use N parameter to see the IP addresses instead of domain names of the systems. Wireshark is free, open source, and the world's foremost network packet analyzer, and it is the de facto standard across system and network administrators. Wireshark has the ability to listen and record traffic, as well as advanced filtering and reviewing options. We're not going to do a deep dive into Wireshark right now, since that's the subject of network layer attacks. So here, let's see a summary of the traffic and the systems related to the interfaces we listen. Let's go to Kali and start Wireshark. You can start Wireshark from the Applications menu or open a terminal window and type Wireshark to start the app. Don't worry about the ampersand and the and of the command. Putting an ampersand at the end of a command causes the shell to run the process in the background. It's sort of multitasking. You can have many processes running, but only one in the foreground at any given point. The process in the foreground is the process that appears to have locked up the terminal. Whatever. The first message is because we are a super user on Kali. No worries. Okay, the welcome page of Wireshark asks which interface we would like to listen to first. So let's have a look at the interfaces of our system. To look at the interfaces and to remember the IP address of Kali, open a terminal and type ifconfig. There are two result sets of the ifconfig command, eth0 and LO. eth0 is the first Ethernet interface. Additional Ethernet interfaces would be named eth1, eth2, etc. Here we have only one. Now LO is the loopback interface. This is a special network interface that the system uses to communicate with itself. eth0 is the interface that we're interested in at the moment. Double-click to open the eth0 on the main page of Wireshark to start capturing the packets passing through our Ethernet interface. Now, to speed it up, let's create some network traffic. Open one of my virtual machines, OWASP-BWA, and ping Kali. To stop ping command, press Ctrl-C, ifconfig, to learn the IP address of the machine. Now I go to another VM, Metasploit, and ping the last VM first. And then ping Kali. Here we have a lot of ICMP and ARP traffic at the moment. So let's generate some traffic. I open the browser in Kali and visit the website served by the OWASP-BWA machine. And even more traffic. I visit nhs.uk, my favorite website. Okay, that's enough. Let's turn back to Wireshark. As you see, we have a lot of packets captured, and new packets arrive every second. ARP packets, TCP packets, TLS packets for HTTPS traffic, etc. Here we don't investigate the packets in detail. We want to learn about the systems which are interacting with us. So go to Statistics menu and select Conversations. There are 5 tabs in a conversation window by default. And we're on the IPv4 tab at the moment. Here there are IP packets grouped by address A and address B. In each line, we see how many packets sent up to now, total size of the packets in bytes, number and size of packets from A to B and from B to A, etc. There is traffic between 8.8.8.8 and my collie. Now I know that 8.8.8.8 is the IP address of Google DNS, so I must have set the Google DNS as the DNS of my collie. You know, I'd like to look at the network config. And yes, my DNS address is 8.8.8.8. In the Ethernet tab, we can see the MAC addresses of the systems. The addresses full of Fs mean that the packet is broadcasted. ARP requests are the examples for these kind of packets. In the TCP tab, we can see TCP packets grouped by the addresses and this time by ports as well, because a system may have different interactions with any other system. For example, Kali may have HTTP traffic through port 80, and at the same time, it may have an SSH connection through 22 as well. Same as TCP. Packets are grouped by IPs and ports in the UDP tab. Here we have learned a lot of live systems, IP addresses, and MAC addresses just listening to the traffic go through our network interface. If you'd like to investigate the traffic between the two machines, select a line, right-click. If you choose Apply as Filter from the menu, only these kinds of packets will be seen in Wireshark. I'll choose Find at this time. As you see, automatic query string is prepared. I can navigate between the packets by clicking the Find button. Go back to the conversation window. At the bottom right, there is a Conversation Types button. When you click on it, a lot of different protocols are listed. These selected 5 are the default selected protocols. You can add any protocol from the list. When you select one of them, a new tab is added to the conversation window. So have a look at what you see here. There are a lot of packets that Wireshark captures in seconds. There are some requests and responses for them, broadcasts and their replies, and etc., etc. There is an easier way to follow a stream, although this is very entertaining. The stream is a collection of packets that form a network conversation from the beginning to the end, just like your favorite story. So I'm in Kali now, and I captured the traffic just for a little bit, and while I was capturing, I visited a website to create some HTTP traffic. And here are the results: DNS packets, TCP packets, HTTP packets, etc. So I'll select an HTTP packet, and it's the GET request. Right-click, go to Follow on the submenu, and here you see the TCP stream and the HTTP stream options are both enabled. So that means we can follow either the TCP stream or the HTTP stream. So let's click HTTP stream. Now the client packets are red and the server packets are blue. The GET request by Kali, 200 OK response by OWASP BWA. Now this is a return page in HTML format. So you can scroll down and we'll see some of the other requests and the responses in the same stream. And perhaps you're beginning to see that when you click on a link in a website or visit a website by typing its URL, there might be several consecutive requests and responses that you don't even realize. But in actuality, you don't need to know them as the end user, but we're not your typical end users now, are we? So let's keep going. From the combo box at the left-hand side of the bottom of the stream window, you can filter the conversation from one side to another or vice versa. So at the right-hand side, right, there is another combo box where you can select the output format. Now when you close the stream window and go back to the main window of Wireshark, you can see that the stream filter is applied right here. So I'll remove the filter by clicking this cross icon. Now I see the entire captured traffic again. That is why filters exist. So in typical traffic capturing on a network interface, there are a lot of packets received from and delivered to all over the network and, well, the internet as well. So let's see how we can take a picture of that network. Let's go to Kali and start Wireshark. You can start Wireshark from the Applications menu or open a terminal window and type Wireshark to start the app. Don't worry about the ampersand and the and of the command. Putting an ampersand at the end of a command causes the shell to run the process in the background. It's sort of multitasking. You can have many processes running, but only one in the foreground at any given point. The process in the foreground is the process that appears to have locked up the terminal. Whatever. The first message is because we are a super user on Kali. No worries. Okay. The welcome page of Wireshark asks which interface we would like to listen to first. So let's have a look at the interfaces of our system. To look at the interfaces and to remember the IP address of Kali, open a terminal and type ifconfig. There are two result sets of the ifconfig command, eth0 and lo. eth0 is the first Ethernet interface. Additional Ethernet interfaces would be named eth1, eth2, etc. Here we have only one. Now lo is the loopback interface. This is a special network interface that the system uses to communicate with itself. eth0 is the interface that we're interested in at the moment. Double-click to open the eth0 on the main page of Wireshark to start capturing the packets passing through our Ethernet interface. Now, to speed it up, let's create some network traffic. Open one of my virtual machines, OWASP BWA, and ping Kali. To stop ping command, press Ctrl-C, ifconfig, to learn the IP address of the machine. Now I go to another VM, Metasploit, and ping the last VM first. And then ping Kali. Here we have a lot of ICMP and ARP traffic at the moment. So let's generate some traffic. I open the browser in Kali and visit the website served by the OWASP BWA machine. And even more traffic. I visit nhs.uk, my favorite website. Okay, that's enough. Let's turn back to Wireshark. As you see, we have a lot of packets captured, and new packets arrive every second. ARP packets, TCP packets, TLS packets for HTTPS traffic, etc. Here we don't investigate the packets in detail. We want to learn about the systems which are interacting with us. So go to Statistics menu and select Conversations. There are 5 tabs in the conversation window by default. And we're on the IPv4 tab at the moment. Here there are IP packets grouped by address A and address B. In each line, we see how many packets sent up to now, total size of the packets in bytes, number and size of the packets from A to B and from B to A, etc. There is traffic between 8.8.8.8 and my Kali. Now I know that 8.8.8.8 is the IP address of Google DNS, so I must have set the Google DNS as the DNS of my Kali. I'd like to look at the network config. And yes, my DNS address is 8.8.8.8. In the Ethernet tab, we can see the MAC addresses of the systems. The addresses full of Fs mean that the packet is broadcasted. ARP requests are the examples for these kind of packets. In the TCP tab, we can see TCP packets grouped by the addresses and this time by ports as well, because a system may have different interactions with any other system. For example, Kali may have HTTP traffic through port 80 and at the same time, it may have an SSH connection through 22 as well. Same as TCP. Packets are grouped by IPs and ports in the UDP tab. Here we have learned a lot of live systems, IP addresses, and MAC addresses just listening to the traffic go through our network interface. If you'd like to investigate the traffic between the two machines, select the line, right-click. If you choose Apply as Filter from the menu, only these kinds of packets will be seen in Wireshark. I'll choose Find at this time. As you see, automatic query string is prepared. I can navigate between the packets by clicking the Find button. Go back to the conversation window. At the bottom right, there is a Conversation Types button. When you click on it, a lot of different protocols are listed. These selected 5 are the default selected protocols. You can add any protocol from the list. When you select one of them, a new tab is added to the conversation window. Active scanning is done through sending multiple probe requests and recording the probe responses. Because passive scanners are limited to looking at existing traffic, they suffer in terms of overall completeness and accuracy. For example, a passive scanner can't detect an application that no one ever uses, and it can be fooled easily by a system intentionally spewing out misinformation and disinformation. The tools seen on the slide are a few examples of active scanning tools. In this course, we will examine the Nmap and Nessus tools in detail. Hping is an excellent command-line-oriented TCP/IP packet assembler analyzer. The interface is inspired by the ping 8 Unix command, but Hping isn't only able to send ICMP echo requests. It supports TCP, UDP, ICMP, and raw IP protocols, has a traceroute mode, the ability to send files between a covered channel, and many other features. So a subset of the stuff you can do using Hping: firewall testing, advanced port scanning, network testing using different protocols, TOS fragmentation, manual path MTU discovery, advanced traceroute under all the supported protocols, remote OS fingerprinting, remote uptime guessing, and don't forget TCP/IP stacks auditing. Hping can also be useful to students that are learning TCP/IP. Although it's a packet analyzer tool, it's widely used for DOS, denial of service, tests and attacks to create IP-spoofed packets and send them to the target system. Let's see how we can use the Hping command to scan the network simply. Go to Kali and open a terminal screen. Hping 3 is embedded into Kali and defined in the path, so you can use it anywhere, just typing the name of the command, Hping 3. Type hping3-h or hping3-help to see the detailed usage of the Hping 3 command. Let's look at a few parameters important for scanning mode. Under the mode title, we have a scan mode, and the help shows a sample usage of the mode as well. We'll use scan or 8 parameter to use Hping in scan mode. Under TCP UDP title, we have the parameters to set the flags of TCP or UDP packets. Well, you'll see the flags and meaning in this course in following lectures, so just see the Hping in action now. For example, uppercase S, or SYN parameter, is used to set the SYN flag of TCP or UDP packets. Let's prepare the Hping command to make a network scan. The first parameter is scan, to use Hping in scan mode. Here we should say in which ports we will scan. In this example, 0 to 500 means that the ports between 0 and 500 will be scanned. You can give a port range like this with a dash between the lower bound and the upper bound, or you can give the ports one by one, separating them by a comma, or you can use a combination of these two. Now I want to set the SYN flag of the packet, because all TCP connections start with a SYN packet. Well, again, we'll show you how a TCP handshake is made later on in the following lectures. Here comes the IP address to scan. Hit Enter to start the scan. Here we have the responding ports, and the flags column says what the reply is. We sent SYN packets and get SYN ACK packets. That means ports are accessible and open to us. Now let's make another scan. This time, I'll use uppercase X to make a Christmas scan. In this scan, push, urgent, and fin flags are set in the packet, which is not seen in regular traffic. Since the packets they received are not valid packets, they've dropped them and returned no response. Although it's not the subject of our course, because it's very common usage, I'd like to show you how to perform an IP-spoofed DOS, or denial of service attack, using the Hping tool. I'm going to attack my own server. First, I'll test if I can connect to the application. So open a terminal screen and ping the application www.owaspbwa.com. Okay, I have a connection through the application. Open a browser and visit the website. Here I click a few links to show the response time of the server. Oh, okay, it's really fast. It responds as soon as I click onto links. Now let's prepare the Hping command to prepare a DOS attack. The first parameter of the command is -flood. You know what? Let's run hping 3-help in another terminal screen to see the meanings of the parameters. Flood parameter is used to send packets as fast as possible. To make it a SYN flood attack, I set the SYN flag using -s parameter. When I send a SYN packet, since it's a legitimate TCP handshake starter, the server will try to respond to all the packets at the start of the TCP communication. So the server will be very, very busy. -v is to open verbose mode. That means we'd like to see the results of sent packets. The next parameter is rand source. This parameter will randomize the source IP addresses as if they are requested by different systems. So the attack is distributed denial of service now. And since the IP addresses are random, the victim doesn't know about you. Give the target domain as a last parameter. Oh, by the way, the order of the parameters is not important. Hit Enter to start the attack. And because we're in flood mode, no replies is shown. Let's try to click a few links to see the response time of the server while it's under attack. Click a link. It's waiting. It's obviously slowed down. Maybe our request will be timed out? So this is how a simple denial of service attack is performed. I'll stop the flood by stopping the run of the command using Control-C keys. As you see, in less than a minute, we sent more than 1 million SYN packets to the victim server. No packets received because we randomized the source IP addresses of the packets. That means the responses were sent to different IP addresses. This is why we didn't receive any packets. Since I stopped sending packets, the server is now responding in good time again. Now let's repeat the attack while Wireshark is running to see what's happening under the hood. Start Wireshark. Since we're using the ETH0 interface of Kali, I'll double-click the ETH0 on the home screen to start to listen to the traffic passing through the ETH0 interface. There's still some packets on the queue because of our previous attack. I restart capturing by pressing the green button at the upper left corner of Wireshark to clean the screen before the second attack. Continue without saving. Okay, Wireshark is running and clean. We're ready to repeat the attack. You can see the number of packets at the bottom of Wireshark. As you see, we sent hundreds of thousands of packets in seconds. So let's talk a little bit about the network and data link layer security. Why is it important, and how can we classify the network layer attacks, etc.? When the OSI model was introduced, there was no thinking of any type of security. Security just wasn't part of the design of either the OSI or TCP/IP models. Further, while there may be OSI layers, there are not necessarily protocols that correspond to them. You see, OSI was built to allow different layers to work without knowledge of each other. So any compromise in lower levels directly affects the higher levels. As a result, a system is as secure as its weakest link. In other words, security is as strong as the weakest link, right? So when it comes to networking, layer 2 is one of the weakest links. The protocols developed in the early years of the internet did not require a quality of service, QoS. For example, short delays in the protocols could be ignored. So the key principles of information security, CIA triad, confidentiality, integrity, and availability, were not integrated into the protocols, or they are really weak. So we can classify the network and data link layer attacks according to the effects of the attacks. Right? So these classes are denying the traffic between two hosts, sniffing or listening to the traffic, compromising the transferred data, and spoofing. So let's have a look at the network sniffing methods first. We're going to learn how to listen to the network traffic and how to use some tools such as TCP dump and Wireshark. During the penetration test, we listened to the network traffic for many good reasons. First of all, it's possible to obtain the clear text critical information, such as usernames, passwords, instant messages, emails, and all that. We can check to see if the scans work correctly. And some controls can be seen by listening to the network interface, such as if the scan parameters are set correctly, packets are properly exported from the network interface, and responses are received. Listening to the traffic, using passive scan methods, we can collect information about IP addresses, services running on server systems, and protocols and technologies used in network infrastructures, etc., etc. TCP dump is a free open source, very common, and fast packet analyzer that runs under the command line. It prints out a description of the contents of packets on a network interface that match the Boolean expression given as a parameter. TCP dump has a lot of filtering options. We'll discuss some of them in the next slide. It can be preferred to the other packet analyzers, such as Wireshark, because it's so fast. It also supports some of the most common network traffic capturing format, PCAP. You can save the results as raw ASCII text in a document as well. So have a look at this. These are some of the parameters you can use with the TCP dump command. D, or list interfaces, prints the list of the network interfaces available on the system and on which TCP dump can capture packets. I, or interface, listens in on the interface. If unspecified, TCP dump searches the system interface list for the lowest numbered configured interface, excluding loopback, which may turn out to be, for example, ETH0. N means do not convert addresses, that is, host addresses, port numbers, etc., to names. V produces verbose output when parsing and printing. The more V, the more details. W writes the raw packets to specified file rather than parsing and printing them out. R reads packets from the file which was created with the W option or by other tools that write PCAP or PCAPing files. A prints each packet in ASCII. Handy for capturing web pages. When parsing and printing, in addition to printing the headers of each packet, capital X prints the data of each packet in hex and ASCII. This is very handy for analyzing new protocols. So if you use the X option, the data of each packet is printed in hex. In addition to these options, you can filter the results in several ways. If you would like to monitor a specific protocol, such as TCP, you can use its name as the filter. You can capture packets to or from an endpoint residing in the network using net filter, or use host filter to see the packets of a host as a source, destination, or either one. Use the port to filter TCP or UDP packets sent to or from a specified port. Use port range to listen to ports in any given range. Now, if you use the SRC option, you can see only the packets where the target system is the source of the packets. Similarly, DST is used to specify the destination system. So, of course, you can use more than one filter in a command and set up the relation using and or as logical operators. For example, host is 1.1.1.1 and port is 80. Now, before running several TCP dump commands, let's examine the fields of a typical TCP dump output row. The row shown in the slide is a TCP packet. The first field is the time when the packet arrived, with a timestamp as hour, minute, second, and, well, the fractions of a second. So the second field is a protocol running atop the link layer, in this case, IPv4. Now for IP packets, the third field is the IP address or host name of the host sending the packet, along with, for TCP and UDP packets, the source port. The packet on the slide came from port 80 of the system 172.16.99.139. Now the fourth field is the IP address or host name of the host receiving the packet, along with, for TCP and UDP packets, the destination port. Flags is the TCP segment flag. The packet on the slide doesn't have any flags set other than ACK. ACK is the acknowledgement number in the packet. TCP dump shows sequence and acknowledgement numbers relative to the initial sequence number by default. Win is the source host's TCP window, and you see the options field. Length is the length of the data in the TCP segment. Length here is 0, so that means that no data is exchanged yet. So that's enough for now. Let's see TCP dump in action. Time for hands-on. Okay, so before we talk about how to expand the sniffing space, let me explain the active network devices and the routers, hubs, and switches. Hub is commonly used to connect segments of a LAN, which is a local area network, and a hub contains multiple ports. When a packet arrives at one port, it is copied to the other ports so that all the segments of the LAN can see all of the packets. Hub acts as a common connection point for devices in a network. Now, switch operates at the data link layer, layer 2, and sometimes the network layer, which is layer 3 of the OSI reference model, and therefore support any packet protocol. Now, LANs that use switches to join segments are called switch LANs, or in the case of Ethernet networks, switched Ethernet LANs. In basically all networks, switch is a device that filters and forwards packets between LAN segments. A router is connected to at least 2 networks, commonly 2 LANs or WANs, which are the wide area network, or a LAN and its ISP, which is the Internet Service Provider's network. Router is generally located at gateways, the places where 2 or more networks connect. Using headers and forwarding tables, router determines the best path for forwarding the packets. And in addition, the router also uses protocols such as ICMP, Internet Control Message Protocol, to communicate with each other and configures the best route between any 2 hosts. So, in a word, router forwards data packets along networks. Now let's compare the hub and the switch, since both of these 2 devices have similar roles on the network. Each serves as a central connection for all of your network equipment and handles a data type known as frames. Frames carry your data. When a frame is received, it is amplified and then transmitted onto the port of the destination PC, which is typically a personal computer. The big difference between a hub and a switch is in the method in which frames are being delivered. You got that? In a hub, a frame is passed along or broadcast to every one of its ports. It doesn't matter that the frame is only destined for one port. The hub has no way of distinguishing which port a frame should be sent to, right? So passing it along to every port ensures that it will reach its intended destination. Now, this places a lot of traffic on the network and can lead to poor network response times. You can only imagine, right? Besides, the frame is received by the unintended nodes, which could be hackers. And in a cybersecurity point of view, what about the confidentiality? And additionally, on a 10100 megabit per system hub, it must share its bandwidth with each and every one of its ports. So when only one PC is broadcasting, it will have access to the maximum available bandwidth. However, if there are multiple PCs broadcasting, then that bandwidth will need to be divided among all of those systems, which will degrade performance for everybody. So in comparison, a switch keeps a record of the MAC, which is the media access control address of all the devices connected to it. With this information, a switch can identify which system is sitting on which port. So, when a frame is received, it knows exactly which port to be sent to, without significantly increasing network response times. And in addition, unlike a hub, a 10100 megabit per second switch will allocate a full 10100 megabits per second to each of its ports. So regardless of the number of PCs transmitting, users will always have access to the maximum amount of bandwidth. That's important. So it's for these reasons that a switch is considered to be, well, let's say a much better choice than a hub, right? Good. So switches make it difficult to sniff the network traffic. In the past, the traffic was being sent to all ports with the hub technology. With switches, the traffic is directed only to the specified port. So a network device only receives its own packets, not the others. So we need to use some techniques to sniff the traffic of the other devices then, huh? These are some of the techniques to expand the sniffing space. You thought it couldn't be done. So we'll talk about SPAN, Switched Port Analyzer, or port mirroring. So that's a method of monitoring network traffic. With port mirroring enabled, the switch sends a copy of all network packets seen on one port or an entire VLAN to another port where the packet can be analyzed. Port mirroring is supported by almost all enterprise-class switches that I can think of. So, in other words, managed switches. It allows a particular computer to see the network traffic, which is normally hidden from it. You can monitor the entire traffic sent from the switch by copying its uplink port. Now, you have to have physical access and the admin privileges on that switch. So this method is often used to send the network traffic to the IDS, which is typically an intrusion detection system device. In a MAC address table overflow attack, also known as MAC flooding attack, within a very short time, the switch's MAC address table is full with fake MAC address and port mappings. Switch's MAC address table has only a limited amount of memory, and when that table is full, the switch cannot save any more MAC addresses in it. So once the switch's MAC address table is full, and it can't save any more MAC addresses, it generally enters into a fail open mode, and it starts behaving like a network hub. Frames are flooded to all ports, similar to broadcast type of communication. So as an attacker in the network, you start to receive the frames of others. You know, Address Resolution Protocol, ARP, or ARP, is a network layer protocol used for mapping a network address, such as an IPv4 address, to a physical address, such as a MAC address. A system asks for the owner of an IP address by sending an ARP request, and the owner of the IP address answers him with an ARP reply. What if the attacker replies first, before the owner of the IP? Once the attacker's MAC address is connected to an authentic IP address, the attacker will begin receiving any data that is intended for that IP address. This is the basic principle of ARP spoof attacks. ARP poisoning can be achieved because of the lack of authentication in the ARP protocol, so the attacker can send a spoofed ARP message onto the LAN. Would you like to make the attack much more powerful? I suspected as much. Then you've got to replace your MAC with the gateway. So every packet sent by the victim will be in your malicious hands. But we are ethical hackers, remember. Dynamic Host Configuration Protocol, DHCP, is a protocol used to provide automatic and central management for the distribution of IP addresses within a single network. It's also used to configure the proper subnet mask, default gateway, and DNS server information on the particular device. Now, similar to the other types of spoofing attacks, DHCP spoofing involves an attacker pretending to be someone else, in this case, acting as the legitimate DHCP server. Since DHCP is used to provide addressing and other information to clients, losing control of this part of the network can be very dangerous. In DHCP spoofing attacks, the attacker places a rogue DHCP server on the network, and as clients are turned on and request an address, the server with the fastest response is used. If the device receives a response from the rogue server first, the rogue server can assign any address as well as control which device it uses as a gateway. So a well-designed attack can collect traffic from local hosts to a rogue server that logs all traffic and then forwards out the traffic to the correct gateway or to the device. So this action would be almost transparent. Thus, the attacker can steal information almost invisibly. The foundation of a MAC flood is to make a switch behave like a hub. As I mentioned before, a hub sends the packet it receives to all of its ports. However, a switch sends the packet only to the target system. So if we can make the switch behave like a hub, then it would send the packet to all of its ports. and I could listen to the traffic even though I'm not the target. In a MAC flooding attack, within a very short time, the switch's MAC address table is full with fake MAC address and port mappings. Once the switch's MAC address table is full, and it cannot save any more MAC addresses, it generally enters into a fail open mode, and it starts behaving like a network hub. Ethernet switches uses MAC address tables to determine where to forward traffic on a LAN. So let's go step by step to understand how the MAC address table is built and used by an Ethernet switch to help traffic move along the path to its destination. Now suppose that all of the devices connected to the switch are powered on but have not sent any traffic yet. In this case, the MAC address table of the switch would be empty. Now suppose computer A wants to send traffic to the server. It prepares an Ethernet frame and it sends it off toward the switch. The first thing the switch would do when receiving the traffic is to create a new entry in its MAC address table for computer A's MAC address. Makes sense? The switch then performs a lookup on its MAC address table to determine whether it knows which port to send the traffic to. And since no matching entries exist in the switch's table, it floods the frame out all of its interfaces except the receiving port. Because the frame was sent out to all the switch's other ports, it is received by the target server as well. Then the server sends a new frame back toward the switch. The other systems which receive the frame do nothing. The switch receives the frame and creates a new entry in its MAC address table for the server's MAC address. It then performs a lookup of its MAC address table to determine whether it knows which port to send the server's traffic to, and in this case, it does. So it sends the return traffic out only on the port of computer A, without flooding. So this process repeats as devices continue to send traffic to each other. An important detail to remember is that the MAC address table timeout is typically short. So for example, default timeout duration of Cisco switches is 5 minutes. So an entry is left in the table itself only for that specified amount of time before the timeout expires and the entry is removed from the table. Let's look at the switching mechanism with a cybersecurity point of view. The mechanism has two weaknesses in it. First, when the target MAC address is not in the MAC address table, the frames are flooded out of all the ports, so unintended systems on the network are capable of sniffing these frames. The second weakness is that when the MAC address table is full, no new record is accepted. So what if I fill the table by announcing thousands of fake MAC addresses from a port of the switch? Most of the switches start to behave like a network hub in such a situation, which means they send each frame to all of the ports. So look at the page seen in the slide. This is the manual page of the macof command. Macof is a command line tool mainly used to flood the switch on a local network with random MAC addresses. So as I mentioned before, when the switch receives a frame, it creates a new entry in its MAC address table for these MAC addresses. Once the switch's MAC address table is full, and it cannot save any more MAC addresses, it generally enters into a fail open mode, and it starts behaving like a network hub. So let's see macof command in action. So here's a network that I created in GNS3. Well, the IP addresses are different from the one that I created in the previous lectures, but not to worry, it's completely identical with that network. So in addition, I've added some other VMware VMs, OWASP, Broken Web Applications, and Metasploitable in the same way with Kali. Now just a little word of caution, while you're adding a VMware VM to a GNS3 network, do not forget to create a new custom network mode such as VMnet2, because all VMs need a separate custom network mode. Remember that. Okay, so now I'll go to Kali. Since Kali is a part of the GNS3 network, its network settings is custom, so it's not in NAT mode right now. Have a look at the IP address using ifconfig. Okay, so it's in 192.168.10.024 IP block. So now check the entire network. I go over to the other VMs and look at the interface configurations. These are the IP addresses of all the VMs. Now go to Kali and ping them. The results are pretty good. We got the reply packets for ping requests. So now I open another terminal screen and scan these two VMs and see the open ports and running services. So I'll simply use the nmap command with the IP address only. So it'll be a SYN scan, and the top 1,000 ports will be scanned. Here are the results. 10.11 has 9 open ports, and 10.12 has 23. And as you see here, telnet port of the 192.168.10.12 is open. So let's go to the VMs. 10.12 is Metasploitable, and 10.11 is OWASP BWA. Now, we know the telnet service is running on Metasploitable. So to create some traffic and let the switch fill the MAC address table, I'll start up a telnet connection from OWASP BWA to Metasploitable. Type telnet and the IP address of Metasploitable. Enter the username and password, which are already given as a welcome message here. And we got the session. Okay, so we can exit now. Now I'll go to the console of the switch and type show MAC address table dynamic to see the dynamic records of the MAC address table. Now here there are 6 port and MAC mappings for now. Run the command again, and now we have 2 rows. So it seems, by the look of this, that the MAC address table aging is 10 or 15 seconds. Okay, you ready for this? This is the time of MAC flooding. So now I'm in a terminal screen on Kali. Have a look at the manual of macov command first. So type man macov and hit enter. Macov is a tool that's used to flood the local network with random MAC addresses. And here are the options. I, to identify the network interface to attack. N, to specify the number of packets to send. D, to specify the destination system's IP address, etc. So let's create the command. Of course, the first command I'll send is macov. I, the interface that's used to attack, will type that in as eth0. D, the destination, the ether switch router. Now we're ready to run the command, so hit enter. And the MAC flood started, and macov sends tens of packets in seconds. Now let me go to the ether switch router console and look at the dynamic MAC address table again. You can call the last command by using the up arrow key. And as you see, there are a lot of rows for our fast Ethernet 1.0 port, which is used for calling. So while macov is running, let's run Wireshark and try to listen in to the traffic on the telnet of Kali's own network interface. Now to see only the telnet traffic, type telnet in the filter box and click the blue button next to the box. Okay, no telnet traffic for now. Now I go back to the OWASP BWA VM and telnet to the Metasploit VM again. Telnet, the IP address of Metasploitable, username and password. Run a command. Okay. So back to Kali. You see the telnet traffic here. Kali is neither the source of the traffic nor the destination. It receives the telnet traffic. Now, this is a typical in hub behavior to send packets to each node, so we can say that our switch is behaving like a hub now, just like we predicted. So let's go ahead and stop Wireshark and the macov command using Control-C keys. You can do that. These are the telnet packets. Since telnet is a clear text protocol by default, we can see the payload as well as the metadata. We can see every character in a different packet. So select one of them. Right-click, follow, and select TCP stream. So the red characters here are client packets. The blue characters are the server packets. Here's a credential, username, and password. So I bet you're hoping to learn how to prevent MAC flooding attacks, and you've come to the right place. To prevent the MAC flooding attacks, network operators usually rely on the presence of one or more features in their network equipment. With a feature often called port security by vendors, many advanced switches can be configured to limit the number of MAC addresses that can be learned on ports connected to end stations. Many vendors allow discovered MAC addresses to be authenticated against an authentication, authorization, and accounting or AAA server, and subsequently filtered. Implementations of IEEE 802.1x suites often allow packet filtering rules to be installed explicitly by a AAA server based on dynamically learned information about clients, including the MAC address. Security features to prevent ARP spoofing or IP address spoofing, in some cases, may also perform additional MAC address filtering on unicast packets. However, this is an implementation-dependent side effect. An ARP spoof is performed replying to an ARP request before the real owner of the IP address. Because of the lack of authentication mechanisms in ARP protocol, you're able to set yourself as the owner of the IP in the source machine's ARP table. Okay, to understand the ARP spoof or ARP cache poisoning attack, let's remember the ARP protocol and its principles once again. Address Resolution Protocol, ARP, is a network layer protocol used for mapping a network address such as an IPv4 address to a physical address such as a MAC address. To simulate how the ARP mechanism works, we have a small network in the slide, a switch on top, and 3 computers connected to it. Computer A wants to talk to computer C. It puts an ARP request onto the wire, which happens to be broadcast. Essentially what it's saying is, who has computer C's MAC address? Of course, because it's a broadcast, every system on the network hears it. Does everybody respond? Well, what happens is that B hears that A is looking for the MAC address of computer C. B knows that it's not computer C and therefore does not respond to the broadcast. The broadcast, the ARP request, goes out to every system, but the only system that will reply is computer C with an ARP reply. In other words, computer A says, who has the MAC address of computer C? And although all the workstations hear the question, only C replies and says, I've got the MAC address of computer C, and this is what it is. So the ARP reply sends back the MAC address to computer A, and each of these machines start building an ARP table. These are how ARP requests and responses look in Wireshark. The first packet is an ARP request. As you see, it is broadcast. And the second packet is an ARP reply. The owner of the IP 207 answers with its MAC address. As you see, ARP request is broadcast throughout the network, and the first reply is trusted and accepted. Okay, so we have already seen the routine of the ARP protocol. Computer A sends an ARP request. The request is broadcast. The owner of the IP replies with an ARP reply, and both sides update their ARP tables. Now we have an attacker in the network. Okay, so this is how the ARP spoof attack works. Computer A wants to talk to computer C. If the MAC address table of computer C is not in the ARP table of computer A, it puts an ARP request into the wire, which happens to be broadcast. This is the point where all the computers on the network get the ARP request. So although it's not his IP address, the attacker replies the ARP request before the real owner. In this ARP reply, the attacker puts his own MAC address corresponding to the target IP address. Computer A receives the ARP reply and stores the address pair in its ARP table, and communication takes place. Oh yes, there's plenty more to do. There are several tools to perform an ARP spoof attack, such as ARP spoof, the command line tool which is embedded in Kali. But we're going to use Edercap for the demonstration of the ARP spoof attack. Edercap is a free and open source network security tool for man-in-the-middle attacks on LAN. It works by putting the network interface into promiscuous mode and by ARP poisoning the target machines. Thereby, it can act as a man-in-the-middle and unleash various attacks on the victims. Edercap has both a command line interface version and a graphical user interface version. Let's see them both in action. First, let me show you the command line version of Edercap. So this is my network created in GNS3. I have a Kali, an OWASP BWA, and a Metasploitable VM in the network. So use ifconfig inside the VMs to check the IP addresses and the other interface configurations as well. So ping each other to be sure that they can communicate. Okay? Now I go to Kali, open a terminal screen, and do the same here. Check the interface configuration and ping other VMs. Yep, everything's okay. So let's look at the ARP table of Metasploitable. Type ARP-N and press enter. So currently there are 2 records in the ARP table of Metasploitable, one for Kali and one for OWASP BWA. Now let me show you something. If you want to perform an ARP spoof attack, you should enable IP forwarding in your attacker system so that the packets will not end on your attacker system and be forwarded to the destination system. Otherwise, you'll block the traffic between the victim and the spoofed system. Check that out. So the IP address is managed by a variable IP forward, like in Kali. And to look at the file content, type cat/proc/sys/net/IPv4/IP forward and press enter. Its value is 0. So to enable it, it has to be 1. So I'll change it. You can open the file with a text editor and change the value, but here I'll just simply use the echo command for this purpose. Echo 1 greater than sign the entire file name. So check the file again. And yes, its value is now 1. Now, please note that Edercap enables IP forwarding automatically, even though you don't enable it manually. All right, I want you to know what's happening behind the scenes, so to speak. All right, so now's the time of the attack. Before creating the command, let's see the manual of Edercap. So type man Edercap and press enter. So here's the short definition and the long description. Targets, options, M for man in the middle, MIT-M attack. So these are the MIT-M attack types. ARP is at the first line, and the others, ICMP, DHCP, etc. And here are the user interface options. T for the text-only interface. Anyway, let's just create the command. So first, the command itself, Edercap. I, the interface, E the 0, T for the text-only interface type, M to make it a MIT-M attack, and select the MIT-M attack type, ARP, column, remote. So the first IP specifies the IP address which will be spoofed, and the second IP address is the victim system. So that means there will be a row in the Metasploitable's ARP table with a Kali's MAC address and OWASP BWA's IP address. And that means when Metasploitable wants to send a packet to OWASP BWA, it will be sent to Kali instead, right? And with the help of IP forwarding, the packet will arrive at OWASP BWA finally. Now, please don't forget to use these slashes at the beginning and end of each IP address. The command is ready to run. So, let's see what it does. Hit enter. And here's a summary of the attack, the victims, interface type, etc. Now I'll go to Metasploitable, ARP-N, to see the ARP table again. And as you can see here, the first record is for Kali. So please look at the MAC address. And the second record is for OWASP BWA, but with the attacker's MAC address. Any packet sent from Metasploitable to OWASP BWA will visit Kali now. So let's create a telnet connection to port 80 of OWASP BWA. Type telnet OWASP BWA IP and the port 80. Now hit enter. Type get/http/1.0 and press enter twice. And here is the HTTP response. the main page of OWASP BWA. Now let's go back to Kali and see what happens. So these are all the TCP packets sent from Metasploitable to OWASP BWA. ACK packet, FIN packet, and scroll up a bit, and here's the telnet connection results. HTTP response. Keep going up. We can find some other critical data here too. And here's some credentials, for example. In the terminal screen where Edercap is running, you can use Control-C to end the attack. So there it is, it stopped. Now go back to Metasploitable and look at the ARP table again. Now the IP address of OWASP BWA is matched with the correct MAC address. Now you might remember what I told you before that, well, I hope you remember everything that I told you before. But, in particular, Edercap has a graphical user interface as well. So let's have a look at Edercap's GUI right now. Again, we're in Kali. Click Show Applications menu item and type Edercap. And here you go, you'll find the Edercap GUI app. So these are both Edercap GUI apps. You can just simply click one of them. I want to show you, though, another way to start the app. From the upper left corner, Applications, go to Sniffing Spoofing Tools, and select Edercap GUI. Okay, so here we are at the main panel of the Edercap GUI. We'd better check the network, so I'll open up a terminal screen and ping the other VMs, Metasploitable and OWASP BWA. Yeah, everything looks okay. So go to the Sniff menu in Edercap and select Unified Sniffing. Asking for input interface, ETH0 is good. Click OK. If you look at the Edercap menu, it's totally different now. So go to Hosts and select Scan for Hosts. It's a kind of a ping scan to find out the devices of the network. It found 5 devices and added them to the hosts list. So go back to Hosts again, and now select Hosts Lists. And here's a list. Very nice. Works well. 192.168.10.11 is OWASP BWA. So this is the system that will spoof. So select it and click Add to Target 2. So 192.168.10.12 is Metasploitable. That's our victim. So we'll change its ARP table, select it, and click Add to Target 1. I think now we're ready to attack. What do you think? All right, so let's go to MIT-M and click ARP Poisoning. Okay, check the Sniff Remote Connections option and click OK. And the final step, go to Start and select Start Sniffing. So the attack has begun. Let's go to Metasploitable and see the attack result. To see the ARP table, type ARP-N and press Enter. The first row is for OWASP BWA, but the MAC address is Kali's MAC. To show it, now I'll ping Kali to create the ARP record. Run the ARP command again, and now I have another row for Kali. And both Kali and OWASP BWA have the same MAC address. Okay, you know the rest. The packets will be sent to Kali instead of OWASP BWA, so if you'd like, you can open Wireshark and collect the fruits of your labor. Enjoy it. Now, similar to the other types of spoofing attacks, Dynamic Host Configuration Protocol, DHCP, spoofing, involves an attacker pretending to be someone else. In this case, acting as a legitimate DHCP server. Since DHCP is used on most networks to provide addressing and other common information to clients, losing control of this part of the network can be dangerous. Dynamic Host Configuration Protocol, DHCP. Now, it's a protocol used to provide automatic and central management for the distribution of IP addresses within a network. It's also used to configure the proper subnet mask, default gateway, and DNS server information on the device. In most homes and small businesses, the router acts as a DHCP server. In large networks, a single computer might act as a DHCP server. In short, the process goes like this. A device, the client, requests an IP address from a router, the host, after which the host assigns an available IP address to allow the client to communicate on the network. So let's look at some of the advantages of using DHCP. A computer or any other device that connects to a network, local or internet, must be properly configured to communicate on that network. Makes sense? Since DHCP allows that configuration to happen automatically, it's used in almost every device that connects to a network, including computers, switches, smartphones, gaming consoles, you name it. Now, because of this dynamic IP address assignment, there's less of a chance that two devices will have the same IP address, which is very easy to run into when using manually assigned static IP addresses. Using DHCP also makes a network much easier to manage. From an administrative point of view, every device on the network can get an IP address with nothing more than their default network settings, which is set up to obtain an address automatically. So that's easy, gives them nothing to call the help desk about. The only other alternative is to manually assign addresses to each and every device on the network. You're not getting paid enough to do that. So because these devices can get an IP address automatically, they can move freely from one network to another, given that they're all set up with DHCP, and receive an IP address automatically, which is super helpful with mobile devices. Now, as a cybersecurity expert, you should know one more thing about the DHCP mechanism. The first device which replies to a DHCP discover request decides the configuration of the client. There is not any mechanism to authenticate the DHCP server. Similarly, a DHCP server tries to reply to all the DHCP requests, and again, there is no authentication mechanism for the clients who request an IP. You get it? I think you do. What if a hacker replies before the real DHCP? Or what if a client sends a lot of DHCP discovery requests by changing the MAC address each time? So let's have a look to see how a DHCP mechanism works in detail. Once a device is turned on and connected to a network that has a DHCP server, it will send a request to the server called a DHCP discover request. After the discover packet reaches the DHCP server, the server attempts to hold on to an IP address that the device can use and then offers the client the address with a DHCP offer packet. Once the offer has been made for the chosen IP address, the device responds to the DHCP server with a DHCP request packet to accept it. After which, the server sends an ACK packet that's used to confirm that the device has that specific IP address and to define the amount of time that the device can use the address before getting a new one. If the server decides that the device cannot have the IP address, it will send a NAC. Let's see the DHCP server mechanism in Wireshark. So Wireshark is already embedded into Kali and it's ready to use. In addition, I'd also like to show you how to download and install it in a Windows system. So right now I'm in a Windows 8 system. Open the internet browser and search for Wireshark for Windows, using those as the keywords. First link is the download page of wireshark.org. So let's click it. My Windows is 64-bit, so I'll download the 64-bit, which is the latest stable version. Click it and save the installer. Now it takes less than a minute, unless your connection is a mess. You might want to look into that. Just kidding. Click to run it. The setup wizard opens. Okay, so simply it's a next finish installation. No need to change anything. Wait until the installation finishes. Okay, so check this to run Wireshark now and click Finish. And welcome to the Wireshark and Windows interface. So now I will show you the DHCP mechanism in Wireshark. So let's run Wireshark, and you can see that it's listing the packets received by ETH0. So to demonstrate the DHCP mechanism, we need to ask for an IP address over at the DHCP server. From the bottom right corner, right-click to the network icon and select Open Network and Sharing Center. Click Ethernet 0 and then Properties. You'll have to scroll down a little bit and double-click IP version 4. And as you see here, the IP address is manually set for my Windows 8. So to start a DHCP request, I'll choose Obtain an IP address and DNS server address automatically. Those are my options. Now, before I click OK, I'll go to Wireshark and restart capturing by clicking the green button on the toolbar. So now Wireshark Windows will be cleaned. Continue without saving. So now go to the network status window and click OK. And we can close all the networking windows. So Wireshark captured the packets. Well, it's still capturing, but let's go to the top of the list to find the DHCP packets. So here the DHCP Discover packet is right here at the top of the list. When we look at the ports in the UDP header, we see that the port 68 is used to send DHCP Discover packets. So let's go back to the filter box and type UDP port equals 68, and now we have the DHCP packets only. So the first packet is DHCP Discover. And as I mentioned before, it's broadcast. Source IP is all zeros because we don't have an IP address at the moment. Destination IP is all ones, 255.255.255.255 because it's a broadcast packet. And right here is Bootstrap Protocol, which is an application layer protocol used by DHCP mechanisms. The second packet is a DHCP offer packet sent by the DHCP server, 172.16.99.254 to the Windows system. The destination IP is 172.16.99.233, which is offered to the DHCP server. So in here, the destination MAC address is important. That's what's going to be targeted according to the MAC address. So as you see, the destination MAC address of the DHCP offer packet is the same as the source MAC address of the DHCP Discover packet. Now the third packet is the DHCP request sent by the Windows system. It's still a broadcast packet and the source IP is still all zeros. The message is request and the requested IP address is an option 50. So if you expand it, you see the requested IP address. And it's the same as the offered IP address 172.16.99.223. The last packet is DHCP ACK, sent by the DHCP server to the Windows system. This packet completes the DHCP mechanism successfully. So from now on, the IP address of our Windows system is 172.16.99.223. In DHCP spoofing attacks, the attacker places a rogue DHCP server on the network. There are two main features of the DHCP mechanism that emerges the DHCP spoofing attack. First, there's no authentication process and priority in the DHCP mechanism. Second, as clients are turned on and request an address, the server with the fastest response is used. So if the device receives a response from the rogue server first, the rogue server can assign any address as well as control which device it uses as a gateway. So a well-designed attack can funnel traffic from local hosts to a rogue server that logs all the traffic and then forwards that traffic out to the correct gateway to the device. And this action would be almost transparent, right? Thus, the attacker can steal information pretty much invisibly. How are you going to find that? That's why you're here. Let me clue you in on another important point. While setting up a rogue DHCP server, we cannot be so sure whether the client received the settings of the rogue server or the legitimate server. That's why it's way better to use the DHCP spoofing attack with the DHCP starvation attack. All right? In a DHCP starvation attack, an attacker broadcasts a large number of DHCP request messages with spoofed source MAC addresses. If the legitimate DHCP server in the network starts responding to all these bogus DHCP request messages, available IP addresses in the DHCP server scope will be depleted within a very short span of time. Now, once the available number of IP addresses in the DHCP server is depleted, network attackers can then set up a rogue DHCP server and respond to new DHCP requests from the network DHCP clients. By setting up a rogue DHCP server, the attacker can now launch a whole DHCP spoofing attack. So here is how we can perform a DHCP spoof attack together with DHCP starvation attack. So we'll create a lot of DHCP discovery packets to request new IP addresses from the DHCP server. DHCP server replies to these requests. IP address space is limited. For example, a Class C subnet has about 250 IP addresses available. So since the IP addresses are used for fake MAC addresses, there aren't any more IP addresses for legitimate clients. DHCP cannot respond to the new requests, and the clients which cannot have IP addresses become out of service. So now we'll set up a rogue DHCP server, which is the only server to respond to the client's IP address requests right now. The rogue DHCP server starts distributing IP addresses and other TCP IP configuration settings to the network DHCP clients. TCP IP configuration settings include default gateway and DNS server IP addresses. So now we can replace the original legitimate default gateway IP address and DNS server IP address with our own IP address. Once the default gateway IP address of the network devices are changed, the network client starts sending the traffic destined to outside networks to the attacker's computer. The attacker can now capture sensitive user data and launch a man-in-the-middle attack. So let's see how we can perform a DHCP starvation attack and consume the DHCP pool using Yersinia. Yersinia is a network tool designed to take advantage of some weaknesses in different network protocols. The protocols currently implemented in Yersinia are shown in the slide. Now we're going to use our VMs in NAT mode during this demo. So I'm on my host machine and open the virtual machine library. This is the Kali that I'll use. So click this icon to see the VM settings. Click the network adapter icon. It says Internet is shared with my Mac, so if you look at the explanation in the right-hand side of the frame, it means the VM is in NAT mode. So this is what we want, so just leave it as it is. The Connect network adapter is selected, so Kali is ready to use with a NAT network connection. So Windows 8 is the other VM that I'll use to demonstrate DHCP starvation attack. Let's have a look at the network settings of Windows as well. Yeah, it's in NAT mode, and the network adapter is connected. So I'll disconnect the network adapter by clicking here, because I just want to show you that the DHCP of VMware is working properly. So I want to add a second network interface for my Windows system. Click Show All, and go to the Settings menu, and click on Add Device at the upper left-hand corner. Select Network Adapter and click Add. The details of the new adapter are listed here. The NAT mode is selected by default already. So uncheck the Connect Network Adapter box for now. Okay, so as you see, we have two network adapters for the Windows system. Both of them are in NAT mode and are disconnected. So now I'll start the Windows 8 system. Log in, and sure enough, it's ready. Right-click on the network icon at the lower right corner and select Open Network and Sharing Center. And right there, we don't have an active network at the moment. That's to be expected. So now I connect the first adapter and activate the network. In VMware Fusion, you can see and change the setting in several ways. If you use the VM in full screen mode like I do, just go to the upper side for VMware Fusion menu. There it is. And if the menu does not appear, just press Command and Control buttons together. Right, so this is the default setting of VMware Fusion to turn back to the host system when you're inside a VM. And these are the network adapters. When you click on them, you'll see the short menu for network adapter, and here you can connect or disconnect the network adapter, change the network mode, NAT bridge, or host only, and you can use this pop-up for the network adapter settings. Now, the second way to see and change the network settings is to click the settings icon, then select the adapter to see the settings. So the third way is to go to the virtual machine menu. Go to the network adapter, and you'll see the short menu of the adapter. Now go to the first network adapter icon and click on the Connect Network Adapter menu item. And now you see in the Network and Sharing Center window we now have an active network connection. So click the network name and the details button. Here are the connection details, and right there it is. DHCP is 172.16.99.254, and it assigned an IP address for the VM 172.16.99.221, as well as a gateway and the DNS address. Now I'll go back to Kali and open a terminal screen. Using the ifconfig command to see the network interface configuration, and sure enough, it has the IP address. So ping the Windows 8 system to validate the network, 221. Okay, we receive the ICMP reply, so everything looks okay. Now is the time for Yersinia. So type man Yersinia and hit enter to see the manual. And right here in the manual, Yersinia is a framework for performing layer 2 attacks. And here's a list of protocols implemented in Yersinia. Scroll down. You'll see the options. We can use uppercase G to start a graphical interface. So let's go ahead and use it in graphical mode. You can press Q to quit from the manual and turn back to the terminal. Now type Yersinia, uppercase G, and press enter. So this is the graphical user interface of Yersinia. Before running the attack, let's open Wireshark and monitor the network packets to see what happens when we start the attack. You can type Wireshark in terminal to start it, or just click the Wireshark icon. To select the interface to listen, double-click ETH0. And to discard the different packets and focus only on the DHCP packets, we can filter the packets. In the filter box, type bootp and hit enter. So bootp is the short form of Bootstrap Protocol, which I mentioned earlier. It's basically a computer networking protocol to automatically assign an IP address to network devices from a configuration server. And obviously, it's used by the DHCP server. Now we can turn back to Yersinia and prepare and run the attack. So click Launch Attack. That's the link at the upper left-hand corner. The tabs in the window are the implemented protocols. Choose DHCP and select Sending Discover Packet. Now click OK. As soon as we click the button, Yersinia starts sending dozens of DHCP requests in a second. It'll keep sending the packets till we stop the attack. Now look at the Wireshark window. These are the DHCP Discover packets sent by Yersinia. So now, while Yersinia is sending the DHCP Discover packets, let's activate the second interface of the Windows VM. And let's see if the DHCP server assigns an IP address for the second interface. Alright, so we're in the Windows VM now. Go to the second network adapter, click Connect Network Adapter 2 to activate the second interface. Now, do you remember what happened when we activated the first interface? We saw the new network activated, but now there is still no network because the DHCP server is busy replying to the request created by Yersinia. It's not going to answer the Windows 8 second interface. So let's turn back to Kali and stop the attack. In Yersinia's interface, just click List Attacks and then click Stop or Stop All. In the Wireshark window, look at the bottom of the packets list. We now have a complete DHCP sequence. Discover, Offer, Request, and ACK packets. In the Windows 8 VM, we now have the second network. The first one was Ethernet 02. This one is Ethernet 0. Click on it. In the status window, click on Details. The second interface has an IP address now, assigned by the DHCP server. Now, to be honest, there are a number of different types of VLAN attacks in modern switch networks. The VLAN architecture simplifies network maintenance and improves performance, but it also opens the door to abuse. So it's important to understand the general methodology behind these attacks and the primary approaches to mitigate them. VLAN hopping enables traffic from one VLAN to be seen by another VLAN. Sounds kind of fun, huh? So as we've already seen before, a virtual local area network, virtual LAN or VLAN, is a group of hosts with a common set of requirements, which communicate as if they were attached to the same broadcast domain. regardless of their physical location. VLANs work by applying tags to network packets and handling these tags in networking systems, creating the appearance and functionality of network traffic that is physically on a single network, but acts as if it is split between separate networks. Capiche? So let's take a moment and remember the reasons of why we're using VLANs. Security. Groups that have sensitive data are separated from the rest of the network. Cost reduction. Cost savings result from less of a need for expensive network upgrades. Higher performance. The number of router hops reduces and the apparent bandwidth for network users increases. Broadcast storm mitigation. Every VLAN only receives its own broadcast packets. Improved IT staff efficiency. As we were talking about before, VLANs make it easier to manage the network. It also simplifies the company's management. So here are the basic principles of the switch ports. The ports of a switch is in dynamic desirable mode by default. If the device connected to the port is a computer, the mode of the port becomes access, and the port is dedicated to that computer. If the device is another switch, the mode of the port becomes trunk. So by default, trunk ports have access to all VLANs and pass traffic for multiple VLANs across the same physical link, generally between switches. So switch spoofing is a type of VLAN hopping attack that works by taking advantage of an incorrectly configured trunk port. In a switch spoofing attack, the network attacker configures a system to spoof itself as a switch. So this spoofing requires that the network attacker be capable of emulating 802.1q and DTP messages. By tricking a switch into thinking that another switch is attempting to form a trunk, an attacker can gain access to all the VLANs allowed on the trunk port. So the best way to prevent a basic switch spoofing attack is to turn off trunking on all ports, except the ones that specifically require trunking. On the required trunking ports, disable DTP, Dynamic Trunking Protocol, and manually enable trunking. Another type of VLAN hopping attack is known as double tagging attack. This type of attack takes advantage of the way that hardware on most switches operates. Most switches perform only one level of 802.1q de-encapsulation, which allows an attacker to embed a hidden 802.1q tag inside the frame. This tag allows the frame to be forwarded to a VLAN that the original 802.1q tag did not specify. An important characteristic of the double tagging VLAN hopping attack is that it works even if trunk ports are disabled, because a host typically sends a frame on a segment that is not a trunk link. So let's see how the double tagging VLAN hopping attack is performed step by step. The attacker sends a double tagged 802.1q frame to the switch. The outer header has the VLAN tag of the attacker, which is the same as a native VLAN of the trunk port. Normally, a switch port configured as a trunk port sends and receives VLAN-tagged Ethernet frames. Native VLAN is the only VLAN which is not tagged in a trunk. In other words, native VLAN frames are transmitted untagged. The assumption here is that the switch processes the frame received from the attacker as if it were on a trunk port. In this example, the native VLAN is VLAN 1. The inner tag is the victim VLAN. In this case, it's VLAN 20. The frame arrives on the switch, which looks at the first 4-byte 802.1q tag. The switch sees that the frame is destined for VLAN 1, which is a native VLAN. The switch forwards the packet out on all VLAN 1 ports after stripping the VLAN 1 tag. On the trunk port, the VLAN 1 tag is stripped, and the packet is not retagged because it's part of the native VLAN. At this point, the VLAN 20 tag is still intact, and it has not been inspected by the first switch. The second switch looks only at the inner 802.1q tag that the attacker sent, and sees that the frame is destined for VLAN 20, the target VLAN. The second switch sends the frame onto the victim port or floods it, depending on whether there is an existing MAC address table entry for the victim's host. So the best approach to mitigating double tagging attacks is to ensure that the native VLAN of the trunk ports is different from the VLAN of any user ports, right? In other words, do not let the users use the native VLAN. In fact, it's considered a security best practice to use a fixed VLAN that is distinct from all user VLANs in the switch network as the native VLAN for all 802.1q trunks. Throughout the course, we're going to learn how to use Nmap in detail to scan the networks. Nmap, Network Mapper, is a free and open source utility for network discovery and security auditing. Many systems and network administrators also find it useful for tasks such as network inventory, managing service upgrade schedules, and monitoring host or service uptime. Nmap runs on all major computer operating systems, and official binary packages are available for Linux, Windows, and Mac OS X. Nmap has been used to scan huge networks of literally hundreds of thousands of machines. Nmap is usually very good at documentation. Significant effort has been put into comprehensive and up-to-date man pages, white papers, tutorials, and even a whole book. You can visit nmap.org to find out more about Nmap. While Nmap comes with no warranty, it is well supported by a vibrant community of developers and users. It's one of the most well-known tools of the network security domain, and indeed, with a lot of facilities, it's very powerful. In addition to the classic command line Nmap executable, the Nmap suite includes an advanced GUI and results viewer, ZenMap, a flexible data transfer, redirection, and debugging tool, NCAT, a utility for comparing scan results, NDiff, and a packet generation and response analysis tool, Hping. Nmap uses raw IP packets in novel ways to determine what hosts are available on the network, which ports of these hosts are accessible, what services those hosts are offering, what operating systems are running, what type of packet, filters, firewalls are in use, and dozens of other characteristics. Beyond all this, Nmap has its own scripting engine and allows developers to develop new modules. In the following lectures to discover the network, we'll perform the following with Nmap. First, we'll use ping scan to find out the hosts in the network. Then we'll use different types of port scan to find the open or accessible ports. We'll detect the services running on the ports and their versions. We'll try to learn the operating systems running on the systems. And after that, we'll see how to use scripts with Nmap scans. And we'll learn some important scripts as well. Nmap sends some packets to discover the network. To prevent security devices from blocking our packets, here's where we're going to learn some timing tricks. Then we'll see what we can do more of to bypass security devices such as packet filters, IDS, or IPS. Here, there's an Nmap command example. Let's see some basic parameters of the Nmap command. Nmap is, of course, the command itself. S is to define the scan type. If you use S with uppercase T, as seen in the slide, it means you want to run a TCP scan. We'll see the important scan types in detail. If you don't use this parameter and you have the administrator privileges on the computer where you're using Nmap, SynScan is a default scan type. If you don't have the admin privileges on the computer, TCP scan will run. Destination IP address is the only required parameter to run this command. It means you can run the Nmap command like nmap 172.16.99.139. This is the IP address of the target machine which you want to scan. You can either give a single IP address or give an IP block or an IP range as a target, but we'll see that soon. Destination ports are the port numbers that you want to scan. If the target port numbers are not given to the command, top 1,000 ports will be scanned. Be careful, I didn't say the first 1,000 ports. I said the top 1,000 ports. That means the most used 1,000 ports will be scanned. There are different ways to enter destination ports, and we'll see them in detail. Let's do the first scan. So now let's write our first Nmap command. So with this command, we will scan the IP of the Kali Linux computer. So for this, just open Kali Linux, username root, password tour, and click terminal. Learn IP with ifconfig, Nmap, enter your target IP, press the enter key. All right, so here we've entered our own IP information as the target IP. So how can we find other threads and other targets? So this is where we should probably talk a little bit about IP and network concepts. We briefly mentioned the concept of a rope before, but let's go into a little more detail. So these concepts are the basic concepts that you can probably encounter in just about all of your penetration testing. It might sound a little boring at first, but I really do want to help you master this subject, right? So we got to talk about what is a network. Yeah, I know we've already defined network in that network, but let's dive a little deeper, shall we? So it's a communication system that devices establish with each other in a certain area. Information and system resources are shared among different users. And data can also be transferred from one location to another. And a network is formed just by connecting at least two devices. Now, on the OSI reference model, it's located on layer 3. So what is the OSI reference model? So if you haven't ever encountered it before, the OSI, or Open Systems Interconnection, is a model that was developed in 1984 by ISO, which is the International Organization for Standardization. Now, before you purchased a computer system prior to an OSI standard, everything from cable to a network card, drives to network operating systems were custom made for that company. Therefore, different devices could not communicate effectively with each other. So that's why this model quickly became widely accepted and also became a guide for network standards. So that way, devices manufactured by different companies with the OSI standard will basically be able to communicate using the same protocols. Now, the OSI model consists of 7 different layers. And here they are. Layer 7, application. Layer 6, presentation. Layer 5, session. Layer 4, transport. Layer 3, network. Layer 2, data link. And layer 1, physical. So for now, we'll leave these layers here, though throughout the course we will discuss OSI additions when we get to them in related topics. Now, getting back to the Nmap scan that we perform, it will occur on the network layer, which is OSI layer 3. Now, so with a scan, Nmap will try out the first 1,000 TCP ports that are most commonly used, which ports are available, and what their status is, whether it's on or off, and then the service names that will be using those ports. The 1,000 TCP ports used by Nmap will come by default, and if we want to change the list of ports used, we just need to modify the file user share nmap services. I don't recommend that, though. Interpretation of Nmap results. So when we run the Nmap command, we can have all the information about all of the results and the scan. Incoming results include port information, port status, open or closed, service name, cause information, etc. And the results of the Nmap scan are interpreted and then processed in the next step. For example, according to port information, you can plan your attack types and how they relate to your specific target. So for this example, a ping scan was performed on the IP address 10.0.2.4, and the results are listed here. And additional lines will be listed according to the type of scan performed. Let's say if the operating system parameter was entered, we would see the results in the rows that specify operating system of the target IP. So in the lessons that follow here, we're going to do some very relevant examples, but you are now familiar with the overview. We'll be looking at results in detail, specifically the target IP, which will display the IP address that is being scanned, number of coded ports, Nmap scans 1,000 TCP ports by default, unless otherwise specified. So you can specify how many of the 1,000 ports are closed as a result of scanning. And ports found shows the ports that are used or in use, and they are open on the destination after scanning. Port state displays the status of the ports found, whether they're on or off. Service name displays the service names that are used on the found ports. And for a service state reason, why the ports are open or closed. And the MAC address displays the MAC address of the target threat. Scanning specific IPs or specific targets with Nmap. So the goal of scanning with Nmap should be to get the best information about the target as quickly and efficiently as possible. Therefore, it may only be necessary to scan on specific targets. So Nmap offers a very flexible number of possibilities. Let's have a look at some of them. So in our previous example, we saw how to scan a particular subnet, right? The Nmap subnet command. So scanning an entire network will take some time, depending on the number of devices in the network. Scanning an entire subnet can also cause security systems to be on alert, because it's attempting to access many different threads from a single source thread, a computer thread that is used for scanning. So this, of course, can be recognized by security systems, and then the IP address that you're using for scanning will be blocked. So instead, we only scan specific threads. So to use this command, you need to know the target IP information in advance. So the command we will use is nmap IP1, IP2, IP3. So here, IP1, IP2, and IP3 are the IP information of the target systems. And the number of IPs written here can be increased. Nmap, command, and list creation. So we've already seen that certain IPs can be scanned with the command nmap IP1, IP2, IP3, right? So similarly, instead of typing these IPs in a single screen, we can write them to a file and scan from line to line with Nmap. So this gives us an enormous amount of flexibility when scanning. So the file can be IP, subnet, or web address. They can be all found together or individually. So let's open up these virtual machines that we created. And we'll remember the IP addresses of the virtual machines. So Metasploitable IP is 10.0.2.4. Ubuntu IP is 10.0.2.7. Windows 10.0.2.6. Kali Linux is 10.0.2.15. Good, so now the file can be created as follows. So log into Kali Linux, username root, password tour, click terminal, and type leafpad/root/desktop/test.txt and enter. So we want to scan for IP, subnet, or enter a web address. However, you've got to pay attention to this. Each value will be written on a single line. So here we'll save the file, and we'll write the command nmap-il/root/desktop/test.txt and enter. As you can see, nmap reads from the file and then executes a scan. Nmap random scan and exclude IPs. So with Nmap, you can scan any number of random targets on a network, right? To do this, simply type nmap-ir and a host number. So this penetration test can be used to set random targets and make discoveries related to these targets. So log into Kali Linux, open terminal. So for example, let's scan just 50 targets randomly. Nmap 10.0.2.3/24-IR 50, press enter. And as you can see, only 50 IPs were scanned. So with Nmap, you can scan specific targets or exclude specific targets from scanning. So this command will be able to save us time by excluding known targets from scanning, as well as knowing if there's a firewall on it, or we can scan by excluding the IPs of security servers. So we can open the virtual machines that we created. And of course, remembering the IP addresses of the virtual machines: Metasploitable IP 10.0.2.4, Ubuntu 10.0.2.7, Windows 7 10.0.2.6, Kali Linux 10.0.2.15. So we'll log into Kali Linux, open up terminal, and Nmap 10.0.2.0/24-exclude 10.0.2.6, 10.0.2.7, press enter. And as you can see, the excluded IPs were not scanned. So we can write the threads required for this process one by one, or write them into a file and run Nmap reading from this file. So the Nmap exclude file command should be read from the file in order to specify the unwanted target. So let's open the virtual machines that we created. Now we can log into Kali Linux, open terminal, and type Nmap 10.0.2.0/24 exclude file /root/desktop /exclude list.txt and press enter. And there's the example file, 10.0.2.6 and 10.0.2.7. As you can see, the excluded IPs were not scanned. Print the Nmap results to the file. So a few lectures ago, we saw how we identify which ports are scanned. Now in input management, we'll see how we identify which systems are scanned. Okay, go to Kali and open a terminal window. First, I'll prepare an Nmap query, and because I'll play with the destination IPs, it will be the last parameter of my query. Nmap is the command itself. N to close the name resolution, uppercase PN to close ping, uppercase S for SYNSCAN. Now to keep it simple, let's scan just the top 3 ports. Now is the time to identify the destination systems. Up to now, we learned to scan a single IP. And we learned how to scan an entire C block, 0 through 24. Okay, so what are the other ways of identifying target systems? You can select a range of any part of the IP address. In the slide, the third and the fourth parts of the IP address is given as ranges. That means Nmap will scan IPs from 192.168.1.0 to 192.168.255.255. I'd like to keep the range small. I'll only define a range for the fourth part of the destination address from 100 to 150. There's only one machine between 172.16.99.100 and 172.16.99.150. You can scan more than one IP block in a single query. The example in the slide scans two ranges. The first range is between 192.168.1.0 and 192.168.1.255, and the second range is between 10.0.0.0 and 10.0.255.255. Since I don't have a second network on my Kali, I continue with the third example. The third example is the combination of defining a range and a single number. For example, you can scan the IPs between 100 and 140, IP 206, and the IPs between 220 and 230. So here are the results. Nmap found a machine from the range of 100 through 140, the machine with IP 206, and another machine from the range of 220 through 230. Another way to define the target systems is to give Nmap the IP addresses in a file. In a typical penetration test or ethical hacking, you will scan the network a lot of times. First, you find the hosts. It doesn't make sense to scan the entire network again and again. You'll see huge networks, so if you scan the entire network each time, the pen test will take a lot longer than you think. Let's open a second terminal screen and find the hosts of our IP block using ping scan. As we learned before, now clarify the output to have only the IP addresses of live hosts. grep command to get only the rows containing IP addresses, and cut command to get only the IP addresses from a row. Now we can redirect the output into a text file to reuse the list in following queries. But first, let me close the name resolution. Now, put a greater than character and give a file name to write the result, iplist.txt. We're not interested in the first two IP addresses, so let's edit the file and delete them. I use Nano Text Editor to edit the file. In Nano, use Ctrl-K to delete a line. Use Ctrl-X to exit Nano, press Y to save changes, and hit Enter to save on the same file. Type cat iplist.txt to look at the file again. Now we have 4 IP addresses in the file. Let's create a new Nmap query, and this time, let's give the destination systems in a file, iplist.txt. And here are the results of the 4 systems which are listed in the iplist.txt file. So let's talk about the output management in Nmap now. Up to now, we've run a lot of Nmap queries and got the results on the terminal screen. This is the default output behavior called interactive output, and it is sent to standard output, std out. In a penetration test, we should save the results of the queries to be able to analyze them later on. Hopefully, Nmap has its own output management skills. So let's have a look. There are 3 major output saving formats in Nmap. Normal output, which is similar to interactive output. That's what you see on the screen up to now, except that it displays less runtime information and warning, since it is expected to be analyzed after the scan completes rather than interactively. Greppable output, which includes most information for a target host on a single line, so you can use it to collect the information you want using the excellent grep command. We've already seen a few examples of grep command in this course. XML output is one of the most important output types, as it can be converted to HTML easily parsed by programs such as Nmap graphical user interfaces or imported into databases. There's one more magic parameter, which is O_A, to let you generate the outputs in all formats. Now let's see the Nmap output management in action. Go to Kali and open a terminal screen. Prepare an Nmap query. For this example, I want to prepare a SYN-scan. Now we're ready for output management options. First, I want to generate the XML output using O_X parameter. O_X parameter needs the output file name. You can give the file name with the full path. If you don't specify a path, just as in this example, the file is created in the current folder. Be careful. OX, OG, and ON parameters require the full file name. So if you want the file to have an extension such as .xml, you should specify it here. Hit Enter to run the command. To see the generated file, here it is. And use the less command to see the content of the file. So it's typical XML file with tags. Here's a host tag, starts and ends. All the results about a host is listed between the start tag and the end tag. IP address, scanned ports, and of course, the scan results. Here's another host tag and the scan results of the second host as well. Press Q to quit, less command. Now let's call back our Nmap query with the up-down arrow keys of the keyboard. Now I want to generate all types of outputs. Type O uppercase A and the base name of the files. Be careful, O uppercase A parameter requires the base file name of the files, not the full names of the files, and it'll put the file extensions itself. Let's look at the content of .nmap file using the less Linux command. This is almost the same as you'll see on the screen. Now let's look at the greppable output. Here there are two lines for each host, one to show the status of the host and another one to show the port scan results. So what is a port and how does it work? Well, in computer networks, hardware connections are terminated physically, wired or wireless. In software, a port within an operating system is a logical structure that identifies software-specific process or service. The ports are identified by 16-bit long numbers of each protocol and address combination. The most common protocols that use port numbers are the Transmission Control Protocol, TCP, and the User Datagram Protocol, UDP. Now, the port number is always associated with the host IP address and its communication protocol type. Completes the destination or source network address of a message. And then certain port numbers are used for specific services. For example, port 80 is used by HTTP. Port 443 is used by HTTPS protocol. So then this way the package can be easily transmitted to the running application. The most commonly used ports are ports 1 through 1024, and other ports can be specified to a particular application. The most used default ports. So below are the most commonly used default ports and the names of the services that use them. Now it's important to remember these ports, know them well, is because we can understand what the systems are in the target network when we're scanning. So according to the port scan results, we can plan the next step. Or if there are services that we know are used within the target network, we can scan directly for these services and then finish the scanning process without getting caught in the security systems. So if port 21 is open, FTP service is available. And if port 53 is open, DNS service is available. If port 110 is open, there is an SMTP service, which means that mail service is up and running. FTP is 21, SSH 22, Telnet is always 23, SMTP 25, DNS UDP 53, HTTP 80, POP3 110, NetBIOS 139, IMAP 143, SNP UDP 161, SMP Microsoft DS UDP 445, RSH 514, VMware 902, MS SQL 1433, Oracle DB 1521, MySQL 3306, RDP 3389, VNC 5900, Proxy Application Servers 8080 and 8081. 25. Scanning the top 20 and the top 100 ports with Nmap. So I'll remind you, In our very first scan with Nmap, all we did was enter Nmap IP address. Now, since we didn't enter any port parameters in that particular IP scan, by default, Nmap scanned the top TCP 1000. So in this way, it may be reasonable to scan for a single rope. However, it will not make sense to scan the entire network. So therefore, wouldn't it be a good idea to scan only specific ports when we want to scan? So in this way, we can scan faster and reduce the chance of, catching the attention of security systems. Nmap offers many alternatives for scanning specific ports, so let's have a look at the most used types of them one by one. So if we type the command nmap --top ports 20 and a destination IP in the terminal, Nmap will search for the top 20 TCP ports on the target system. Now you have to remember that Nmap always performs a TCP port scan if no specific parameters specified. So if you want to see what these 20 TCP ports are, we can write nmap --top ports 20 VOG. V parameter means verbose. The OG parameter specifies that the scan result will be in greppable mode. So we're only going to see displayed the last dash parameter. Similarly, if you want to see the top 100 ports, we can write nmap --top ports 100 VOG. And similarly, if you want to see the top 1000 ports, we can write nmap VOG. And we can do the same thing by adding TCP parameters. So what I mean by that, we write nmap st --top ports 20 VOG. So st is the parameter, that's the TCP port. Then similarly, if you want to see the top 100 ports, we write nmap st top ports 100 VOG. And then if we want to see the top 1000 ports, we can write nmap st VOG. So let's do an example here. Open up VirtualBox, open Kali Linux, and open Metasploitable. Log into Kali Linux VMs, and open up Terminal, and write this command. Nmap 10.0.2.4 st top ports 20 VOG, and press enter. Now, if we only want to see the port numbers, nmap st top ports 20 VOG, and press enter. And if you want to see what these 20 UDP ports are, we can write nmap su top ports 20 VOG. Now here the su parameter is the UDP port, and the v parameter is verbose. The OG parameter specifies that the scan result will be in greppable mode, so it specifies that what will be displayed as the last parameter. So similarly, if you want to see the top 100 ports, we'll write nmap su top ports 100 VOG. And if you want to see the top 1000 ports, we'll write nmap su VOG. So we can go back and open VirtualBox, open Kali Linux, open Metasploitable, and log in to Kali Linux VMs. We can open Terminal and write the command nmap 10.0.2.4 su top ports 20 VOG, press enter. And if we only want to see the port numbers, nmap su top ports 20 VOG, and press enter. Scanning specific ports with nmap. Nmap P ports and target IP. So you don't want to scan just the top 20, the top 100, or the top 1000 ports with nmap. Instead, we can set the ports that we want to scan. So this way we can scan faster and way more specifically. Now, unless otherwise stated, our scans will be valid for these TCP ports. If we want to perform a UDP port scan, we'll need to specify it on the command line. Remember, in our previous lesson, we saw how to do this. So to perform a UDP port scan, we need to use the SU parameter in the command line. For example, let's scan some of the TCP and UDP ports on our Metasploitable VMs that we've already set up. So we can perform the most commonly used TCP-80 HTTP port and TCP-443 HTTPS port and UDP-53, which is the DNS port, scans in sequence. Okay, so open VirtualBox, open Kali Linux, open Metasploitable, and log into Kali Linux VMs. Open Terminal and write the command nmap 10.0.2.4 p53 80 443. Press enter. And the scan results appear. So let's have a look. So it shows the TCP 80 and 443 ports. Now, since we didn't enter the UDP parameter, the UDP port did not scan. So let's do a UDP port scan and have a look. Nmap SU P53 80 443. Press enter. And here you can see TCP does not show ports 80 and 443 since we enter the UDP parameter. Only the UDP port shows up as a scan result. Now, both TCP and UDP port scanning can be performed at the same time. So when you want to do that, you write this into the command line, nmap STSU P53 80 443, and press enter. And there you have it. Both TCP and UDP ports show up in the port scan results. Scanning a specific port range with Nmap. Now, what was the port before? So we learned what it's used for, but there are 65,535 port numbers in most computer systems. So with Nmap, we can scan a wide range of ports, right? So this method can be used if the scan results, based on the default port numbers, are negative. So this means that well-known services are always targeted. Hackers often give priority to scanning these ports, like AVI. So in this case, by changing the number of these ports, maybe an attack can be prevented. So because many hackers use ready-made attack systems, they're always going to scan the default ports. So for this reason, the security level can be increased just by changing the port number of a service used within the application. For example, port number 443 HTTPS can be changed to 14443. So in this case, attacks to the HTTP service will be prevented. Nmap also allows you to scan specific port ranges for these such situations. So for this, Nmap port P, port number, and press enter. Now, please make a note that unless you specify otherwise, our scans will be valid for the TCP ports. And if we want to perform a UDP port scan, we just need to specify it on the command line. In our previous lesson, I believe we saw how to do this. To perform a UDP port scan, we just need to use the SU parameter in the command line. So let's do an example. We'll scan for specific TCP and UDP ports on the Metasploitable VMs that we've already set up. So open up VirtualBox, open Kali Linux, open Metasploitable, and log into the Kali Linux VMs. Open Terminal, and write this command, nmap 10.0.2.4 p1000-2000, press enter, and the scan results come up. So here you can see it scanned the TCP 1000 to TCP 2000 port range, and it shows the results. Now both TCP and UDP scanning, of course, can be performed at the same time. When you want to do that, you just put this on the command line, nmap STSU P1000 to 2000, and press enter. And there you have the scan results of the TCP and UDP ports between 1000 and 2000. SYN scanning. Nmap SS, target IP command, is the most commonly used form of scanning in Nmap. Of course, if we do not give a parameter while scanning, Nmap will always scan TCP. So the scan uses the aforementioned three-way handshake system. A SYN scan is faster and less detectable than a TCP scan because in this scan the connection is terminated before it's fully established. However, you should also remember that they may be detected by next-generation firewalls and security software. I'll show you how the scan works. So step 1, Nmap will send a SYN packet to the scanned port of the target computer. Step 2, the computer receiving this response will send a SYN ACK. Step 3, after receiving this answer, Nmap does not send the ACK packet from the computer that we're scanning to complete the connection. Instead, it sends a reset packet. So that way the possibility of logging is reduced and our speed increases as there is not a full connection. Now this type of scan is especially useful for systems that use firewalls. That way the status of the corresponding port of the target is determined. In SYN scanning, comments are made according to the answers received. So when a SYN scan is performed, the following answers can be received from the target system. The port open status. So Nmap sends a SYN packet to the destination, and the destination system sends the SYN ACK packet. Nmap terminates the connection by sending a reset packet instead of sending an ACK packet. And that indicates that the port is open and accessible, and that the port accepts a TCP or UDP connection. Port closed status. Nmap sends the SYN packet to the destination, and the destination system sends a reset message instead of the SYN ACK packet, and then terminates the connection. And in this case, the port is accessible but cannot be processed. Now how about the port filtered status? So two kinds of answers can be received here on the Nmap side. First, the Nmap sends a SYN packet to the target system, and no response is received from the target system. When that happens, it is not commented whether the port on the target system is open or closed. Then secondly, Nmap sends a SYN packet to the target system, and the destination system sends the ICMP unreachable error packet. So then in this case, the port is accessible, but it's not known whether it's open or closed. TCP scan. So in our previous lessons, we discussed the TCP scan, and by default, Nmap always performs TCP scans unless otherwise specified. So let's take a closer look at a TCP scan with Nmap. Nmap sends a SYN packet to the target system, and the target system receives the packet and sends the SYN ACK packet to the Nmap computer, which receives an Nmap packet and sends the ACK packet to complete the connection. The destination system port sends the port information that is open. Nmap terminates the connection by sending a reset packet immediately. So to scan TCP with Nmap, we need to add the ST parameter to the Nmap command. So I'll give you an example. We'll scan the TCP top 20 on the Metasploitable server that we installed. So open VirtualBox, open Kali Linux, open Metasploitable, and log into Kali Linux VMs. Now open up Terminal and write the command nmap 10.0.2.4 top ports 20, press enter. And the results of the scan are right here. So let's have a look. As you can see, the top 20 ports were scanned, and it lists the results. TCP and SYN scan difference. So what are the differences between the SYN scan and the TCP scan? They're right here. A SYN scan, three-way handshake, does not complete. The TCP scan, the three-way handshake, is complete. The SYN scan, if the SYN ACK packet arrives, the connection is terminated with reset. And on a TCP scan, if the SYN ACK packet arrives, the connection is completed with the ACK packet. In a SYN scan, SYN scans are usually not logged on the server. TCP scan are logged on the server. SYN scans require root authority because there was interference in the packages. A TCP scan does not require any root privileges because it uses the TCP connect method. UDP scan. So in our previous lessons, we discussed the UDP scan. Most of the services that are popular in server systems run over TCP protocol, however. UDP services are also widely used. So DNS port 53, SNMP ports 161 and 162, and DHCP port 67 and 68 are the most commonly used services. UDP scanning is generally slower, and it's more difficult than TCP scanning. So for this reason, some security controllers kind of ignore these ports. Extensible UDP services are common. Therefore, this is an error because attackers do not ignore the entire protocol. So in order to scan UDP with Nmap, we will need to add the SU parameter to the Nmap command. And it can be combined with a TCP scan type, just as the SYN scan, SS, to control both protocols using the same scan. Sound good? A UDP scan works by sending a UDP packet to each targeted port. And for most ports, this packet will be empty. That means no load. But a protocol-specific data payload will be sent for several of the more common ports. Now, 4 different situations can occur when we scan UDP with Nmap. And these will be open status. That's when Nmap sends a UDP packet to the target system. If the UDP response is sent from the destination system, that means that the destination port is open. And a closed status. So Nmap sends a UDP packet to the target system, and if the ICMP port from the destination system sends an unreachable error response, that just means that the destination port is closed. An operation cannot be performed. Filtered status. Nmap sends a UDP packet to the target system, and if the ICMP sends unreachable errors from the target system, the destination port is filtered. So the port is open, but it cannot be operated. It's likely that security software is being audited by it. Open filtered condition. Nmap sends a UDP packet to the target system, and if there's no response from the target system for a certain period, Nmap accepts this port as open filtered. So that just means it cannot decide whether the port is open or closed, but still an operation cannot be performed. So now let's do a simple UDP scan. So here's the example. We'll do a UDP top 10 port scan on the Metasploitable server we installed. So we open VirtualBox, open Kali Linux, open Metasploitable, and log into Kali Linux VM, and open up Terminal and write this command, nmap 10.0.2.4 su top ports 10 reason sv, and press enter. And there are your scan results. So as you can see, the time is too long for the TCP scan. Nmap UDP scanned the top 10 ports and listed the results. Up to now, we have seen the most important scanning types to discover a network. There are some other scanning techniques in Nmap which are not used as much as the others, but in some cases, you may need to find some other ways to be able to discover the sensitive hosts in a network. In this slide, we'll see 3 more scan types: null, fin, and Christmas scans. The common ground of these 3 scanning methods, null, fin, and Christmas scans, is that they send packets to the target systems in which SYN, ACK, and RIST flags are not set. Null scan, S_N, does not set any bits. That is, the TCP flag header is 0. Fin scan, S_F, sets just the TCP fin bit. Christmas scan, S_X, sets the fin, push, and urge flags. lighting the packet up like a Christmas tree. There are two rules defined in RFC standards about such packets. The first rule is, if the destination port state is closed, an incoming segment not containing a RIST causes a RIST to be sent in response. The second rule is, packets sent to open ports without the SYN, RIST, or ACK bits set are dropped. These three scan types are exactly the same in behavior except for the TCP flag set in probe packets. If a RIST packet is received, the port is considered closed, while no response means it is open or filtered. If an ICMP unreachable error, type 3 code 0, 1, 2, 3, 9, 10, or 13 is received, the port is marked as filtered. So as a result, with these types of scans, you can find out if a port is closed or not. It's not possible to understand if it's open or filtered if there's no response. This scan is different than the others discussed so far in that it never determines open or even open filtered ports. It's used to map out firewall rule sets, determining whether they are stateful or not and which ports are filtered. The ACK scan probe packet has only the ACK flag set. When scanning unfiltered systems, open and closed ports will both return a RIST packet. Nmap then labels them as unfiltered, meaning that they are reachable by the ACK packet, but whether or not they're open or closed is undetermined. Ports that don't respond or send certain ICMP error messages back, type 3, code 0, 1, 2, 3, 9, 10, or 13, are labeled filtered. So in this lesson, we will see how we can discover the online hosts in the network using the Hping scanning method. So one of the most common Nmap usage scenarios is to scan an Ethernet LAN, right? There are multiple ways to discover hosts in your network, and one of these methods is the Hping scanning method. Well, okay, so what is ARP anyway? Address Resolution Protocol. It's a low-level protocol that works at the link layer level of the OSI model, which was explained in the Nmap OSI model lesson. So the link layer is a protocol that's used in IP version 4 local networks to discover online hosts in the local network. It can't be used on the internet, right? So when using Nmap on a network, ARP protocol is applied by default because, well, it's just faster and way more reliable. All right, so how does ARP ping scanning work? ARP ping scanning works in a pretty simple way, actually. A regular ARP packet request looks for the MAC address using the device's IP address. Nmap sends ARP requests to the destination IP addresses, and if a host responds with an ARP reply, that means a host is online. Nmap uses the -PR parameter for ARP discovery. So let's go ahead and try this. So open Kali Linux in VirtualBox. Enter username, password, and open terminal. So first, we've got to learn our IP address because we're going to need them to learn which IP range that we're going to look for the live hosts in. So write sudo su dash for root permissions. Enter the root password. And write ifconfig into the terminal. Okay, so here's our IP address. Now we know which IP range we will look at, right? So let's write nmap, and the -sp option tells nmap to only perform a ping scan, then print out the available hosts that respond to the scan. This is also known as a ping scan. And write -PR for the ARP discovery. Then after writing those commands, we'll need to specify the IP ranges. We can specify the range like writing /24. That's at the end of the IP address, or we can just put the asterisk at the end of the IP address. Cool, so here are the live hosts in the local network. Like I said earlier, the ARP scan is set to be the default network ping scan in Nmap. If you just scan the network with the -SP parameter, you can see which protocol Nmap uses as the default protocol. So to see this, write -- packet trace with -SP. So see that's a double dash packet with a dash, just a single dash in between? All right. Anyway, as you can see, the ARP protocol is used by default. Now, if you don't want to use the ARP protocol, you've got to write -- disable -ARP. All right, so let's see this. Write nmap -- packet -trace -SP space -- disable -ARP -ping and the IP range that Nmap is going to look for. So press enter. Okay, so as you can see, Nmap is making ICMP echo requests for searching live hosts. What do you think? So we've learned what the ARP is and how we can use it. All right, so in this lesson, we are going to see how we can discover the online hosts using the ICMP ping scanning method. So, of course, there are multiple ways to discover hosts that are up and running, and one of these methods is the ICMP ping scanning method. ICMP, or Internet Control Message Protocol, creates a feedback mechanism by working in the data part of the IP packet at the Internet layer, and then reporting on the problems to the communicating units. So it's part of the IP protocol suite. Therefore, it is in layer, say it with me, layer 3. So ICMP is a protocol that helps TCP/IP to work, provides feedback by the host in case of error. So ICMP protocol will run on every host. Hence, ICMP echo requests are blocked, even through simple firewalls. ICMP is also used for checking live systems. Ping is the most well-known utility that uses ICMP requests, and the principle is pretty simple. ICMP scanning sends requests to hosts and then waits for an echo request to check and see whether the system is alive. An ICMP ping scan can have 3 parameters. One of them is -PE. So this parameter makes ICMP echo requests. The other 2 parameters are timestamp enter the root password, write nmap -SP. So this option tells Nmap to only perform a ping scan, then print out the available hosts that respond to the scan. And this is indeed also known as a ping scan. -PE for making ICMP echo requests and the target IP address, as seen in the terminal host, right? So for you to see, again, just write the same things and we'll add -- packet -trace. Now press enter. What do you see? Nmap is sending ICMP echo request packets and returns taking ICMP echo replies. All right, so that's how we can discover the hosts with ICMP pings. Nmap fast scanning. Nmap F target. So in this lesson, we will see the quick scan parameter with Nmap. Of course, in our previous lessons, we've indicated that if Nmap port range is not specified, TCP will scan the first 1,000 ports. Now, when you scan with the Nmap F parameter, the top 100 ports will be scanned. So let's open up VirtualBox and Kali Linux. Open up Metasploit 10.0.2.4. Log into Kali Linux VMs. Username root, password tour. Open terminal and write this command. Nmap 10.0.2.4 F V top ports 10 map open port scanning. Nmap target IP command open. So in scanning ports with Nmap, Nmap will scan and list all of the ports that you specify, whatever you desire. Now it will also be able to specify whether the port is open or closed when it lists your results. So if we want to see only the open ports, we can use the Nmap command, open res parameter. So in this case, it only lists the ports that are open after the scan. It does not list the status of the other ports. So for example, scan the top ports on the Metasploitable server and list just the open ports. So for this, let's open VirtualBox, open Kali Linux, open Metasploitable, log into Kali Linux VM, username root, password tour, and open up the terminal. So write this command, nmap 10.0.2.4, top ports 10, open, press enter, and there are the scan results. And the ports that are open are listed here. Nmap no port scan. So of course, Nmap is a program that's used to perform active scans, and the discovery of the results will help you set your goals for what your pen test will be. It's going to be unnecessary to scan all the ports for each IP, especially when scanning large networks. So instead, wouldn't it be quick and logical to detect open computers as a first step, and then only scan for ports on those computers? Yeah, so let's do this then. Nmap can perform a ping scan just to detect the computers that are turned on. So scanning with SN consists of an ICMP echo request, TCP SYN to port 443, TCP ACK to port 80, and an ICMP timestamp request by default. Now, only SYN packets are sent to ports 80 and 443 on the destination by a non-privileged user. So let me show you an example. So let's make an active discovery on the network where the virtual computers are that we have established. So for this, let's open all of the virtual computers that we have installed. Open VirtualBox, open Kali Linux 10.0.2.15, open Metasploitable 10.0.2.4, open Ubuntu 10.0.2.7, open Windows 7 10.0.2.6. Now log into Kali Linux VMs, username, root, password, tour, open up terminal, and write this command, nmap sn 10.0.2.0/24, and press enter. Okay, so here are the scan results, and we can see the computers that are open here. 35, Nmap ping scan. Nmap SP target. So this scan type lists the host in the specified range that will respond to a ping. It allows you to determine which computers are online rather than which ports are open. So basically there are 4 methods in Nmap for ping scanning. It will send an ICMP echo request packet to the target system. And if an ICMP echo reply is received, then the system turns on and ICMP packets are not blocked. If there is no response to the ICMP ping, Nmap attempts a TCP ping to determine whether ICMP is blocked or whether the host is actually online. The TCP ping sends a SYN or ACK packet to any port on the remote system, and of course the default is 80. If reset or a SYN ACK is returned, the remote system will go online. And if the remote system does not respond, it is offline or the selected port is filtered and then therefore does not respond to anything. So when you run an Nmap ping scan as root, the default will be to use the ICMP and ACK methods. However, this method may not work correctly on all networks, especially where ping packets are prohibited. Let me show you an example. So we'll make an active discovery on the network where the virtual computers are that we have established. So for this, let's open all of the virtual computers that we have installed. Open VirtualBox. Open Kali Linux 10.0.2.15. Open Metasploitable 10.0.2.4. Open Ubuntu 10.0.2.7. Open Windows 7 10.0.2.6. And then log into Kali Linux VMs. Username root, password tour. Open terminal. And write this command. Nmap SP 10.0.2.0/24. Press enter. And the scan results appear. And we can see that the computers are open right here. Nmap no ping scanning. So if you scan with the Nmap PN parameter, it accepts that the target threads are open. Scans all the ports for each IP without pinging. So it could take a long time to detect master servers, especially in large networks. Use Nmap PN target. Nmap V command. So if the V parameter is used for Nmap scanning, the detailed results are listed. And if the V parameter is used twice, the results can be more detailed. Nmap target V V. So I'll show you an example. Let's scan the top 10 ports on the Metasploitable virtual machine. And let's see the difference in the meter. And as you can see, it only lists port names and numbers, the port state, whether they're open or closed, and the service names. Now we'll do the same operation with the V parameter. Nmap 10.0.2.4, top ports 10 V, and press enter. And there's the different scan results. So as you can see, you get more details and in the list. Now, if we do the same operation twice by putting the V parameter in, let's see how that works. Nmap 10.0.2.4, top ports 10 V V, press enter. And there are your scan results. Indeed, we have much more detail in the list. So for this, open VirtualBox, open Kali Linux 10.0.2.15, open Metasploitable 10.0.2.4, log into Kali Linux, username root, password tour, open terminal, and write this command, Nmap 10.0.2.4, top ports 10, press enter. Now the scan results follow. Indeed, we have much more detail in the list. In those Nmap lectures, we have seen no port scan, also known as ping scan, different ways of scanning ports, SYN scan, also known as half-open scanning, TCP scan, also known as TCP Connect scan, and UDP scan. Now let's see some more details to be able to use Nmap more effectively. We have found the hosts and open ports of them. Now is the time to find out the services which are listening to those ports, and the version of those services. In addition, let's detect the operating systems running on those systems. Suppose that you ran an Nmap query and it told you that ports 25 TCP, 80 TCP, and 53 UDP are open. Using its Nmap services database of about, 2,200 well-known services, Nmap would report that those ports probably correspond to a mail server, SNMP, web server, HTTP, and name server, DNS, respectively. This lookup is usually accurate. The vast majority of daemons listening on TCP port 25 are in fact mail servers. However, you should not bet your security on this. People can and do run services on strange ports. Even if Nmap is right, and the hypothetical server above is running SNMP, HTTP, and DNS servers, that is not a lot of information. When doing vulnerability assessments, or even simple network inventories of your companies or clients, you really want to know which mail and DNS servers and versions are running. Having an accurate version number helps dramatically in determining which exploits a server is vulnerable to, and version detection helps you obtain this information. After TCP and/or UDP ports are discovered using one of the other scan methods, version detection interrogates those ports to determine more about what is actually running. The Nmap Service Probes database contains probes for querying various services and match expressions to recognize and parse responses. Nmap tries to determine the service protocol, for example, FTP, SSH, Telnet, HTTP. The application name could be ISC bind, Apache HTTPD, Solaris Telnet-D. The version number, host name, device type, something like a printer or a router, and the OS family. You know what that is, Windows, Linux, etc. So let's see how to use service and version detection in Nmap and why it's important. Okay, go to Kali and open a new terminal window. Let's create the Nmap scan command. Nmap is the command itself. N is to avoid the DNS resolution. Uppercase PN is to avoid the host discovery. I'm using the SYNSCAN this time. I write the destination IP, which is the IP address of my Metasploitable VM, and the destination ports, the top 10 ports. Let's run this command first to see the results of a command without version detection. Now, I open a new terminal window to create a new Nmap command. I prepared the command with the same configuration. SYNSCAN, Metasploitable, and top 10 ports. I add S uppercase V parameter for version detection and hit Enter. As you see, the query takes longer this time. The SYNSCAN without the version detection took less than a second, and the SYNSCAN with version detection took, about 12 seconds. In the first query, service names are estimated by Nmap according to the default services running on those ports. In the second query, on the other hand, Nmap probed the ports to determine more about what is actually running. Now, I want to show you the most important reason of using version detection in Nmap queries. In Kali, I'm going to run SSH on port 443, and then scan the port with Nmap. Let's perform the demo together. First, look at the listening services if SSH is running. Netstat, TNLP. SSH is running on port 22 at the moment. Type service SSH stop to stop SSH service and hit Enter. Now, to change the port of SSH, we're going to change the configuration. Open the sshd_config file with a text editor to change it. I use Nano text editor for this purpose. Type nano/etc/ssh/sshd_config and hit Enter. Find the port line, delete the sharp to make it a valid configuration line. The sharp was used to make it a comment line. Change the port number to 443. Control X to exit Nano, Y to save changes, and hit Enter to save over the existing file. Start SSH again, using the service SSH start command. Look at the listening ports to double-check Netstat TNLP. SSH service is running on port 443 now. Let's scan port 443 of Kali with Nmap. Prepare the Nmap SYNSCAN command. No version detection for this query. Nmap detects that the port is open. Look at the service. Nmap says the service is HTTPS. Using its Nmap services database, Nmap reported that this port probably corresponds to a web server for HTTPS, and we know that's not true. So let's prepare the Nmap SYNSCAN again, but this time use S uppercase V parameter to run the version detection mechanism. Now, as you see, port 443 is running and the service is SSH, not HTTPS. Version detection interrogated the port to determine more about what is actually running. Nmap queried the port using the probes of the Nmap Service Probes database and matched expressions to recognize and parse responses. And the version of SSH is OpenSSH version 7.6p1. So, if you are not 100% sure about the type of the running service on a port, run version detection. Got it? Good. So one of Nmap's best-known features is remote OS detection using TCP/IP stack fingerprinting. Nmap sends a series of TCP and UDP packets to the remote host and examines practically every bit of the responses. After performing dozens of tests, such as TCP-ISN sampling, TCP option support and ordering, IP-ID sampling, and the initial window size check, Nmap compares the results to its Nmap OS DB database of more than 2,600 known OS fingerprints and prints out the OS details if there's a match. Each fingerprint includes a free-form textual description of the OS and a classification which provides the vendor name, for example, Sun, underlying OS, that would be Solaris, OS generation, let's say 10, and device type, general purpose, router, switch, game console, whatever. OS detection is far more effective if at least one open and one closed TCP port are found. So let's see the OS detection in action. We have to use OS detection with one of the port detection techniques. So I use SynScan for this demo. The target system is Metasploitable. Let's choose top 100 ports to make the query faster, or just don't give any port. Let the Nmap scan top 1,000 ports. That won't take long. Put uppercase O for OS detection and hit Enter. Here is the result of OS detection. It's a general-purpose device and running Linux with a version between 2.6.9 and 2.6.33. If you would like Nmap to be more aggressive to have a more accurate result, you can use OS scan guess parameter with OS detection parameter. Now, let's scan a Windows system and try to find out the version of the OS. So here I have a Windows 8 virtual machine. I want to learn its IP address first. Open a command prompt, type ipconfig, and hit Enter. Now let's go to Kali and test if we can reach the Windows system. First, I'll ping the system. No, the system is not responding to the ping requests, or we cannot reach the system. So second, I perform an Nmap ping scan. We know how to do it, right? Type Nmap SN 172.16.99.171 and hit Enter. Yes, Nmap says the host is up. So we are able to reach the system. Now I want to scan the top 10 TCP ports of the system. I add the reason parameter to see the reasons of the results. All the ports we scanned are filtered because there are no responses from them. It's not good for us. So I add the OS detection to the latest Nmap query and rerun it. No, Nmap cannot find the OS details because it does not have a result set to probe or interrogate. I would like to open a port on the Windows system and reply the Nmap scans. In Windows 8 VM, I run the IIS, Internet Information Services Manager, and start to host the default website of IIS. Open a web browser and try to reach the website typing the IP address of the system into the address bar. Okay, web service is up. Let's test if I can reach the website from Kali. I go to Kali, open a browser, enter the IP address of the Windows 8 VM, and hit Enter. No, I cannot, and I think I know the reason. In Windows VM, let's look at the firewall if HTTP traffic is allowed. So I open the firewall. At the upper left corner, I click Allow an app or feature through Windows Firewall link. Click Change Settings, which needs to have admin privileges. Go to the end of the list. As I thought, HTTP services are not allowed. Check it and click OK to apply the changes. Now in a command prompt to see port 80, I run netstat an command. When I come back to Kali, I see that the page is loaded in the browser. That means Kali can reach port 80 of my Windows 8 VM. Now in Terminal Screen, I want to run SynScan for the Windows system's top 10 ports. Here we have an open port now. So let's reply the scan with OS detection option. Now we have the OS detection result. First, Nmap warns us about the results. It says the results may be unreliable because it couldn't find a closed port to probe. But anyway, Nmap makes it best. And here, it says the operating system is one of them. Windows 2008, Windows 8.1, Windows 7, Windows Phone, or Windows Vista. Good job. Nmap Script Engine, or NSE. So what do you suppose script scanning would be? So Nmap is indeed a software for port scanning purposes, right? It can also be used for pen test purposes using its advanced features. Nmap has started to be developed as a port scanning tool, and today it has exceeded itself with its vulnerability and exploitation features. So the Nmap scripting engine, or NSE, is one of Nmap's more powerful and flexible features. So it allows users to write and share simple scripts to automate a wide range of network scanning tasks. These scripts are then executed in parallel with the speed and efficiency that we would expect from Nmap. So users can use scripts distributed with Nmap or write themselves to meet their specific needs. NSE consists of scripts in these following categories: defined categories, auth, broadcast, brute, default, discovery, DOS, exploit, external, fuzzer, intrusive, malware, safe, version, and vuln. So the category names are not case sensitive. And, let me just briefly describe each category. Auth. So these scripts handle authentication information, or bypasses it, on the target system. Instead of scripts that use brute force attacks to identify credentials, they are placed in this brute category. Broadcast. Scripts in this category typically discover hosts that are not listed on the command line by publishing to the local network. Use the new target script variable to allow these scripts to automatically add hosts that they discover to the Nmap scan queue. Brute. So these scripts use brute force attacks to estimate the authentication information of a remote server. Nmap, HTTP brute, Oracle brute, SNMP brute, etc., including many scripts that enforce the protocol. Discovery. These scripts attempt to discover more about the network by querying global records, SNMP, enabled devices, directory services, and so on and so forth. So, DOS. Scripts in this category can cause denial of service. Sometimes it is done to test the vulnerability for denial of service method, but more generally, it is undesirable because of the side effect required to test a conventional vulnerability. In other words, these tests sometimes crash sensitive services. Exploit. These scripts are intended to actively exploit a vulnerability. External. Scripts in this category can send data to a third-party database or another network resource. For example, WhoisIP establishes a connection to the Whois servers to obtain information about the destination's address. The operators of the third-party database probably record everything that comes into them, so this will log your IP address and the destination address. Most scripts that do not fall into this category contain absolute traffic between the scanning computer and the client. Fuzzer. Scripts in this category are designed to send unexpected or random fields by the server software in each package. Although the technique is useful for finding undiscovered errors and vulnerabilities in software, it runs both slowly and uses a lot of bandwidth. An example of a script in this category is DNSFuzz, which slightly bombs a DNS server with incorrect domain requests until the server crashes or a user-defined time limit expires. Intrusive. These scripts cannot be classified into a secure category because the risks may be high enough to destroy the target system. It can fully exploit the resources. That means bandwidth, CPU, RAM, of the target system. Therefore, they are perceived as unwanted processes by system administrators, as you may very well imagine. Malware. These scripts test whether the target platform is affected by malware or backdoors. For example, SNMP strange port, which monitors SNMP servers running on unusual port numbers, and authspoof, which identifies similar fraud numbers that give a fake answer before receiving a query. Both of these behaviors are usually caused by malware infection. Safe. Scripts that are not designed to crash services, use large amounts of bandwidth or other resources, or exploit vulnerabilities. They're less likely to harm remote administrators, but we cannot guarantee that they will never cause adverse reactions, as with other Nmap features. So most of them are performing general network discovery. Scripts in this category are not classified for security, but all other unsafe scripts should be placed as intrusive. Version. So scripts in this particular category are an extension of the version detection feature and cannot be explicitly selected. They're selected to run only when version detection, SV, is requested. The outputs are indistinguishable from version detection output and do not generate service or host script results. Vuln. These scripts check for specific known vulnerabilities and typically report results only if they are found. Default. So this is used with SC or the A parameter. Scripts defined in the default category are speed, usefulness, verbosity, reliability, intrusiveness, privacy. Script equals can be used with the default parameter. So Nmap script files in the scripts folder. If you don't know the folder name, you can list all the scripts when you run locate NSE on the command line. If you're looking for a specific script for a specific topic, then just type it into the command line. If you want to, you can always edit the scripts. You can review them, make changes. For example, if we are looking for DNS-related scripts, we just need to type in the command line Current NSE scripts are available at nmap.org. You can view all scripts and usage patterns at this address, nmap.org, NSE doc. So Nmap, since NSE is open source, it's constantly updated. Therefore, it is necessary to update the script database before scanning with scripts, yeah? So to do this, you just run the command, script update. Now there are a few parameters to scan the script with Nmap, and I'll show you a few of them. Nmap SC. If we only use the SC parameter, Nmap scans for each IP and port with scripts defined in the default category. Nmap script name, target. So in this case, Nmap will scan with the specified script. So if you want to get help with a script, we can use Nmap script help script name. Nmap scripts can be used with other parameters as well. So the script that we use here must be compatible with the service that we scan. Might not seem obvious, but... So let's write a few examples of Nmap commands. Example 1. So let's do a script scan related to HTTP. First, we'll do a port 80 scan on the current network. So we'll turn on virtual machines that we have installed, open VirtualBox, open Kali Linux 10.0.2.15, open Metasploitable 10.0.2.4, open Ubuntu 10.0.2.7, open Windows 7 10.0.2.6, and log in to Kali Linux VMs. Username root, password tour, open terminal, and write this command. Nmap 10.0.2.0/24 P80, press enter. Okay, so here are the scan results. And one of the machines that we found is Metasploitable 10.0.2.4. So let's check out what scripts we have. So go to the command line, locate *.nse pipe grep HTTP. And let's look at the results. So we can scan all of these scripts by using them, or you can use them one by one. So in this example, let's run an HTTP brute scan. On the command line, enter nmap 10.0.2.4 script HTTP brute and press enter. So if we want to look at what is in the script, we can write leafpad user share nmap scripts http brute.nse. Then when we open the script file, we can see all of the commands used and the explanations put in by the person who wrote the script. And if you want to get just about half, then just type nmap crypt script help http brute.nse and press enter. So here you can review it by clicking on the link on the Internet NSE doc. The scan results will be listed as follows. Now, if we want to crawl using all the scripts related to HTTP, go to the command line, nmap 10.0.2.4 script http *, press enter. But I'll be honest with you, this command can take a long time to run, because Nmap will try all of the HTTP scripts in sequence. So in this example, let's do a script scan on the Ubuntu VM using the default and safe categories. Now to get help on the default and safe scripts, at the command line, type nmap script help default and safe, press enter. And the help information related to each script will be listed. So we can turn on the virtual machines that we have installed, open VirtualBox, open Ubuntu 10.0.2.7, open Kali 10.0.2.15, log into Kali Linux VMs, username root, password tour, open terminal, and write this command at the command line, nmap 10.0.2.7, script, default, and safe. Press enter. There's your scan results. All right, so in this lesson, we're going to learn how we can do a brute force attack just by using the scripts. So brute force attacks, this is a type of attack that's based on, well, basically trial and error, right? This attack commonly uses automated tools to guess various combinations of usernames and passwords until they finally find the correct input. Nmap has multiple scripts about brute. If we list out the scripts, you can see Nmap has multiple scripts that vary from technology to technology. So in this lesson, what we're going to do is use MySQL brute, SSH brute, and FTP brute scripts, and we'll test the Metasploitable 2 machine. You ready to try these scripts? So first, run the Metasploitable 2 machine, open Kali Linux and VirtualBox, enter username and password, open terminal, Enter sudo su- for root permissions. Enter the root password. Cool, so let's start with the first script, which is the MySQL brute script. Write nmap -p3306. That way you can specify the port address. --script for choosing the script MySQL-brute. And the target IP address. Now, brute force may take some time, so while it's doing its thing, let me see some arguments that come with the script. So, for seeing the arguments, write nmap and the script name into your search engine, and nmap has a document for each script on the official nmap website. And as you can see on the screen, nmap gives us the arguments and the output of the script. If we look at the script output, what you're looking at is the script showing us the username and password for MySQL access. The second script is SSH brute. So we can write in the terminal nmap -p22 for specifying the port address, --script for choosing the script SSH-brute, and the target IP address. Cool, so the script immediately starts to try to find the username and password. Why don't we have a look at the arguments that belong to this script? So what you see on the screen are the arguments of the script. And here is the example usage. So the script shows the username and password for SSH authentication. Whew. So the third script, it's FTP brute. Write nmap -p21 to specify the port address, --script for choosing the script FTP brute, and the target IP address. And the script starts to try to find that username and password. Why don't we have a look at the arguments that belong to the script? Okay, so what you're looking at are the arguments of the script, and here's the example usage. So the script shows us the username and password for FTP login. All right, that's everything you need to know about how to use brute scripts.
Nmap timing templates. So in scanning on these networks, our goal, of course, is to make discoveries as soon as possible without being noticed. And this discovery identifies to us the computers and ports that may be open. This next step is to obtain the necessary information. Now, our biggest obstacle when scanning, of course, is security systems. But Nmap offers different alternatives for scanning without being caught in security systems. They are activated by the T parameter and named in the range 0 to 5. So the T parameter is only related to timing when it's used with other parameters. T0, paranoid, only one port is scanned at a time, and it's used to send packets very slowly. The time difference between the two packets sent is 5 minutes. So this option is one of the modes used to bypass security systems. T1, sneaky. So this mode is used when you want to send packets quickly, but it's still slower than a normal scan. The time difference between two packets sent is 15 seconds. Of course, this option will be the second mode that's used to bypass security systems. T2, polite. So in this mode, you'll be sending packets quickly, well, more quickly than T0 and T1, but certainly slower than a normal scan. So the time difference between the two packets sent is 0.4 of a second, and when scanning in this mode, you may be visible to security systems. T3 is our normal operation, so this mode is the default Nmap timing pattern used when the T parameter is not specified. So yeah, what is the time difference between the two packets sent? Is 1/10 of a second. T4, aggressive. You will use this mode when you want to send packets very quickly, and Nmap will wait only 1.25 seconds for a response. So the time difference between the two packets sent is up to 10 milliseconds. Now, the official documentation of Nmap recommends the use of T4 for modern, reasonably modern, and reliable networks. T5, or insane. So use this mode to just send insanely fast packets, and it'll only wait 0.3 of a second for an Nmap response. And the time difference between two packets sent is up to 5 milliseconds. So, of course, this mode makes scanning super fast, but sometimes you're going to sacrifice accuracy. So if it fails to complete a scan within 15 minutes, Nmap will give up a host. Otherwise, the T5 should only be used on a fast network and high-quality systems, because sending packets that fast can affect the operation of the network or the entire system and can even cause system failure. Bypass of IPS and IDS systems with Nmap. So what is IPS and IDS? With the development of network systems, security problems have arisen exponentially. The network system can attack the computers. Unauthorized persons may attempt to access computers. The outgoing packets over the network can be viewed by third parties and saved and viewed on their own computer. Critical systems running over the network can then be rendered inoperable and face many security problems. That's why they're called vulnerabilities. So in order to prevent these security problems, systems that constantly monitor the network and prevent future attacks are deployed. So these such systems are called IPS, or Intrusion Prevention Systems, and IDS, or Intrusion Detection Systems. So today there are many very advanced IPS and IDS systems. With the development of the Internet and these computer systems, many types of attacks can be conducted over a network. Therefore, IPS and IDS systems are used in just about every network system. Ooh, okay, so how can we scan that with Nmap? How can I scan without getting caught within an IPS and IDS system? I'm glad you asked. It's time to learn about that. How to bypass IPS and IDS systems. Now, there are actually many ways to circumvent IPS and IDS systems when scanning with Nmap. And I'll list some of them. Timing, the most basic detection method of IPS and IDS systems. Blocked if one rope on the network attempts to access multiple ropes and scans on all ports. So in this case, all you need to do is scan individual threads and ports. And then don't access more than one IP and one port at the same time. So in other words, you'll disable parallel scanning. So to do this, it's necessary to scan with Nmap in either T0 or T1 mode. But do remember that T0 and T1 will take a much longer time to scan. Source port. So another method is to scan packets directly through a port with Nmap. We can make Nmap act as an HTTP service. Many IPS and IDS systems allow packets sent through port 80 to pass through. But Nmap must be used with the source port parameter. So let's do an example. Turn on virtual machines that we have installed. Open VirtualBox. Open Kali Linux 10.0.2.15. Open Ubuntu 10.0.2.7. Open Windows 7 10.0.2.6. Log into Kali Linux VMs. Username root, password tour, and open terminal. And then write this command. Nmap 10.0.2.6, source port 80, press enter, and there are your scan results. Randomized scanning order. So another method is to randomly select the hosts to be scanned. Nmap will scan the threads in sequence when used in default or normal scanning. So in this case, the safety systems may interfere with the thread on which Nmap is installed. So in order to prevent this, we can provide random selection of strings to be scanned with Nmap. So for random scanning, we can use the randomize host parameter with Nmap. And I'll give you that example. If you turn on the virtual machines we have installed, open VirtualBox, open Kali Linux 10.0.2.15, open Ubuntu 10.0.2.7, open Windows 7 10.0.2.6, open Metasploitable 10.0.2.4, and log into Kali Linux VMs. Username root, password tour, open terminal, and write this command, nmap 10.0.2.0/24, randomize hosts, press enter, and the scan results follow. So as you can see, it didn't scan in any order. It randomly scanned all of the IP addresses. MAC address spoofing. So another method of bypassing firewall restrictions when port scanning is to emulate the MAC address of another computer. This technique can be very effective, especially if there is a MAC filtering rule that only allows traffic from certain MAC addresses. So you will need to discover which MAC address you need to set in order to get the correct results. So specifically, the spoof MAC option allows you to select a MAC address from a specific vendor, select a random MAC address, or set a specific MAC address of your choice. Another advantage of MAC address fraud is that you make your browsing more confidential because your actual MAC address does not appear in the firewall log files. Command: specify MAC address from a vendor, nmap spoof MAC del /apple/3com IP target. Generate a random MAC address, nmap spoof MAC 0 IP target. Specify your own MAC address, nmap spoof MAC 0A0027000006 IP target. And here's an example. Turn on the virtual machines that we have installed. Open VirtualBox, open Kali Linux 10.0.2.15, open Metasploitable 10.0.2.4, log into Kali Linux VMs, username root, password tour, and open terminal. And then write this command, nmap stpn spoof MAC 3com 10.0.2.4, press enter. And the scan results follow. So Nmap generated the MAC address of 3com and scanned it using this MAC address. Now to change the IPv4 lifetime or MTU value in sent packets, so Nmap gives the user the option to set a specific MTU, which is the maximum transmission unit, to the package. So it's similar to the packet fragmentation technique. During scanning, Nmap will create packets based on the number of MTUs we provide. For example, if we set the MTU to 16, Nmap will generate packets of 16 bytes and cause confusion on the firewall. Please note, though, that the MTU value must be a multiple of 8. So 8, 16, 24, 32, etc. So here's an example. Turn on the virtual machines we have installed. Open VirtualBox. Open Kali Linux 10.0.2.15. Open Ubuntu 10.0.2.7. Log into Kali Linux VMs, username root, password tour, open terminal, and write this command. Nmap MTU 16 10.0.2.7, press enter. And the scan results follow. Send bad checksums is another way to circumvent security systems. Send incorrect checksum packets. Now, many security systems ignore faulty packets, especially due to performance problems. So by taking advantage of this incorrect behavior, we may be able to send incorrect checksum packets with Nmap. And you can use the Nmap bad sum target command to send packets to destinations that have failed checksum packets. So I'll show you an example. Turn on the virtual machines we have installed. Open VirtualBox, open Kali Linux 10.0.2.15, open Ubuntu 10.0.2.7, log into Kali Linux VMs, username root, password tour, open terminal, and write this command. Nmap badsum 10.0.2.7, press enter, and there are the scan results. Fragmentation. So yet another method is to shred the sent packets into smaller packets. To do this, we can use the F parameter in Nmap. For example, if you turn on the virtual machines we have installed, open VirtualBox, open Kali Linux 10.0.2.15, open Ubuntu 10.0.2.7, log into Kali Linux VMs, username root, password tour, open terminal, and write this command, nmap f 10.0.2.7, press enter, and there are your scan results. So there are numerous tools on the market to conduct a penetration test. However, achieving success in a test largely depends on the right set of tools and the techniques that are used. In order to complete a test, you've got to choose the right set of tools and apply the best methodologies. Sure, it would be a whole lot easier and a whole lot of time savings if just one single tool could help you perform all the required tasks for penetration testing. That's why when I think of the best tools for penetration testing, Metasploit framework is the one that first comes to mind. In the security marketplace, it's considered to be the most effective tool to conduct a penetration test today. It can literally perform all tasks that are involved in a penetration testing lifecycle. Now, it's important to understand the capabilities of Metasploit so that it can be leveraged perfectly during each test. With the use of Metasploit, you really don't need to reinvent the wheel. It offers a wide variety of exploits, information gathering modules, with a few web testing capabilities too. So Metasploit allows you to easily build attack vectors to augment its exploits, payloads, encoders, and way more in order to create and execute more advanced attacks. So besides manually or automatically accomplishing these tests, Metasploit is not just an application. Like I said before, it's an entire framework that has an extensive exploit development environment. And what that means is it allows you to customize and extend the framework for whatever your requirements may be. So no doubt you've seen that it's a very powerful tool for penetration testing. However, I want to warn you, it's not a magic tool that can help you hack into any target system. One of the goals of this course is to get you comfortable with the framework, show you some advanced attacks, and ensure that you can apply these techniques responsibly. Right? So in the next few hours, you will be talking about the Metasploit framework. Now, before we jump into the hacking, you should know why I prefer Metasploit among all the other tools out there. Thankfully, first up, it's an open source project. So, yeah, this is pretty much my main reason why I go with Metasploit. It's also actively developed. Metasploit allows you to reach the source code and customize the modules. And yeah, it has a chargeable version, but I will give you details about all the different versions in the next section. I also think it's easy to use Metasploit. It has reasonable naming conventions and commands. And it's great for testing large networks because you don't get confused and you don't have to dread a whole lot of extra busy work. Because Metasploit offers to test the entire range automatically. It uses parameters such as subnet and classless interdomain routing, CIDR values. So therefore, Metasploit saves a large amount of time and energy. Now, Metasploit has a variety of payloads, and you can easily switch between them. For automated exploits, you can create and set payloads quickly. Moreover, generating shellcode to use in manual exploits also becomes easy by using the MSF Venom from the command line. Metasploit also offers cleaner exits. In other words, when you try to compromise a system by using a custom-coded exploit, you've got to be really careful. Because if the exploit does not have a right exit code, that has the big potential to crash the system. And believe me, that's not a good practice at all. So if you don't want to face such situations and the wrath that it brings upon you, Metasploit is also responsible for making a much cleaner exit from the system that you want to get into. And luckily, the graphical user interface. Yeah, the commercial and the community version of Metasploit has GUI, and you can perform most anything from there. So this brings up the question, what do you have for Metasploit framework? The answer is Armitage, which is a third-party interface. Hopefully you're going to be learning these environments more in the later sections. So stick with me. So, over the last decade or so, technology development has dramatically increased, which can easily be observed when you have a look at what's in your pocket. I'm talking about your cell phone. So, therefore, a new form of technology pops up, and it finds application fields in the market. Bitcoin, cloud, IoT, virtual reality, artificial intelligence, and machine learning applications, and so on. Also, now programming languages and frameworks are far more powerful and versatile. So I'm hoping that therefore this evolution will never end. Gives me something to do anyway. Moreover, private and governmental organizations are in such a competition for applying these improvements. Almost all the businesses move partially or completely to IT. They create new web applications, buy new hardware, and set up new data warehouses. Almost everything is automated. And even you are part of the system. So while these technologies completely change the way you do things, they also bring along some threats with them. And these threats, they will come into your life. And then the organizations that you perhaps work for, they will overreact or apply too much effort for detection and the protection of their system. They are so deeply concerned about keeping their data safe, they'll invest millions and millions of dollars in security programs to prevent possible data breaches. Then attackers can discover new ways of manipulating technology, and then the security programs develop new ways to prevent data breaches, and it goes on and on. While defensive security measures can fail, testing the system against the adversaries gains much more importance. So penetration testing is the best solution for organizations to accomplish these scenarios. I mean, testing is not the only way to protect the system. However, it is one of the most effective ways to identify the weaknesses in the systems, right? So by attempting to circumvent security controls, penetration testing can identify the ways in which a hacker might be able to do so. The organization will get the idea of how an attacker can gain access to their system and how they can then stop that attacker to be effective. And then, of course, that way they can easily identify the negative and positive aspects of their security system. So for all these reasons, and probably more than I can think of, and you could probably come up with a whole bunch more, but you can see that all compliance and auditing firms include penetration testing in their operations. So, with penetration testing, an organization can easily evaluate its security posture. All right, so penetration testing execution standard. It's a specification document which is redefining the penetration test for both new and experienced penetration testers. It has been adopted by several leading members of the security community. So therefore, if you feel you are new to penetration testing standards or uncomfortable with the terms, please have a look at it. The penetration testing execution standard, I believe, will be the best one for you to go from. Now, I know that last sentence sounds like an advertisement, but you're not going to lose anything if you check some of these documents once, okay? So PTES is divided into 7 phases. Let's have a look at each of them briefly. Pre-interactions. So the pre-interactions, typically, that's the phase that you discuss the scope and the terms of the penetration test and convey your goals of the engagement with your client. While discussing the scope of the penetration test, you should clarify all the domains that will be tested, as well as any special requirements that are going to be needed, such as special privileges and the access to the critical systems and so on and so forth. See, that's why you're going to develop your own way of keeping track of it all. The expected positives of the test should also be part of the discussion with the client in this phase. Great, so now this is what you should do before testing begins. Intelligence gathering. The information or intelligence gathering phase, or reconnaissance as I talked about earlier, it's one of the most important phases in penetration testing. If you are properly gaining knowledge about your target from social networks, Google, or any other way that you can accomplish, you're going to be able to simulate appropriate and exact attacks rather than trying all possible attack vectors. This will also help you save a huge amount of time as well. So I believe anyway, it's a duty of a penetration tester to gather enough information about the target by performing a variety of scans. So that includes looking for open ports, identifying services running on those ports, and you're also going to be able to discover what vulnerable services exist. I find this phase particularly important. So, in the Metasploit framework, there are many auxiliary modules that enable you to gather information from the targets. Now, the next phase is threat modeling. So this phase focuses on categorization and modeling of the threats based on their impacts on the system. Now, in my point of view, this phase is not necessarily always applicable. It depends upon how much time you have. If you are performing a long-term red team activity, modeling threats are going to work for you. But on the other hand, in an ordinary situation, you probably don't have the time to model a threat. You're going to look rapidly for a way to exploit and gain access to the system. So our next phase will be vulnerability analysis. Now, in this phase, you analyze the target network and make a vulnerability scan over that network to identify all of the weaknesses. Once again, this is a very important phase. It's also what I would call a stepping stone into the exploitation phase. So the next phase is exploitation. Either manually or automatically, you will detect vulnerabilities for this network. In this phase, you'll identify which vulnerability is applicable, if possible, and then you run the appropriate exploit for this particular vulnerability. Now, being successful in this phase means that you have access to the system. Now, believe me, you will be satisfied. And now it's time to gather some extra information. So this next phase is called post-exploitation. After gaining access to the target, you will look for some extra information and use some advanced ways to maintain your access. Now this phase, if you haven't ever done it before, this is going to be really mind-blowing for you. And then our last phase is reporting. So you've done a whole mess of things, okay? So you've exploited the target, maintained your access, and all kinds of things. Now, to a client, this might not even seem like much. You might not even have been detected by the client. So you have to report on what you have done on the system in a proper way. So it's important for this to make absolute clear sense. And otherwise, clients, they're pretty much going to wonder what you actually do. So it's important that you practice what you've learned while the course develops. And for that reason, you should build your own lab. Mwahaha. So don't worry, I'm going to help you build it step by step. This is going to be your own lab, so you can customize it the way you want, but I will teach you each step one at a time. So before you even jump to any conclusion, all the lab environments will cost you zip, nada, nothing. Only your time and perhaps patience. So first, let's have a look at the requirements. When you prepare your lab, you should make sure that your setup will meet the basic system requirements. Because we'll be using virtual machines and some pretty processor-intensive tools, I highly recommend that your system should be capable of handling at least 2 virtual machines at the same time. So for storage, I don't want to give you, just any random numbers about the size of available hard drive space, but you really will need it. If you don't have enough, you're probably going to face some problems. Now for memory, insufficient memory fails suck, so I strongly advise using at least 16 gigabytes of RAM. For your processor, I think if you're on this course, it means that you've probably got a good enough processor to support virtualization. Now, you should activate it from BIOS if this is the first time for you to actually start up with a virtual machine. And what about for a hypervisor? VMware Player, VMware Workstation, or VirtualBox? All of them are going to be good options to build this lab on. You're going to watch me using VirtualBox because, well, some intentionally vulnerable virtual machines only work on VirtualBox, so I would highly recommend you do that too. And finally, we'll talk about your internet access. You are going to need internet, but only when you're setting up the lab. Otherwise, I don't think you're going to need it. You can do it offline, but it'll be good to search for extra information. So basically, the lab network will be all that. You'll be using VirtualBox in NAT network mode as hypervisor. Then you will download and configure the virtual machines together. So let's get started first with VirtualBox. So now let's provide connectivity between your virtual machines. So the way I'm going to do this, I will include all of my virtual machines in a NAT network. I'm first going to start with Kali. So I'll choose it, click Settings, go to Network Settings, change NAT to NAT Network, right? And click OK. Now do the same thing for the other virtual machines quickly. So snapshots. I strongly advise you to take a snapshot of each machine in your lab. Because you're going to, do some hacking stuff on each of the machines. They're going to contain many payloads and exploits on them. You may crash them or trash them or do whatever the heck you can to them. So take snapshots so you don't have to create and import the machines from the very beginning. You can go to the Snapshots menu from here, or from the above menu, go to Machine Tools, Snapshots, and you'll see this pane here. So choose your virtual machine and click this green plus sign, and then give a name and write a definition about your snapshot. So I'm just going to leave it the same and just write the definition as clear to define it as a clear installation. You can write whatever you want about yours. Click OK. And now I'll just quickly take the other snapshots. Yeah, so there it is. I finished taking snapshots. So finally, we finished building the lab. So let's get hacking. So here we are. Meet the Metasploit framework. This is pretty much your Swiss Army knife to pen testing. Until now, you might recall the basic phases of a penetration tester and completed the lab setup. So let's talk about the big picture. Metasploit framework. I consider the MSF to be one of the most useful penetration testing tools freely available. The Metasploit framework provides an impressive workspace that is, beyond any others that I can think of, because it's beyond any one particular tool that has a bunch of exploits. So it's more than that, though. You can customize it for your own purpose. From a wide variety of commercial exploits, as well as an extensive exploit development environment, all the way to network information gathering tools and web vulnerability plugins. You can pretty much find almost everything that you need for a penetration test. But to be clear about this course is I have prepared this in a manner to encompass only the front end or the user aspects of the framework, pretty much with the aim to give an in-depth look into the many features of Metasploit. So this isn't an exploit development course for MSF. I'll plan that for later, and you'll be raring to go. But it is an amazing tool for sure. So before we do a little walk around, let's have a little brief talk about its history. And believe me, I'll be brief. Won't be too long. So the creator of Metasploit is H.D. Moore, who was spending most of his time validating and sanitizing public exploit codes to use in 2003. Then, the idea of a framework formed in his mind, and the first edition came out. The first edition was a complete Perl project released in 2003 with a total of 11 exploits. Then, with the help of some other friends, Metasploit 2.0 was released in 2004 with 19 exploits and over 27 payloads. Then shortly after this release, the team continued to widen, and Metasploit gained popularity in the information security community. Then following a complete rewrite in the Ruby programming language, the Metasploit team released Metasploit 3.0 in 2007. 150,000 lines of code added to the project in an 18-month period after migrating from Ruby. With the 3.0 release, Metasploit saw widespread adoption in the security community and also a big increase in user contributions. In the fall of 2009, Metasploit was acquired by Rapid7, which allowed HD to build a team to focus only on the development of the Metasploit framework. After the acquisition, updates have occurred more, rapidly. Then Rapid7 released 2 commercial products based on the Metasploit framework, Metasploit Express and Metasploit Pro. Metasploit Express was a lighter version of the Metasploit Pro. But for this version, Rapid7 announced the end of life on June 4th, 2018. So the team will focus on Metasploit Pro by adding new features such as collaboration, group penetration testing, and so much more. So I told you I'd be brief. This was your history class of the Metasploit project. So like it or not, basically the life cycle of a product pretty much defines what it is. So being familiar with the file system of a tool might help you to exploit it a little bit better. So take some time to make yourself familiar with its file system. In order to do that, the best way to learn the structure of Metasploit is to browse through its directory. Metasploit framework is provided in the User Share Metasploit Framework directory in Kali Linux, and one can more easily understand the Metasploit architecture by having a look under its hood. So let's examine the file system of Metasploit and see just how the framework is constructed. So I'm going to open a terminal, and let's have a look, see where we are. So I'm going to Metasploit Framework directory, and when using Kali Linux, the Metasploit framework is usually located in the path User Share Metasploit Framework. So let's see what we have here. Right, so hopefully if you can see over my shoulder here, the MSF file system is organized by really well-defined directories. And the structure is very clear. The Metasploit framework has a variety of component categories based on their role in the penetration testing phases. For example, here, the data folder. This directory stores editable files, such as word lists and binaries, required for some of the exploits. So let me show you some of the word list directories. Metasploit uses these lists for brute force. The documentation folder. As its name suggests, the documentation directory contains the available documentation for the framework. Modules folder. all the Metasploit modules are contained in this directory. Now, the modules directory is where you will find the actual MSF modules for exploits, auxiliaries, post modules, payloads, encoders, and NLP generators, and you will be interacting with Metasploit mostly by modules. The primary directory for modules is user, share, Metasploit framework modules. But you can use your own modules from your home directory at MSF4 modules. Plugins folder. And as I said before, Metasploit is not a rigid tool. You can customize it and add plugins to increase its power. So you're going to find these plugins in this directory. Some of the common plugins are OpenVAS, Nexpose, Nessus, and a variety of others which can be loaded into the framework using the load command. Scripts. The scripts directory contains Meterpreter and other scripts. Now I'm going to show you some of the Meterpreter scripts. These scripts help you to automate some of the post-exploitation jobs, such as keyboard recording, dumping password hashes, and getting much more information from the compromised system. Tools. The tools directory has various useful command line utilities that aid in penetration testing, and that's contained in this folder. Oh, I also want to show you how to view the Metasploit directory from the GUI. Now, this will be way more helpful to get a better understanding of the framework and all of its components. So from folder view, user, share, Metasploit framework, and now you're in the Metasploit directory. You can open the folders that you have viewed from the terminal. So you've learned so far that Metasploit is a complete penetration testing framework, and it's not just a single tool. When you call it a framework, it obviously means that it consists of many useful tools and utilities. So I've shown you basically an overview of the Metasploit file system. Metasploit consists of various components such as libraries, modules, plugins, and tools. So here I have a diagrammatic view of the structure of Metasploit for you. Let's have a look to understand the use of the various libraries as explained in the diagram. Rex handles almost all core functions such as setting up sockets, connections, formatting, and all the other raw functions. MSF Core provides the basic API, and the actual core that describes the framework, MSF Base, provides some friendly API support to the modules. So if you're not developing exploits or some of the other modules, you will mostly deal with prepared penetration modules, showed here in the red rectangle in the diagram. So you have the option to load modules either at runtime or from the MSF console. To load modules at runtime, from the terminal, pass the M option when running MSF console. But you can also load your modules from MSF console by using the load path command. Now let's have a look at this colorful diagram. It's a broad level structure of Metasploit framework. You're going to be using auxiliary modules to carry out operations such as information gathering, fingerprinting, logging into various services, and so on. These modules are particular to enumeration. For example, you might want to perform a version detection on an FTP service to model an attack. Such tasks can be very easily accomplished using auxiliary modules present in the Metasploit framework. As I created this course, there are over 1,000 auxiliary modules spread across 19 categories in the Metasploit framework. This screenshot shows various categories of the auxiliary modules present in the Metasploit framework. Now, I'm just giving you an idea of how deep it is. I don't need you to get overwhelmed by the number of auxiliary modules present in the Metasploit framework. So you don't need to know each module. You only need to know how to find the appropriate one. All you do is search the right module in the required context and use it accordingly. You're going to cover extensive usage of examples of auxiliary modules in some of the later sections of this course. But since you asked, let me quickly show you one. So I'm going to make a TCP port scan on Metasploitable 2. But first, look at the path of the auxiliary TCP port scan module. All right, so it's here, as you see in the path. So let me bring the Metasploit 2 to the record screen. It's on my second screen. Okay, so look at the IP address, 10.10.2.14. So I'm going to make a port scan on this IP. Open your terminal with me. And before I start Metasploit, it's better to start PostgreSQL. I'll talk about databases after you're familiar with the environment. So I'll initialize the Metasploit databases with msfdb init command, then type msf console q to start Metasploit in quiet mode. Okay, so finally it's open. Now the basic syntax of usage is like this. Type use, and then the name of the module that you want to use. In this case, auxiliary scanner port scan. Now here I'll press tab. As you can see here, Metasploit has a magnificent tab completion. So now I can type the rest. And to show the variables of the module type, show options. You see the variable names make sense. Ports, rhosts. You can set a variable like this. Set rhosts 10.10.2.14. Same for ports variable. Set ports between 20 and 500. Then run the module. So it'll take a few minutes to scan for the ports between 20 and 500. And there, it's finished. So as you can see, these TCP ports are open on Metasploit 2. And this is pretty much the basic usage of an auxiliary module. So let's go ahead and meet some of the other types of modules. A payload is a piece of code that executes on the target system, and it helps us carry out some of the operations, such as connect to the command line of the target after a successful exploitation. To basically understand what a payload does, let's consider a real-world example. So I want to show you an example that I heard of before, which helps me understand it as well. Payloads are kind of an explosive material that's in the head of a missile. When the missile hits the target, the explosive material causes the damage desired by the owner. Now, the owner of the missile can change the explosive material as well as the payloads. So that's the way that the Metasploit framework works with payloads. It allows you to perform some operations on the target system. For example, a reverse shell is a payload that creates a connection from the target machine back to you as a Windows command prompt. Whereas a bind shell is a payload that binds a command prompt to a listening port on the target machine, which you can then connect to. This screenshot shows various categories of payload modules present in the Metasploit framework. So I'm going to go to the Metasploit directory to view payloads. I'm using GUI to be clearer. And here, under the payload folder, you're going to see three different kinds of folders named singles, stagers, and stages. These are the main payload types. Singles are the payloads that consist of the exploit and require shellcode, which means they have everything that is required to exploit the vulnerability on the target. Naturally, the size of these payloads is pretty big. Thus, it's not going to be good for if you want to be stealthy. So, for example, this one, Meterpreter reverse TCP. And stagers. Just so you know, sometimes size really matters. Okay, the stagers payload comes in handy in such a situation. So they don't have the exploit code. That means they're going to be smaller in size, and it's going to help you in many other tests. Like this one, bind TCP and reverse TCP. And then finally, stages. After the stagers communicate with the target system, stages are then uploaded to the target system to do the actual actions desired by the penetration tester or attacker. And here you see the Meterpreter payload, which is the most used stages payload. And you'll use it in many exploits, but we're going to get to that in some of the later sections. All right, so that's enough theory, don't you think? So open up your terminal again. And just like before, you can use an auxiliary module. Usage is the same. Use, and then the payload name. Use payload, Windows, Meterpreter, bind TCP. Now, let me tell you an important point here. Bind TCP payloads make the attacking machine directly connect to the target. So, when you show the options of this module, there will be rhost and lport variables. Rhost defines the address of the target machine. Now, in this case, it is the IP address of Metasploitable 2. And lport is the port number on the attacking machine that the attacking machine will listen on. And then on the other hand, there is reverse TCP connections. So I'll show you both ways. Use payload, Windows, Meterpreter, reverse TCP. When you show the options, you will see the lhost and lport variables. So in this case, lhost is the IP address of the callie that the target will connect back to. And lport is the port number on the callie that will listen for incoming connections from the target. So I'm going to set lhost as my IP address. Let me check my address on a new tab, just want to be sure. Okay, 10.10.2.11 is my IP. And I'll set lport to 4445. Then you can use run or generate as a command to generate the shellcode of this payload. So this is the payload, and by scrolling down you can view just how long it is. But see, now you can use it as an exploit code. But you're not going to work that way in this course. I'll tell you why coming up. So exploits are the most important part of the Metasploit framework. They make you take advantage of a flaw within any particular system, an application, or a service. So it's by using exploits that you, or maybe an attacker, can get the results from that the developer or the system administrator would never intend for. In Metasploit framework, there are 1,824 exploits when I recorded this course, which includes more than 15 categories based on the different platforms. And right up here are the various categories of the exploits. Now, I guess you might think about how you're going to find your way among all of the available exploits. So let me quickly show you one. Now, first, I got to mention you've got to be very careful before using any of these exploits. So let me suggest to you that you make an extensive enumeration on the target that you want to use an exploit on. A proper enumeration of a target might give the operating system of the target, including the exact version and architecture, open ports on the target, both TCP or UDP, services with a version information, and probability of a particular service being vulnerable. So, first, let's have a look at the exploit modules from the GUI. Look into the folder, and here there are over 15 categories. And under each one, you'll find even more categories. Under Unix FTP. Here's the exploit that I want to use. So we'll go back to the terminal. Now I want to clear the screen. Usage is the same as auxiliaries. Use, and the name of the exploit. Use exploit Unix FTP vsftpd backdoor. So I'll use this one just as an example. Then show you the options of the exploit. Set rhost to your Metasploitable2 IP address. Default port number is 21. So you don't need to change it unless you find that this version of FTP is running on another port. And I'll show you the options again. Okay, so here you go. Type exploit to run the exploit code against the Metasploitable2. And ta-da! You have your first shell on the target. As you can see here, Metasploit warns us about the open shell. So this is not an interactive shell. And while you can type some Linux commands directly here, who am I using the shell? Ooh, root user. Type ID to see the actual user. And yeah, sure enough, it's correct. So you can write here Linux commands. For example, ifconfig. And you see that? This is Metasploitable2. Now, when you create payloads directly, most of the time these payloads are detected by security tools on the targeted systems. So at this point, you will need something tricky to evade their security tools. And as you can guess, encoders come to the rescue. Now, the job of the encoders is to obfuscate your payload in such a way that it goes undetected by any of the security systems on the target system. So have a look at the table on the screen. It shows the various encoder categories available in the Metasploit framework. So clear the screen and minimize it. And I'll show you the encoders folder from the GUI. So it's under the modules directory. You'll find the encoders folder, and that contains 10 different categories. And I will use this one under x86. So now let's turn back to the command line. To view the encoders from Metasploit, type show encoders. All the encoders will be listed just like that. Now you are allowed to encode each payload directly in Metasploit by typing set encoder and then the encoder schema name. But mostly you will use encoders with MSF Venom tool separately. So I'll do that in this tab. Open a new tab. Now, let's not get confused about MSF Venom. I'll tell you about it later in a separate section, just wanted to show you what the deal is. So now, let's just focus on the E parameter. With this parameter, you will define the encoding schema for your payload. So let me complete this example. By hitting enter, an exe file, which contains an encoded payload, will be generated. And then look here, it's the root directory, and you'll see the file. And as you can see, this is a Windows executable file. Now, the post modules contain various scripts and utilities that help you to further infiltrate your target system after a successful exploitation. Once you successfully exploit a vulnerability and get into your target system, the post-exploitation modules are going to help you in the following ways. Escalate user privileges, dump OS credentials, steal cookies and saved passwords, get key logs from the target system, execute PowerShell scripts, and make your access persistent. The Metasploit framework has more than 250 such post-exploitation utilities and scripts. So after gaining a shell, you can choose the appropriate post module to gather more information from the target or escalate your privileges. So let's see what a post modules directory looks like. Under modules, post, and there are the post module directories. So because I have exploited a Linux system, I'll need to use Linux post-exploitation modules. So let's go have a look at the Linux folder. And under Linux, there's a gather folder. And what do you have here? The hash dump module. Now, it's not only for Linux. If you look over here, you have the same for Windows as well. Now, before we go jumping into the command line, I just want you to realize just how meaningful the Metasploit directory structure really is. Now, you might ask, can you find your way around only by examining the structure? Let's go back to terminal. So now I'm going to use the VSFTP exploit again. So use exploit, Unix, FTP, VSFTPD, show options. Everything is ready to exploit. Then exploit J. So this command will exploit the target, and if I get a session, then it will hold that session in the background. Type sessions to list the available sessions in the background. And there it is. It's session 4. So now is the time to use a post module over this session. Now the usage syntax of a post module is the same. Type use, and then the name of the post module. Use post, Linux, gather, hash dump. Now, show the options to me. Only the session variable. So, set this variable to the index of the session 4. Then exploit. Ha 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 ha. So here are the password hashes of Metasploitable2 users. Now you don't have to stay with that. You can also use some of the other post modules. Metasploit comes in various editions. And now that there are 3 options, the Express edition isn't used any longer. The first one is a commercial edition, Metasploit Pro. So this edition offers tons of great features. It allows you to scan web applications, evade antiviruses, as well as automate exploitation. The Pro version is generally used for advanced penetration testing and included in organization security programs. So let's see what the next flavor is. Metasploit Community. So this is a free edition. It might fit for students and small businesses who want to deal with security. Now, naturally, the edition is not as capable as the Pro version is, but it can really fit into your requirements. And then the last edition is Metasploit Framework. This is the command line edition with all the manual tasks, such as manual exploitation, third-party import, and so on and so forth. And because the framework is the base for all the editions, this is the one that makes more sense for the developers and the security researchers. Now, I also want to clarify something important, that throughout this course, I will be using the Metasploit Framework edition. So except for some of the experimental purposes, I'm not going to be using the other editions. But I will show you the installation and basic usage of them so that you remain familiar. So unless I particularly specify Metasploit, you should take it to mean the Metasploit Framework from now on. And sometimes I'll say MSF, which is short for Metasploit Framework. Now this illustration can help you to understand the differences between the editions. And of course, Metasploit Pro has some additional features. So it is indeed obvious to me, and certainly I hope to you, that Metasploit Pro is addressed more by security professionals and the security consulting practices. Now, unlike the others, the Pro version has an increased execution and browsing functionality. So besides what open source framework offers, Metasploit Pro goes above and beyond by delivering a full graphical user interface, automated exploitation capabilities, and complete user action audit logs, as well as customizable reporting. The Pro features an advanced penetration testing workflow that includes antivirus evasion, customized reporting, social engineering capabilities, web application support, VPN pivoting, and multi-user capabilities. Metasploit Pro can also be installed on Windows, Linux, and Mac OS X machines, and you can certainly run it on almost any web browser. Or you can continue to use the command line interface, which they call ProConsole. Metasploit Pro is fully supported by Rapid7's security and support specialists, in addition to the large and, well, it's been growing, the Metasploit community. So to use Metasploit Pro, you will need to purchase it from Rapid7 and install it on your system. However, they have cleverly developed a trial version, so you can go ahead and download it and examine what the Pro version offers in detail. The Metasploit community is a lighter version of the Metasploit Pro. Now, like the Pro Edition, you will have a graphical user interface over the web browser. And that will incredibly help you to simplify your efforts, such as network discovery and vulnerability verification for specific exploits. You can increase the effectiveness of your vulnerability scanners, such as Nessus, Nexpose, and so forth, by using them with the community version. The Metasploit community offers some great features. Map your network. That supports you to scan and make host identification. Provide a concurrent export-import capability that helps you to work with tools such as Nessus, Nmap, and others. In addition, Nexpose scans can be initiated from within the Metasploit Community Edition. And a bunch of other wonderful features you're going to see. So the only thing you should be watching here is enumeration and safe exploitation. Oh, and another thing that I forgot to say. I think it's the best part. It's free. Still. So let's have a look at the interface. Now, although there is a whole section about community, I only want to show you the interface for now. If you don't want to install it by yourself, you don't have to do it now. It's in its own section. So have a look at the interface. And it displays over the web browser. So I'm just going to open my browser. I happen to have it bookmarked here. And this is a login screen for the Community Edition. Going to enter my login info. And click Sign In. And this is the main view. Now I'm going to zoom in and hide this panel to get a better view. Yeah, that's a little better. So as you can see, the projects reside here. You can list or create a new project from this menu. And over here on the upper right-hand corner, you will see the global settings and community user account information. All right, so now let's view the details of Pentest 1. So this is the overview, the summary of the project. However, on the above menu, you can also see some special items to work with Metasploit community. For example, you can manage hosts, your sessions, and your credentials. Some menu items like web apps are only in the Pro version. So that means you're going to see this annoying page. Metasploit also offers various types of user interfaces, and each one has its own advantages. The GUI interface. With the graphical user interface, some people say GUI, I tend to prefer GUI. Almost everything might be done by clicking a button. This interface is user-friendly, and that helps to provide a cleaner scanning and exploiting environment. I've showed you that while talking about the Pro and the Community Editions. You might like it a whole lot better because it just, is a clean way to exploit a target. Now, this is the console interface. The way I see it, most of the penetration testers and security researchers use this interface. It's also the most popular one. Its power cannot be underestimated. This interface provides an all-in-one approach to basically all the options offered by Metasploit. It's also considered one of the most stable interfaces. Now, throughout the range of this course, I'm going to be using this console interface for the most part. And once you get used to the environment and the commands,
you're going to consider yourself a console ninja. And the next one is the command line interface. Metasploit had an interface named MSF CLI, but nowadays it doesn't really exist. You can use MSF console's X parameter to accomplish the exact same thing now. It supports almost every feature that Metasploit framework has, such as the launching of exploits to activities, payload generation, and so forth. However, I think it's hard to memorize every command each time, so I tend not to use it too much, although somehow I'll use it a couple of times. You'll see when we get there. So for those of you who want to benefit from MSF, but you really feel you need a GUI, hold on. The next one is for you. Armitage. 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 You say Armitage. Anyway, Armitage by Raphael Mudge. It's a cool hacker-style GUI interface. It provides a lot of the features such as easy vulnerability management, Nmap scans, exploit recommendations. It uses Cortana scripting language for automation. Now, to be honest, I don't really use this feature, and so I will give you some extra thoughts about Armitage in the next slide. Also, there's a full section that covers how to use it efficiently, so stay tuned. I first want to show you the equivalent of the old MSF CLI interface. Because it doesn't exist now, MSF Console's X parameter does the exact task for you. So, open your terminal. MSF Console H will display a basic help menu. Now here the parameter and its description is visible. But now I'm going to use it as type MSF Console X. Then, between double quotes, write your Metasploit commands. So I'm going to use the VSFTPD exploit again. And yeah, there's no tab completion here. So that's why I was saying earlier, it might be a little more difficult to remember the command each time. So anyway, hit enter. And it'll start the Metasploit at the very first moment. Then it will use the exploit and set its variables. A session is open in the background. So I will interact with that session by sessions I1. Now, because this is not a Meterpreter shell, you can directly write Linux commands to the screen. Uname A to check the machine's full name. Ifconfig, and this is what you saw earlier in Metasploitable 2. Now, due to some licensing issues, Offensive Security doesn't ship Metasploit Community and the Trial Pro versions in Kali Linux. That's why I want to provide you with another free option, which is called Armitage. Now, it's not an addition of the Metasploit framework. It's an interface that will help you manage your penetration tests. It has a very good Java-based graphical user interface. And as I said before, hey, it's developed by Raphael Mudge. So the goal here is to help security professionals better understand hacking and help them realize the power of Metasploit. So now let's have a look at how to get into this tool. You don't need to install Armitage into Kali. It already comes pre-installed. So naturally, you can install Armitage to some other Linux distros, but for Windows, it's not valid. So you can't work with Armitage on Windows systems. Now, you may find a way to use it on Windows, but it probably won't be worth the effort. Anyway, open your terminal and type Armitage. And it asks for connecting to the database server, so click Connect. And then it'll ask to start Metasploit RPC server to remotely interact with Metasploit, so click Yes. And at first glance, this is what it looks like. Now, you see that on the left pane, the modules are there. And on the right pane, there is nothing, but if you have your hosts, it will be listed. And below is for the console and the module-specific tabs. So you can manage Armitage from the above menu. And Here inside the Armitage menu item, you can set global settings for Armitage and create listeners, change the view of the right pane. The console item provides you with a place to manage your credentials, your jobs, downloaded files, and all that. And you'll see that they come up as tabs below. Under the host item, there are options for managing hosts on your penetration test. Armitage allows you to add host and make an Nmap scan on them at any time during a pen test. Another great feature of Armitage is here under the attacks menu. It will suggest exploits for your target host after a rather extensive enumeration. So if you want to, you can try every suitable exploit onto the target host. On the workspace menu, you can create and change between your workspaces. So that is Armitage in general. We're going to get into much greater detail in an entire section of its own just a little bit later. So now you have the basic information about the Metasploit framework and its structure. So why don't we go ahead and let's get started with the basics of MSF console. And I guess you could consider it the most popular interface. But before I show you a demo, I want to tell you a little bit more about it. It is just a simple command line interface for the Metasploit framework. However, don't let its simplicity fool you. It's an easy and flexible way to interact with the framework. It's the most stable and powerful interface to access most of the features within MSF. Now, at first, the syntax might be a bit confusing. It's not going to take you much time to appreciate the power of this interface. Now, you will use MSF console to rule the Metasploit framework throughout the rest of this course. As I mentioned to you earlier, some of the Metasploit editions offer GUI and web-based interfaces. However, I think from a learning perspective, I'm always going to recommend mastering the command line console of the Metasploit framework. And among my favorite things is the Linux command style tabbing, as well as the command completion. That's my friend, and I'm sure it'll become your friend too. So go ahead and open your terminal and simply type in MSF console H to display the basic help for the console. So this is basic help menu for MSF console. Now, certainly you're familiar with the Q and the X parameter from some of the previous videos. For the other ones, I'm going to let you go ahead and discover them by yourself, because you're not going to really need them throughout the rest of this course. So, to interact with the console, just type MSF console. So I add the Q parameter to start the Metasploit in a quiet way. And you'll get the point after a few minutes. Watch. So type it and hit enter. Now, if this is the first time you start it up, you may need to wait a little longer, but not too much. And look at that. That's all there is. MSF console is all that. So to find your way and take advantage of using Metasploit, MSF console provides some commands, and you can type help to view the commands. So they're categorized by their usage purpose. Here are some of the core commands. The core commands work all the time. They are not specific to a particular module or something else. And then the module commands, these ones are related to the modules such as exploit, payloads, and those are the ones that we've used in previous videos. Job commands help you manage handlers, your incoming connections. Resource commands are very useful when you want to automate your work. Now, because Metasploit was developed with Ruby, it also provides you a Ruby shell to interact with. And then all the developer commands help you to specialize your Metasploit experience. Now, Metasploit has the ability to use a database, such as MySQL, PostgreSQL. So with database commands, you're going to manage the database operations.
For example, you can import a scan result into Metasploit, or you can export the results. And there's so many more options. Now, while you are conducting a penetration test, you'll probably get some credentials. So that's usernames, passwords, hashes, etc. With creds, you can view, add, or delete these credentials. Of course, you can if you use Metasploit. And now I want to dive into MSF console commands in the next section, so come with me. So MSF has such a wide variety of different commands, and they all have well-defined name conventions that will help you to rule the framework. So let's have a look. Core commands. These are the basic commands of Metasploit. You can use them to make general purpose as well as framework-level tasks. Module commands. They're there to help you move between modules and to pass values to the variables. You can view and use a module with these commands. Job commands are basically used for interacting with your sessions to view the status of the jobs that you've started. Resource script commands allow you to record and to run your own scripts to automate your routines. Developer commands allow you to edit the files and interact with Ruby. Database commands are, like we were talking about before, importing and exporting as well as the connection to a database. With these commands, that's where you're going to save your findings. And the credential commands are used when you activate database, and they help you to store and get credentials found while you're doing your penetration testing. So I chose some sets so that you get the basic idea about how to use them. So why don't we go ahead and jump into Kali to see them in action. Go ahead and open your terminal and just write MSF console. So this time, you see that I don't put the Q as a parameter because, well, I don't want to view that banner. Banners are these funny things here. You can change them every time by typing the banner command. But believe me, that's not the actual fun part. You're going to find the real fun in later modules, but I want to make sure that you're well versed in the basics. So I'll choose to divide the MSF console commands into groups to show you in a more meaningful way and make it clear. So, okay, let's start. Color command will provide a colorful output if you enable it. Now, by default, it is enabled, and you may disable it for whatever reason you like. I'm going to enable it by putting in color true. Now, to view the MSF version, just type the version command. All right, so this is my installation version when I was recording the course. And then beside MSF console commands, the interface allows you to execute Linux system commands. Now, I don't know if it's the same in Windows, but on Linux, you have this flexibility. I can change my directory and view it, or I can check my IP address. But anyway, I think you get the point. So you still have questions about the commands? All right, so type this into the console, and it will help you. Or just put help, and you'll see the same output. Now let's say this is not enough, and you want some specific info about a particular command. Type help, and then the command name. So for example, help workspace. Or maybe help help. There's only so much it can do. Okay, so type help search. And then let's have a look at the search command help output. So this command will really be helpful to find a module. And you're going to use it many times. It's okay. You just stick in a search term and you'll see the results. And as you can see from the help screen, you can also be more specific while you're searching. So let's type in search name Java. Now, that, as you see, will bring up many Java-related modules to the screen. Let's search name Java, rank excellent, date 2011. Okay, so only 3 results. So obviously you can narrow the result by being more specific. Okay, so the next thing is grepping. You can grep the output of this command like this. Metasploit also records your history like bash, so it has a history file. And with the history command, you can view what you have entered in the MSF console, just like that. Here you can see some of my previous commands. But you can also save all the output, not only to history. So look at the spool command. We'll type spool and then the output file name, and then it will save everything. Spool desktop msf.log. So now whatever you see in MSF console will be saved to that file. So let's cat this file. And there it is, it saves everything. Here you might want to type spool stop, but I'm not going to do that now. In a penetration test, you may also configure the Metasploit according to your needs. And you are allowed to save your configuration by simply typing the save command. And then your configuration will be saved to that file. Now here, because I'm not making any change to the default settings, you won't see anything. If you finish your work with Metasploit, you can then quit. By using quit or the exit command, you can close up Metasploit and exit just like that. So now open your terminal and start the MSF console. The first command of this part is show. Now when you work with a module, it helps you to display the variables and properties of that module. So the help screen is for showing us that. Type the show command and then the name of the object. So let's have a look at knob generators by typing show knobs. And as you see, the knob generators list appears. So there's no plugin for this phase. And here are the encoders. And also the exploits. But it might take a little while to list all the exploits if you try to list them. And then here are all the exploits in Metasploit. Now when you need to use an exploit, you can search these exploits. For example, if you want to exploit a Java RMI server code execution, you can search for terms like RMI, RMI registry. So yeah, let's perform a search just like that. Search RMI registry. And you see it brings me the appropriate exploit. So I want to make an important point here. When you are conducting a pen test, you should perform an extensive enumeration on the target to choose the right exploit. That's how you know what to search for. Although Metasploit has many exploits, it doesn't mean that you can use every single one in every circumstance. First, you'll need to find the vulnerability. And then, if Metasploit has a suitable exploit, you can use that. Otherwise, you may have a headache if you randomly run exploits, and it's a waste of time. Okay, so back to the RMI registry exploit. So, now you have the name of the exploit. And if you recall from the previous videos, how do you use this exploit? Type use and then the name of the exploit. Now you can work with that exploit. If you want to be sure about the exploit or if you want to configure the details, you can use the info command to get detailed information about what the exploit's going to do. And in this case, this is an exploit, but for sure it can be any other Metasploit module. So read the description, examine the variables, or follow the reference link to get additional information about that particular exploit. Show the options to view the variables, and these are the basic variables. And yes, you can set some advanced variables to have more control over the exploit code. How do you do that? Show advanced. So, here are the other variables of the exploit to make some of the advanced configurations. Some exploits only work with a specific operating system or software versions, whatever. Now, to send the target the right exploit code, you've got to know the version of what you're trying to exploit. Makes sense, right? I'll assume here that you have made enumeration and you know your target well. So that's what you tell Metasploit. Here you specify the available targets by the show targets command. As I hope you see on the screen, there's only 5 types of targets. So this means that this exploit can't be utilized on environments other than these particular 5. For the most part. In a production environment, your exploit may fail due to IPS, IDS, or firewall rules. So I think it's good practice to evade these security measures. For each exploit, there are different evasion techniques in Metasploit. So let's use the show evasion command to display the available techniques. And if you want, you can choose these. And these are the payloads that I listed by the show payloads command. Now, like evasion, for each exploit, there are different payloads. So this means you can't use a Linux payload for a Windows system. And for this exploit, there are these available payloads. Now I'll show you these variables again, and let's set them. You may remember from some of the previous videos how to set a variable, so we'll do that now. Use the set command, just like that. That's why I like the Linux console. Setting the value of variable means you can get the value of the same variable by simply typing get as the command and then the variable name. This is the Metasploitable2 IP address in my lab environment. Now you can also unset a variable value by using the unset command. And I just unset our host value as you see here. So you may come across a situation that you need to use the same value in every exploit. So you can just set the variable to the same value in each exploit again. If you use set G command, you can globally set a variable value. And by using the get G command, you can get the global value of a variable. And then simply you can unset a global variable by using the unset G command. Now, after setting all the variables, you can get the exploit to execute by either using the run or the exploit commands. It actually doesn't matter. So these messages here show what's going on in the background. And you will also be informed by Metasploit if a session is open. So now I have the session, and by typing the sessions command, I will list my available sessions. And as expected, I have only this one. Now to interact with that session, type sessions as your command with the I parameter, and then an index of the session appears. In my case, it's 3. Okay, so now I'm in the Meterpreter shell. Later, you're going to have your deep dive into Meterpreter, I promise. But for now, I'm going to only show you that I have exploited the Metasploitable2. Then let's type in background to turn back to the MSF console again. Now, when you're finished with an exploit, you can pick another one directly by using the use command like this, or you can use the back and then utilize the new one by the use command. That's pretty much how I work. Then show the exploit options. Now for this exploit, I will define a payload by setting the payload variable, set payload Java, Meterpreter reverse TCP. So I don't set the rhost variable. But in the previous video, I defined it as a global variable. And also there are some new variables under this payload section, lhost and lport, because I chose a reverse TCP connection. which means that after a successful exploitation, the target will connect back to me. So lhost in this context is the IP address of Kali, and lport is the port that is ready to connect to Kali. Its default value is 4444, and I don't want to change that. I will only set the lhost to 10.10.2.11, then set HTTP password to Tomcat, set HTTP username to Tomcat. Now, it isn't necessary, but I can set the target to 0. I forgot the R port. So let's set the R port to 8180. Okay, so let me check it one more time. Okay, yeah, everything looks good. Now, exploit. See, it doesn't take too much time. And I have the Meterpreter session on Metasploitable 2. But this time, let's have a look at the user Tomcat55. It is not the root user. So this means, actually, you don't have a high-privileged shell. So I'm going to send this session to the background by using the Meterpreter bg command. So this is my sessions list in the background. Okay, so I want to show you a couple more commands. Push M and pop M. Push M will push the current module to stack. Now I will push this exploit to stack. Then I can pick another one, RMI registry exploit, and I'll run it, and I get another session. So as you can see here, I am working with RMI registry exploit. With the pop M, I'll pop the last module from the stack, and it's the Tomcat Manager exploit, as you see here on your screen. So I'll advise you to do this because when you're doing some really quick exploitation, those last two commands come in super handy. All right, so I want to get something off my chest I need to share with you. As a penetration tester, it's really important to be organized while testing. Now, you're probably going to find yourself in an information pool, and I don't want you to drown. It contains tons of details like credentials, vulnerable services, targets, scan reports, and the list goes on and on. So it is absolutely essential to keep track of what you've done on the network. So this is why MSF has an option to cover with extensive support multiple database systems. So configuring a database to work with MSF will be a real time saver for you. MSF supports MySQL and PostgreSQL. You can use both. However, PostgreSQL is the default one, which has built-in support within MSF. And by using this feature, you can easily access scan information, export and import results, use the identified information later on in modules. Then you will also be able to keep your findings clean and well organized. So go ahead and open your terminal again. Metasploit can use databases to store information. So you have the option to start without a database. But please, for better penetration testing experience, I do not recommend this. So before starting the MSF console using a database, you need to run a sequence of commands. The default installation of Metasploit framework on Kali uses PostgreSQL. So you should first start PostgreSQL from the Linux terminal by typing in systemctl start postgresql.service. And now the next thing is creating and initializing the Metasploit database in PostgreSQL. For this, you can use the msfdb command, and here's the help screen for it. So let's check the database status by typing in msfdb status, and what comes up is PostgreSQL is running, and msfdb finds a database connection file in the default directory. So if you start msfdb, it will use the information in this file for connecting to PostgreSQL. So I'm going to go ahead and delete that database, and let's create it from the beginning. msfdb delete. for deletion. Okay, so now initialization with MSFDB init. Then start the MSFDB with MSFDB start. Now, actually, when you run MSFDB, it will automatically start PostgreSQL. Therefore, you can only use MSFDB, but this is just my habit. So I'll first run PostgreSQL, then MSFDB. And I'm going to run it in quiet mode. Okay, MSF console opened. Now, in order to do the database operations, MSF console has its own database commands. So let's type in help database to get a look at these commands. And here are some of them. And you can see the names are very clear. Check database status with DB status. And Metasploit connected to default MSF3. So you can change this database. You can even create your own and connect to that. And that is going to be our next goal. And now I want to introduce you to the workspace concept in Metasploit. It's more like working under a project area, I think. So simply type workspace to see the available workspaces. Now here I have only the default one. The workspace command has a help screen. So you can add, delete, and create workspaces with abandon, according to whatever your requirements are. And the V command will list the workspaces in a verbose mode. And I will add a couple of workspaces by using A as my parameter. And here are the workspaces that I have added. Now, automatically, the last one is chosen, as you see here. Now, you can also delete a workspace by using the D parameter. And let's say you want to change your workspace anytime. Just write its name after the workspace command. Oh, I'm already using Pentest 4. Alrighty then. Let's connect Metasploit to our own database. So it is quite easy and I think natural if you want to use another DBMS such as MySQL or another database in PostgreSQL. So I'm going to change the current database to another one in PostgreSQL. But before I do that, I need to create a database. So these are my workspaces, but I'm not going to need them now. So I'm going to disconnect from the MSF3 database. Then exit from Metasploit. Now, I think it's good practice to stop PostgreSQL for a while, then start it again. But this is just one of my old habits that I pass on to you. Okay, so now I'm going to get the full name of the PostgreSQL user by these commands. The name is Postgres, type SU, Postgres, to get into PostgreSQL user shell. Now here you're not going to need a password because the default installation there is no password. Now the logic is the same if there is a password, you will need to type it. Alright then, list databases with PSQL L, and here are the databases. So now I'm going to create a user first by using the create user command. Create user, user for MSFP. I'm going to enter my very strong password 2 times. And now let's create a database by create DB. That's the command that is owned by the user for MSF that we just created. So create DB, DB for MSF, owner equals user for MSF. All right, so let's list the databases. And sure enough, here I have the database. So I am now finished with Postgres shell, and I'm going to exit. And I'll open MSF console in quiet mode again. It's finally open. And let's just quickly check the DB status. So as you can see here, it connects to the default database. So now I'm going to disconnect from that database, and that's successful. Now I'm going to connect to my new database, DB for MSF. DB connect user for MSF 1234 at localhost 5432/db4msf1234 is my strong password, as you can see. All right, so now let's check the status of the database. Okay, good. So here you see that I have connected the new one. And you can now work within the workspaces. Add, delete, choose. It's all on you now. So I'm not going to lie to you. Sometimes you're going to hear words like active exploit or passive exploit, right? Basically, exploits in the Metasploit framework are divided into two categories, active or passive. So, what does that mean to you? Active exploits will exploit a specific host, run until completion, and then exit. For example, brute force modules will exit immediately when a shell opens, and execution of the module stops if an error occurs. Oh, and by the way, you can force an active exploit to work in the background by entering J into the exploit command. And of course, on the other hand, passive exploits wait for incoming hosts and then exploit them as they connect. These exploits almost always focus on clients, such as web browsers, FTP clients, and all those. And they'll report shells as they open. Now you can list open shells by entering I with the sessions command. Also, by adding I with the sessions command, you'll be able to interact with the intended shell. Metasploit framework ranks the exploits to help you find the appropriate exploit. And I'll show you all the ranks and their meanings. Excellent. The exploit will never crash the service. This is the case for SQL injection, CMD execution, RFI, LFI, etc. There's no typical memory corruption exploits should be given this ranking unless there are some extraordinary circumstances. Great. The exploit has a default target and either auto-detects the appropriate target or uses an application-specific return address after a version check. Good. Exploit has a default target, and it is the common case for this type of software. Normal. The exploit is otherwise reliable, but depends on a specific version and can't or doesn't reliably auto-detect. Average. The exploit is generally unreliable or difficult to exploit. Low. The exploit is nearly impossible to exploit, or I'd say under a 50% success rate for common platforms. Manual. The exploit is unstable or difficult to exploit and is basically a DOS. So this ranking is also used when the module has no use unless specifically configured by the user. Information gathering or enumeration or reconnaissance, whichever suits you best. Depends upon what spy movies you've seen. In any event, they all define the same concept, that this phase is the initial stage of penetration testing lifecycle. So reconnaissance should be one of the most critical aspects of a successful penetration test for you. This phase involves identification of various software and services running on the target. Now, I'm serious here. The first step for you to take while penetration testing is to figure out which particular version of the software is running on the target. Then you will have a wealth of intelligence about your target by following comprehensive information gathering and enumeration. And that's how you decide specifically which attack is good for you to compromise the system. Now, you may be tempted to immediately launch an automated tool. However, I really do think that these attempts are less likely to help you to compromise the system. Failing in this phase might waste your time and also makes you go around attacking machines randomly. So this isn't something that's good, and believe me, you don't want to do it. So the MSF has enumeration capabilities, and it provides you with many auxiliary modules for performing information gathering. So in order to do that, in this upcoming section, I will be exploring a variety of auxiliary modules within the MSF, so pay attention. And what I'm going to do is enumerate the services that use various protocols, such as TCP, UDP, FTP, SMB, SMTP, HTTP, SSH, and a bunch of others. SMB, which stands for Server Message Block, is a protocol for sharing files, printers, serial ports, and communications abstractions such as named pipes and mail slots between computers. In addition to that, Samba is a freely available SMB server for Unix. It's an implementation of SMB for Unix-like systems. SMB can run directly over TCP ports 137, 139, 445, or on UDP ports 137 and 138. Now, some versions of SMB protocol has known vulnerabilities, so you should enumerate the SMB services. Now let's step back into the lab to use MSF modules for SMB. All right, so you have made a scan over Metasploitable 2 and 3. To check to see if the SMB port is open, type the services command with a P parameter and SMB port numbers 139 and 445. And the ports are open on both machines. MSF has a meaningful directory structure, so you can find SMB-related auxiliary scanners under this directory. You're not going to need to write every word. Just hit the tab button to complete the commands. Now, the basic logic behind the enumeration is service banner and version detection. So that means I will first run the SMB version module, show options, and set our hosts to our target's IP addresses. And then you can run the module. That module executed very quickly. But look at that, though. It does bring some really good information about the targets. So as you can see, 10.10.2.10 is a Windows Server 2008 R2 Standard Service Pack 1, which is Metasploitable 3. Now, on the other hand, Metasploitable 2 has Samba. Now, why is the version detection important? I hear you saying and scratching your head. Well, let's have a look at the Samba version. This version of Samba has a vulnerability. Even Metasploit has an exploit for this. So, I think you get the point. But just one more point here. Metasploit saves this information to improve your penetration tests. So let's type hosts as our command with C as the parameter. Now you see, Windows 7 changed to Windows 2008. So now let's go with another module. You can try all the others, but I'm going to choose SMB MS1710, show the options, set the rhosts variable, and run the module. And it looks like Metasploitable 3 is vulnerable to MS17 through 10. So let's Google this vulnerability, shall we? There are many topics about this vulnerability, and Metasploit has an exploit module for that particular vulnerability. So that's a good way, I think, to illustrate how enumeration gives you better results. So make a note of this vulnerability. You're going to need it later. Okay, so let's go back to the MSF console. All right, so this is the last one. This is the SMB login module. I will immediately set our hosts. Now, I'll need a dictionary file to brute force. So in a new tab, I will create one. For this, you can use the cool tool. It's really simple and very handy. D for how deeper to crawl a target page, and M for minimum character numbers for words in the dictionary, and then the name of the output file. So here I'm going to use the address of the GitHub page of Metasploitable 3 as the target page that cool will derive the words from. So this process can take way too much time, but I'm going to stop it here because the dictionary file has already been created. So let's go back to the MSF console and use it. I'll set the SMB user to vagrant, set the pass file to that dictionary file, and then run the module. So I'm going to interrupt the execution. Did you see at the beginning of the output, did you notice the green color? That's because you need to enter the pair vagrant. Okay, so that's what we need. So make a note of that. Now, SMB reveal is the valuable information that you get. MySQL is one of the most used databases, and it's almost in every network, either for production or for development purposes. Out-of-date or poorly configured MySQL installations may allow you to get in the system. So, your first step is to discover the version. MSF has a couple of modules for MySQL. So let's have a look at them and gather information from the MySQL server in order. So do you remember, as I do, that there are MySQL databases in the result of the db nmap command? So then, how do you view it? I can view it by going to Services, P3306, entering that command, and sure enough, there they are. So there are some useful auxiliaries in Metasploit for MySQL, and you can search it like that. So here they are. And like always, I will start with version enumeration, although Nmap already did it. Show the options. Just going to set our hosts as my variable. Show options. And run. Yeah, it's executed quickly, and the result is the same as the db nmap command. So check this out. Now I'm going to use the MySQL login module. Show the options. And the rhost's value comes up globally. And there are some file variables, as you can see. And I'll set blank passwords to true. So the module will try blank passwords also. So I'm going to start a brute force in just a little bit, but I first need to create a dictionary file specialized for MySQL. And to accomplish this, I'll search on the internet for a reasonable dictionary file, or you can also create one by yourself like we did earlier. But I just want to use the related words like this. So here in the second row, there's a GitHub page. And under default credentials, you will see a MySQL default password file. So I'm going to copy that and say thank you to the owner of the page. Okay, so I'll save it in a file in Kali. And I'll save it here in the desktop. I think I did that before. So let's go back to the MSF console. Set the user pass file variable to the file that you've just created. Okay? Then run. And I think you can catch some user password pairs. So you should make a note of this finding because you will need to use this one later. Okay, so this means that you're really starting to discover and understand your target system. Let's get into the next one. Now, as you probably already know, File Transfer Protocol, or FTP, is used for the transfer of files between a client and a server using port 21. Poorly configured FTP servers can be a good foothold. So, you can run some MSF modules to enumerate FTP servers and gain some important information such as software version, banner info, and all that. Aside from this, the FTP servers authenticate users with a clear text sign-in mechanism. Moreover, it can sometimes allow anonymous login. So why don't we enumerate an FTP service? So let's have a look and see which hosts have FTP services. All right, so both of them have. But sometimes administrators use different ports for the services. So let's try a search with the S parameter. And just like that, you can find all the FTP servers that db nmap command discovers.
And yeah, as you see here, there's an FTP service running on port 2121. And then you'll get this list if you search for FTP auxiliaries. And I'll just use these ones here. Use auxiliary scanner, FTP, and FT version module. Show options. Nothing set. So let's run the module. And there's the results. Now you can do the same process for every FTP port, but here's an important point. If you get the version, look for vulnerabilities on the internet or somewhere else. So what I'll do is I'll copy and then search Google or whatever your favorite search engine is. And you see VS FTP has a vulnerability for this particular version. And even Metasploit has a module for this. So make a note of that because you will use it later. Oh, and by the way, this is a lab environment, remember, but the logic is 100% the same as in any real penetration testing. So I'll use another module, FTP login, showing options, and here are the file variables. So I'm going to allow blank passwords and username as password. And here I'll set user pass file to my FTP dictionary file. And I'll create this list from the same address that I did for MySQL. All right. Run the module. And I think you'll probably find one pair. So make a note of that too. Now, one more module. Some FTP modules allow for anonymous logins. So when you perform a vulnerability scan, you probably are going to get this finding. But you can quickly check to see if any of the discovered FTP services allows this. That's why this module is so handy. Show options. Okay, so I'll need to configure nothing, so I'll just run the module. And the result comes up pretty quickly. So yeah, you can connect this FTP service on Metasploitable 2 anonymously. So now that we got the hang of that, let's enumerate some other services. SSH stands for Secure Shell and works on port 22. It helps administrators make operations over an encrypted channel. Now, although SSH might come in handy when you want to access remote systems, sometimes, but not so often, but it's good to be aware of it, SSH itself can have some configuration vulnerabilities. So let me just quickly show you an example of a poorly configured SSH server. So first let's search for SSH auxiliaries. There aren't too many modules. And I'll follow the same sequence that I did in the previous videos. And I'll try to discover the version, the users. So I will pick SSH version as my first module. Show the options. Now, because I set the rhosts variable as global, the value is automatically assigned. And there's nothing changed here, so let's run the module. And here's the result. So it contains more details on the SSH services on both machines. You should also make a note of that. Now, I don't want to look for vulnerabilities for these versions, but you can if you want to, and test them in the lab environments if you find any. So, okay then, I'm going to use SSH login as my next module. Show options. And I will allow the user name as password and accept blank passwords. Now, I won't create a dictionary file again. So I'm going to use the file that I created for FTP. And I don't think we need anything more. So let's run the module. Now, here I get a username password pair. Vagrant, vagrant. Remember that also. And then Metasploit automatically opens a session for us on port 22. So now we can interact with that session. So now let's enumerate the next service. HTTP
is a stateless application layer protocol. Generally uses TCP port 80 and exchanges data over the World Wide Web. You can fingerprint the HTTP service and gain a whole lot of information about the target system. To accomplish this, MSF has some HTTP modules. Now, besides MSF modules enumerating the HTTP service information, they will also help you looking at backup files on the web server, listing directories, checking the validity of SSL certificates presenting on the web server. But mainly, reconnaissance-related auxiliary modules will be listed under the Auxiliary Scanner HTTP. And one more thing about the ports is that HTTP uses 80, and when it comes as HTTPS, it uses port 443. But both ports are not mandatory. Why is that, you ask? Well, administrators can easily change the port that the web application is served on, so be careful. You may see a web app serving on port 6500. That's nothing new for a pen tester. So let's jump into a practice session. So I think you probably have many HTTP services running on your targets. So let's view them using the services command. And you see there are a lot of HTTP services. And let's have a look at the port numbers. In the real world, it is the same. But here, there are only HTTP services, right? So I can also look for HTTP with SSL, like this. There, another port number comes up. And just like I did before, I will search for HTTP-related auxiliaries. Whoa, okay, so there are too many modules. Some of them are for applications that use HTTP or HTTPS. So it's kind of hard to find some of the core modules for HTTP itself. So why don't we make a short list? That's going to be a handy shortcut for you to start with enumerating HTTP. So let's go back to services. Okay, so now I want to show you something. Look what you have here. A web dev service. Now, this might look kind of old school to you, but you can see in the local networks. This is Metasploitable 3. A web dev service is also available on Metasploitable 2. So you can use all these modules in the lab to improve your skills, but I'll intentionally choose HTTP put module. Show me the options. Right, so this module will use HTTP put as the method to test if the web server allows for uploading a junk file. But the module wants a path variable. So I can try every possible path on the server. Let's try to find a reasonable path. So at this point, I'll use another module, crawler. And then this module will crawl pages and list the paths on the server. Show me the options. And I'll quickly set the variables. Our port to 8585. All right, so let's check. And run the module. So as it finishes up, you have discovered a few paths. And here, the uploads path probably is what you were looking for. So what I'm going to do is I'll use this path, and I'll turn back to the HTTP put module. Show the options again. Just going to set our hosts as my variable. Set path to uploads. Everything looks good. So let's run the module. And it happens very quickly. There it is. You're successful. So now you can upload a malicious file to the web server and call this file to get a session on the server. So if you follow the link, you will get this page. And this proves that one can easily upload something to the server. That is what a vulnerability is. The Simple Network Management Protocol, SNMP, is used to query network devices for information such as bandwidth utilization, collision rates, and a whole lot of other information. But it doesn't only provide network management and monitoring capabilities, but it's also capable of changing the configurations on the host, allowing the remote management of the network device. Yes, I can tell this gets you excited, huh? My young apprentice. And you are right. So SNMP servers can offer considerable information for penetration testers to perform reconnaissance on a specific system. You may also see SNMP installations on some operating systems to specify information such as CPU utilization, free memory, and so on. It's often automatically installed on many network devices with public in the read string and private in the write string. On Windows-based devices by poorly configured SNMP, you can extract patch levels, running services, usernames, uptime, routes, and, well, so much information that it'll totally level up the penetration test for you. So let's use the services command to search for SNMP service. And yes, indeed, you only have to open the SNMP port on Metasploit 3. The version is 1. SNMP version 1 and version 2 both have proven security flaws. But SNMP version 3 is improved with encryption, as well as better check mechanisms. But anyway, I'll search for SNMP auxiliaries. And this time, I'm going to start with SNMP enum. Show me the options. Oh, and by the way, the community strings are essentially passwords that are used to read or write information to a device. So if the SNMP version is right, and you guess the community strings, the SNMP itself can allow anything from excessive information disclosure to full system compromise. Let me give you an example. If you get the read-write SNMP community string for a Cisco router, you can download, modify, and upload the configuration to the router with a backdoor. So here, I'm not going to change the community variable. I will just set the port to 161, and yeah, everything looks quite good. Now I'll run the module. So as you can see, SNMP brings all the information about the target, Metasploit 3. From running applications to network interfaces, service information, device information, user enumeration, nearly everything about the target. SMTP serves on port 25, and it's used for sending and receiving emails. So this service has two interesting commands that reveal information about the mail server users. They are EXPN and VRFY. There are numerous ways to get names with these commands, but let's go and check out the MSF auxiliaries. So these auxiliary modules probe the SMTP server on the target for the version and then list the SMTP server users. So you have a SMTP port open on Metasploit 2. Services, SMTP, and here's the info. SMTP verify, that's a command that helps you to check for users. And before using any module, I want to show you that from the MSF console tray, you can connect SMTP service on Metasploitable 2. Telnet 10.10.2.10.25, and the connection's established. So, verify admin. There is no admin. Verify Metasploit. Okay, no user with that name. Verify MSF admin. Okay, yes, so I found one username. Verify root. Yeah, second username. Verify administrator. Okay, no user with that name. Verify sys. Another correct username. I think you get the point. Because without any vulnerability, you get usernames. Exit telnet. Oops, quit telnet. Okay, so as always, search for SMTP auxiliaries. And first, pick SMTP version. Show options. Okay, so I will set our hosts to 10.10.2.14 and run the module. So this is the SMTP service banner. Now let's pick another module. SMTP enum. Show options. And I will very quickly set our hosts. So let me check if everything is fine with all the variables. Okay, so set threads to 10 and run the module. Okay, so I think I have a problem with module execution. Did you catch it? Because it lasts a whole lot longer than it ought to. So let's set threads 1 again and run the module. And this time it works. And here are the SMTP users. So make a note of these users. You're going to be able to use them in the brute force dictionaries. In this lesson, we are going to learn how to perform DNS enumeration with Nmap. So first of all, of course, what is DNS enumeration? In fact, what is DNS? Good question, so I'll answer them. So DNS, the domain name system, works at the application layer level of the OSI model. DNS is a system, and it's used to convert a computer's hostname into an IP address on the internet. For example, if a computer needs to communicate with the web server hackeracademy.uk, your computer needs the IP address of the web server hackeracademy.uk. It is the job of the DNS to convert the hostname to the IP address of the web server. DNS uses both UDP and TCP. Now, of course, if you need more information about this, you can just visit our DNS lesson in section 2. So DNS enumeration, it's one of the most popular discovery tasks available to create a profile of your target. It's the act of detecting and enumerating all possible DNS records from a particular domain name. This includes host names, DNS record names, DNS record types, TTLs, IP addresses, and a little bit more, depending upon how much information that you're looking for. So after DNS enumeration is complete, unauthenticated users can then use this information to observe internal network records and obtain useful DNS information that allows the attacker to access a complete DNS map. Now, of course, there are many ways to perform DNS enumeration. Nmap has multiple scripts for DNS enumeration, as you can see here. These scripts will try to get information in other ways as well. So in this lesson, we are going to use DNS brute as well as DNS zone transfer scripts. So let's have a look at these scripts and how do they work? Well, first, the DNS brute will attempt to enumerate DNS host names by brute force, right? Guessing of common subdomains. Second, zone transfer. Okay, hold on. What is DNS zone transfer? So DNS zone transfer, it's also sometimes known by the inducing DNS query type AXFR, These are requests for a zone transfer. In other words, it's a type of DNS transaction. It's one of the many mechanisms available for administrators to replicate DNS databases across a set of DNS servers. A zone transfer script sends a request, zone transfer query, to a DNS server. The area to be queried is determined by examining the name given on the command line, the host name of the DNS server, or it can be specified with the script argument DNSZoneTransfer.domain. If the query is successful, all domains and domain types are returned with common type-specific data. So let's try these scripts. Open up Kali Linux in VirtualBox. Enter username and password. Open terminal. Enter sudo su dash. This will give you root permissions. Enter the root password. Now in this test, we are going to use zonetransfer.me for DNS enumeration because this website is developed just for you to get some experience regarding security problems related to DNS zone transfer. All right. So first we'll try the DNS brute script. So write Nmap -P53 for specifying the port because DNS works on port 53. And then the script name, DNS-brute. So we'll need to specify the domain name because we want to get DNS information about zonetransfer.me. So we'll add the domain argument to the command. And the target DNS server, to find the DNS server of the target, you can use the domain information groper tool. So it's a powerful command line tool for querying DNS name servers. And look at that. You can see that the script shows us the subdomain names. Second, DNS zone transfer script. Write Nmap -P53 for specifying the port and selecting the script name DNS-zone-transfer. And we'll need to specify the domain name, so we need an argument. Write /script-args DNS-zone-transfer.domain zonetransfer.me and the target DNS server. So as you can see, the script shows us the methods, the descriptions, as well as the DNS records about the domain. In this lesson, we will learn how to perform HTTP enumeration with Nmap. So first of all, wait, what? Did you say HTTP enumeration? Yeah, because HTTP enumeration is gathering information from websites and web applications. As the number of web applications on the web server increases, the security vulnerabilities have increased as much, right? So in other words, there's many scripts in the Nmap script engine that can be used in many different applications. And as you can see, if we list all the HTTP scripts, there are plenty of scripts in Nmap script engine to display many vulnerabilities. Okay, so the script that you will use will change according to the technology that you're going to be facing. So for now, we're going to enumerate information from the target. We'll not try to exploit the target. So in this lesson, we're just going to use the HTTP enum script. So HTTP enum is the script that enumerates directories used by popular web apps and servers. So let's go ahead and try this script. So in this test, we are going to use Metasploit 2 for the HTTP enum script. So first we'll run the Metasploit 2 machine. And we'll open Kali Linux in VirtualBox. Username and password. Open terminal. Enter sudo su dash for root permissions. Enter the root password. Write Nmap -P80, and that'll specify the port. /script http-enum and the target IP address. So my Metasploitable 2 machine IP address is 10.0.3.5. Okay, good. So now, as you can see here, we've got the paths of the files and the file names. Normally, if we access the website, you'll be able to see the name of the files on the server. But with a script, we can see more files that cannot be seen directly. So with hidden directories, you can access some hidden information like the Apache version or admin login page and all kinds of stuff. So you understand vulnerability. In this lesson, we are going to learn how to perform MySQL enumeration with Nmap. So first of all, what is MySQL? And then what is MySQL enumeration? Well, I'm sure you might have heard of it, but let me just tell you that MySQL is one of the most popular open source relational database management systems. And it has emerged as the relational database. MySQL is a freely available database system. However, there are a few paid versions where you can use more advanced functions. It's really easy to use compared to other database software like MySQL, Microsoft SQL Server, Oracle Database, and so on. So MySQL can run on multiple platforms such as Linux, Windows, Mac, and an information schema to define and manage your metadata. MySQL runs on port 3306 by default. So then expanding that, MySQL enumeration is going to be getting information about the database, the users, and what kind of knowledge that you are looking for, right? So in this lesson, we're going to use the Metasploitable 2 machine for MySQL enumeration, and we're going to gather as much information as possible from the MySQL server. So first, we'll list out the various Nmap scripts that are available to us regarding MySQL. Cool. So as you can see, we've got a few scripts, and each of them are slightly different. So scripts will depend on the information that you have. So in this lesson, we're going to look at MySQL-enum and MySQL-info. Now, if we do talk about some other scripts, MySQL-databases, for instance, this lists out the tables of databases. And another interesting one is the MySQL-empty-password. It's basically trying to find users that don't happen to have a password. What sort of user would that be? You'd be surprised. So let's try these two scripts and talk about them as we go. First, we'll run the Metasploitable 2 machine. Open Kali Linux and VirtualBox. Enter username and password. Open terminal. Enter sudo su- for root permissions. Enter the root password. All right, so let's start with the first script, which is MySQL info. So this script will show us basic information about the MySQL server. So we'll write nmap -p3306. That'll specify the port address, /script for choosing the script MySQL-info, and the target IP address, which is the Metasploitable 2 machine. All right, so as you can see, it'll give us this information regarding the MySQL server. It gives us the protocol version of the MySQL server. So you see that this can be very performative for vulnerability analysis. It also gives us the capabilities listed here. Supports authentication and transactions, and it gives us SALT. So it's very useful information when you're dealing with passwords. So let's try the second script, which is going to be MySQL-enum. And again, we'll write nmap -p3306 to specify the port address, /script to choose the script MySQL-enum, and the target IP address. Now, it'll try to perform valid user enumeration against MySQL server using a bug that's been discovered. So this script performs like a brute force. The difference between the MySQL brute and MySQL enum is MySQL enum tries to log in using a vulnerability. All right, so in this lesson, we've learned how we can gather information from MySQL using Nmap. So in this lesson, we are going to learn how to perform SMB enumeration with Nmap. What is SMB? Well, SMB stands for Server Message Block. It's a protocol for sharing resources like files and printers. In general, any resource on a server. So, it runs on port 445 or port 139 by default, depending on the server. It's natively available in Windows, so Windows users don't need to configure anything extra, just besides the basic setup. In Linux, however, it's a little different. In order to make it work in Linux, you've got to install a Samba server because Linux natively does not use SMB protocol. So then, how can we enumerate SMB? Well, there are a couple of ways that we can do it. The first obvious flaw is using default credentials or easily guessable and sometimes even no authentication for access to important resources on the server. The second flaw is the Samba server itself. Samba servers are notorious for being tremendously insecure. So then, what scripts does Nmap provide to us? Well, we're going to list all the scripts about SMB. And as you can see, there are a few scripts in NSE. So in this lesson, we are going to perform enumeration Metasploitable 2 machine for SMB protocols, SMB enum shares, and SMB OS discovery. So let's go ahead and try these scripts. So first, let's run the Metasploitable 2 machine. Open the Kali Linux in VirtualBox. Enter username and password. Open terminal. Enter sudo sudo- for root permissions. Enter the root password. Okay, so let's start with the first script, which happens to be SMB protocol script. So this script will show us basic information about the SMB. So write nmap -p445 so that we can specify the port, and -- for choosing script SMB-protocols. And of course, the target IP address. And what we're looking at here, the server is running NTLM. And this is the version, which is SMB version 1. So it's dangerous by default. So again, we've got to say that this gives us information on how we can act on it, what kinds of exploits that we can run. So this script gives us that initial idea. Now the second script is SMB OS discovery. So write nmap -p445 to specify the port address. -- for choosing the script SMB-OS-discovery and the target IP address. Now this script gives us information about the operating system that's running on the target machine. The server is running Samba, and here is the computer name. The third script is SMB enum shares -p445 for specifying the port address, -- for choosing script SMB-enum shares, as well as the target IP address. So this script lists out all the shares active on the target. It also lists out permissions as to whether or not we can access those shares remotely or directly with or without credentials. So as you can see, the script lists out the shares that we can have access to. What do you think? It's a virtual gold mine. So in this lesson, we learned what SMB is and how we can perform SMB enumeration. So in this lesson, we're going to learn how to perform SNMP enumeration with Nmap.
What is SNMP, you might say? Well, SNMP is also known as Simple Network Management Protocol. And as the name suggests, it is a simple application layer protocol that helps a network administrator while managing the network. So it's by using SNMP and its basic information, such as the temperature of the devices on the network, such as the router, the switch, the access server, the bridge, and even the computer, and the users connected to the device, the internet connection speed, device operating time, all of this info can be obtained. So SNMP is running on port 161 by default. So, SNMP enumeration, what's that? Well, the SNMP enumeration process enumerates user accounts as well as the devices on a target system using the SNMP. So SNMP consists of a manager and an agent. Agents are embedded on every network device, and the manager is installed on a separate computer. So attackers enumerate SNMP to extract information about network resources such as hosts, routers, devices, shares, and all that, as well as network information such as ARP tables, routing tables, traffic, just about everything you can think of. So why don't we go ahead and list out the various Nmap scripts that are available to us regarding this SNMP. Okay, so as you can see, we've got a few scripts, and each of them are slightly different. Scripts will depend on the information that you have, but in this particular lesson, we are going to look at SNMP processes, SNMP netstat, and SNMP interfaces, as well as SNMP sys description. All right, so let's get started. We'll try these 4 scripts, and then we'll talk about them. In this lesson, we are going to test the IE8 Windows 7 machine that the SNMP service is running. So we'll first run the IE8 Windows 7 machine, open Kali Linux and VirtualBox, enter username and password, open the terminal, enter sudo sudo- for root permissions, and a root password. So let's start with the first script, which is the SNMP processes script. This script attempts to enumerate running processes through SNMP. So we'll write nmap -su for UDP scan, -p161 to specify the port address, and --script SNMP processes for choosing the script. And the target IP address, which is 10.0.3.7 of my Windows 7 machine. Okay, so as you can see, the script lists out the running processes through SNMP. The second script is SNMP netstat. The script attempts to query SNMP for a netstat like the output. The script can be used to identify and automatically add new targets to the scan by supplying the new target script argument. Write nmap.su for UDP scan, -p161 for specifying the port address, --script SNMP-netstat for choosing script, and the target IP address, which is 10.0.3.7 of my Windows 7 machine. Cool, so what you're looking at is the script showing us the active netstat output. The SNMP netstat shows the values of different network-related data obtained via the SNMP protocol from a remote system. The third script is SNMP interfaces. The script attempts to enumerate network interfaces through SNMP. The script can also be run during Nmap's pre-scanning phase, and it can attempt to add the SNMP server interface addresses to the target list. That's pretty cool. So write nmap, S, of course, capital U, for UDP scan, -p161 for specifying the port address, --script SNMP-interfaces for choosing a script,
and the target IP address, which is 10.0.3.7 on my Windows 7 machine. So as you can see, the script shows this information on the network interfaces on the host, like MAC address, type of card, traffic status. Oh boy. So the fourth and last script is snmp.sysdescript, or DESCR. So the script attempts to extract system information from an SNMP service. So we'll write nmap -S capital U for UDP scan -P space 161 to specify the port address, /script SNMP-SYS DESCR for choosing a script. And of course the target IP address, which is 10.0.3.7 on my Windows 7 machine. So as you can see with the script, we can see the system uptime, the MAC address, software version of the SNMP service, as well as the hardware type. All right, so there you go. We've learned what SNMP is and how we can enumerate it.
To compromise the victim systems, we prepare some malicious software and force the victim to run the malware into their systems, so we can open a backdoor or steal some data or gain a session, etc. Before talking about the customer payload creation, we need to see a few terms to make the subject clearer. Most likely you already know the terms we'll talk about in this slide. If so, just jump to the next one. Malware. It's a short form of the term malicious software. It's a kind of software that's used to compromise the computer systems. It's an umbrella term used to refer to a variety of forms of hostile or intrusive software, including computer viruses, worms, Trojans, ransomware, spyware, adware, scareware, and other malicious programs. It can take the form of executable code, scripts, active content, and other software. Payload, inside malware, is the portion of the malware which performs malicious action. Metasploit framework is one of the most known terms in the cybersecurity domain. As the open-source sub-project of the Metasploit project, Metasploit framework is a tool for developing and executing exploit code against the target machine. Even though they're depreciated and removed from Metasploit framework, I'd like to talk about MSF Payload and MSF Encode first. They're depreciated because their abilities are collected into a single tool, MSF Venom. To understand what MSF Venom does, it's better to talk about MSF Payload and MSF Encode first. MSF Payload was a command line tool that's used to generate and output all the various types of shellcode that are available in Metasploit. Using MFS Payload, you can create an executable file, as well as creating a payload to embed the file. The parameters displayed in the slide give us some more about what the MSF Payload does. Most of the time, one cannot simply use shellcode generated straight out of MSF Payload. It needs to be encoded to suit the target in order to function properly. This can mean transforming your shellcode into pure alphanumeric, getting rid of bad characters, or encoding it for 64-bit target. It can also be instructed to encode shellcode multiple times. Output the shellcode in numerous formats, C, Perl, Ruby, and one can even merge it to an existing executable file. So most of the time, this tool was used in conjunction with MSF Payload. MSF Venom is the Metasploit's standalone payload generator. It's the combination of MSF Payload and MSF Encode, putting both of these tools into a single framework instance. That means MSF Venom is a combination of payload generation and encoding. You can do everything that you can do with MSF Payload and MSF Encode. You can generate a payload, encode the payload, avoid the bad characters, use a custom template, and more. Let's see how we can create a basic malicious Windows executable using the MSF Venom tool. 64-bit Windows 8 is the victim system. Choose an executable to use as a template. The output malware will be the same size with this template file. I'm going to use putty.exec file as the template. Let's copy putty.exec to Kali to work on it. First, look at the IP address of the target machine here, Kali. You can use WinSCP tool to transfer a file from a Windows system to a Linux system. SCP, Secure Copy, is a means of securely transferring computer files between a local host and a remote host, or between two remote hosts. It's based on the SSH, Secure Shell Protocol. Now, since WinSCP uses SSH protocol, you'll be sure the SSH service is running on Kali. Check the status of the SSH service using the service SSH status command. It's already active on my Kali. If it's not running, use service SSH start to start the SSH service in your Kali machine. If you try to log in WinSCP using root user, you may see the access denied message. That means using SSH service with root user is denied in your Kali machine's SSH service configurations. Either change the SSH service config to be able to connect with root user or create a new user to use SSH connections. I choose to create a new user. You can use add user or user add commands on the terminal screen, or user's interface to add a new user. Now, I've already added a user before SSH user for this purpose. You can add a similar user to your system. Connect WinSCP using SSH user credentials. Find the exec file at the Windows side. In this example, it's on the desktop of a current user. Copy it to the Kali machine, in here, to the home folder of SSH user. In Kali, use is command in the terminal screen to see if the file is transferred successfully. Now we're ready to create a malicious executable using the putty.exec file as a template. Prepare the appropriate MSF Venom command. The first parameter is -p, which specifies the payload used. You have to find a correct payload according to your target. Don't forget to choose a payload with the correct platform, correct architecture, correct connection method, etc. You can see the available payload using MSF Venom-L payloads command. There are a lot of payloads available, and since the target machine is 64-bit, we can filter the results using grep command with pipe. We use the Windows/x64/meterpreter/reverse_TCP payload for this example. Let's have a pause here and have a small introduction to the world of Metasploit. Metasploit project is the most used penetration testing framework in the world. It can be used to test the vulnerability of computer systems or to break into remote systems. Metasploit was created by H.D. Moore in 2003 using Perl. By 2007, the Metasploit framework had been completely rewritten in Ruby. In 2009, the project was acquired by Rapid7. Now they have a free and open source version, Metasploit Framework, and a commercial version, Metasploit Pro. Its best-known sub-project is the open source Metasploit Framework, a tool for developing and executing exploit code against a remote target machine. The MSF console is probably the most popular interface to the Metasploit Framework, MSF. It provides an all-in-one centralized console and allows you efficient access to virtually all of the options available in the MSF. MSF console may seem intimidating at first, but once you learn the syntax of the commands, you will learn to appreciate the power of utilizing this interface. Meterpreter, short for the Meta Interpreter, is an advanced payload that is included in the Metasploit framework. Its purpose is to provide complex and advanced features that would otherwise be tedious to implement purely in assembly. The way that it accomplishes this is by allowing developers to write their own extensions in the form of shared object DLL files that can be uploaded and injected into a running process on a target computer after exploitation has occurred. Meterpreter and all of the extensions that it loads are executed entirely from memory and never touch the disk. Let's continue to create a malicious executable using the MSF Venom tool. Now, the first parameter was the payload. We can choose the platform here, Windows, but since we chose a Windows payload, the tool will already understand the platform. Same as the platform, we can set the architecture x64 using the -arch parameter. Because we use a payload for x64 architecture, the tool will already understand the architecture, so we don't need to use arch and platform parameters in this example. The next parameter is -f to determine the format of the output file. Now you can use MSF Venom -help -formats to see the available formats. We only use the exec in this example. Then specify the template file using a -x parameter with the template file. Name the output file with the -o parameter. Now is the time to define the options of the payload. To see the options of the payload, you can use the -payload-options parameter with the payload. We have to define the L-host and the L-port options of the payload here. Complete the command again, output file format, template file, and output file name. Now assign L-host and L-port options of the payload. L-host is the IP address of the listener machine, in this example, our Kali machine. L-port is the port which will be open to listen to the sessions. Hit Enter to create the malware. As you see, no arch is selected. The tool selected x64 from the payload. And no platform is selected. The tool automatically selected Windows from the payload again. To be sure, go to the folder and see the created malware. The attacker should find a way to make the victim accept and run the malware. Let's just copy the malware to the victim's machine at the moment, and suppose that we send it as an attachment to a phishing email. First, let's try to copy the file to the Windows machine while Windows Defender is running. As you can see, Windows Defender recognized the malware. And deleted it in seconds. Can you guess why? Because we used a standard Metasploit payload which is very well known, and Windows Defender recognized it easily. To see the payload in action, let's turn Windows Defender off and send the malware again. As an attacker, we need to listen to capture the sessions of the victims who run the malware. Start MSF console. You'll have a Metasploit framework shell. Search for the handlers. Use exploit/multi/handler for this example. In handler, we have to use the same payload that we use in the malware. List the options with show options command. Set the listener address and port. Since the default port is the same with the port we assigned in the malware, we can leave it as is. And run the handler, it starts to listen at that moment. Now go back to the victim machine and run the malware. Voila! We got the session from the victim machine. Look at the system info using sysinfo meterpreter command. It's a 64-bit Windows machine. Look at the user ID. Meterpreter has a lot of excellent commands to compromise the victim's machine. Use help command to see some of them. Let's take a screenshot of the victim machine. When we list the currently running processes using tasklist command in the victim machine, we see the malware running. You can kill it using the taskkill command with /PID parameter. Use /F parameter to force it to be killed. As soon as the malware process is killed, the meterpreter session dies as well. Using MSF Venom, you can create more complicated malware. Doing this, you may suppose it will not be easy for the security systems to recognize the malware. Look at the examples seen in the slide. You can use -E parameter to encode the payload. You can use MSF Venom-L encoders to see the list of encoders. With the -I parameter, you can encode the payload several times. In this example, it was 10 times. -K is used to preserve the template behavior and inject the payload as a new thread. If you use this option, the size of the output file becomes a bit bigger than the template file. But do not forget that you are still using a standard Metasploit payload. Let's take a closer look at the listener. If you use a payload with a reverse connection, also known as a connect back, you, the attacker, have set up a listener first on your box. The victim or target machine acts as a client connecting to that listener, and then finally you receive the session. Exploit/multi/handler module of Metasploit framework is used to collect and manage multiple sessions from different platforms. You can see the detailed options of the handler using show advanced command. If you set exit on session false, the handler continues to listen when an active session is killed. Set the same payload with the malware and set the option of the payload. If you run the handler using the exploit-J command, the handler runs in the background. When a session is opened, a message appears. Use session-L command to list the active sessions. To activate a session, use session-I command with the ID number of that session. You can use background command to send the session background. Use session-K with session ID to kill a session. If you use -K uppercase K parameter, you kill all captured sessions. Creating custom payloads. The payloads of well-known frameworks such as Metasploit are easily recognized by the security systems. The best way to avoid this is to create your own payload. There are open source and free tools to create your own malware and payloads such as Veil, Avoid with a 0 instead of an O, Syringe, Fat Rat, and Empire. Now you will see how to create a custom payload using Veil Framework. First, let's install it to our Kali machine. If we Google as Veil Evasion, the first link will be the GitHub page of Veil Evasion. This page redirects us to the GitHub page of Veil 3.0. In the README part of the page, we see the quick installation guide. We simply follow the steps of this installation guide. Install Git if it's not already installed. Create the clone of the Veil 3.0 project. Go to Veil folder. Under the setup folder, run setup.sh script with the -c parameter. And this will take a few minutes. In this period, some install wizards are opened. Don't worry, they're all next finish wizards. Now, let's see the Veil framework in action. Go to the Veil folder and run veil.py script. Use list command to list the available tools. We would like to use the evasion tool, so print use one and hit enter. Veil evasion menu is opened. Use the list command to see all available payloads. There are more than 40 different payloads. Let's use Meterpreter payload, which is using a reverse HTTPS connection. Copy the file name with the full path. We'll use it on the next step. Print use 27 to use the payload we selected and hit enter. The options of the payload are listed. Change as many options as possible to make the payload more customized. The most important options here are the address and port number of the listener machine, lhost and lport options. Again, listener will be our Kali machine, so assign the IP address of Kali as lhost. Let the lport remain as 4444. To keep the example simple, I'm not going to change any other option at this point. Now we're ready to generate the payload. Use the generate command for this purpose. Give the base name for the output files. To be more meaningful, I'd like to use connection type reverse protocol HTTPS and the port number that uses 4444 in the file name. And last, it's asking the method to create the executable file from the script code. Choose the first one. Malware is ready as a code and as an executable file, plus an RC file which is used to start an appropriate handler that uses the same options with the malware is prepared. Let's transfer the malware to our victim machine using the WinSCP tool. First, I copy the malware to the home folder of the SSH user. You can examine the generated file using Linux file command. Yes, it's Windows executable. Now, go to the victim machine, run WinSCP, and connect to the Kali machine with SSH user. Before copying the malware generated by Veil, let's turn on Windows Defender. Now, while Windows Defender is running, copy the malware to the victim machine. No, Windows Defender cannot recognize the malware. We successfully copied the malware into the Windows 8 system. Now, at this point, as the attacker, we need to have a listener because the payload of the malware uses a reverse connection. So go to Kali, use Metasploit RC file, which is generated by Veil, to create a listener. Print MSF console-R and add the RC file name with its full path, then hit enter. An HTTPS reverse handler starts on our Kali machine's 4444 port as background job. Now go to the Windows machine and run the malware. A session is opened. Use the sessions-l command to see the open sessions, and the sessions-i1 to enter the open session. Now we have a Meterpreter session on the victim machine, even though the victim machine has a security solution, Windows Defender. Enjoy.